Yeah. Hello, everybody. I am Mickey, and it's my pleasure to invite you here to ReactiveConf 2019. And please, let me introduce to you Pavlina, our Master of Ceremony.
Hello, everyone. It is a great pleasure for me to be here with you today. And as you can probably see, Mickey is truly dedicated to her cause because she even heard herself in the shape of her avatar.
Yeah, you know, actually, coming on stage might seem like a small step for humankind, but trust me, for me, it's a really huge step.
Well, we do appreciate that because we have a reason to celebrate today. Not only we're celebrating all year the 50 years since we landed on the moon, all the planets here, and also 5 years since the ReactiveConf was born. And I do think that that deserves a toast.
Yeah, that's true.
So I believe you guys have glasses. So
Cheers.
Cheers to ReactiveConf and landing on the moon.
And now, it's all yours.
Thank you. Well, our main goal here at the ReactiveConf is to create a welcoming space for everybody, where we can learn and share knowledge about web and mobile developments for the next 3 days. We will discuss topics like ReasonML, Webpack, Closure, and so much more. Reactive Conference is just not only a conference where you can sit and listen like you do right now. We actually want to encourage you to be interactive. We want to encourage interactive environment, communication, space where you can talk to each other, inspire each other, and learn from each other. So we created a special chat zones and workshops and networking events. Here you can see how much fun is waiting for you. I am personally the most excited about the Hangouts at 8 p.m., so I hope I'll see you, all of you there. Here you can see also that we have 2 stages, or you probably realized that already. We have a Millennium stage, which is this one, and we also have Discovery stage. Now, depending on the level of your nerdiness or expertise in certain topics, you can attend your preferred level of tasks. So Mickey explained this to me like this. It's basically like in a restaurant. The level of spice is the level of your expertise or level of your knowledge you want to learn. So the Millennium stage will have the mild and the medium spice, and then the Discover stage will have medium spicy to the super spicy ones. Now, where is the spicy stage? So we can see Millennium stage is right here on the main floor, and then the Discovery stage is all the way up. Now, how do you get there? You will be able to teleport yourself through a secret teleport right there in the back by the social baker stand. Just don't forget to press 3. Here are the chat zones where we're talking about. These are happening on the Discover stage. For the next 2 days, you can chat for 30 minutes with your chosen speaker and pick their brain face-to-face. We created also your personal butler, digital butler, Reactive Mickey, messenger bot. It allows you to ask questions and communicate directly with Mickey. There are 3 ways how to get to Mickey. So, you can go to your Facebook Messenger, it's super easy. Search for Reactive Mickey. If you found it, check in, and you can start chatting. You can also just use the special link where you can see on a stage, or you can also just scan the code, and it will lead you right there. How you guys ask questions. You will click on Q&A button, and the button is on the bottom of the menu, and you can start to ask questions. We also would like to go I'm going to go back a little bit here. So we would like to also ask you to react to your speeches, to the talks you will hear. Please rate the talks because it gives us a feedback that we can improve ourselves and get better. There is a Wi-Fi, so be connected. It's pretty simple. You just get on a Reactive Conference 2019. There is no password, and it works in all stages, both days. Also, you all receive a 5-day transportation pass for the public transportation. So don't hesitate to use it. Take advantage of it. If you haven't been in Prague, it's beautiful. If you've been here, you know it's beautiful. So see it. We couldn't have done this without our partners and friends. So big thank you to all those amazing companies that you see behind me. And some of them prepared, or most of them prepared something very special for you. So go to their stands and join in their activities, win, and discover. Now, this is my most favorite part, Reactive by Night. We obviously we'll learn so much today during the talks, but also it doesn't end by the last talk tonight. There will be a whole bunch of activities happening. There are parties by our partners. There is a sightseeing tour for you. Just remember, the conference is happening tomorrow too, so don't go too hard. All your questions about all the fun stuff that is happening tonight can be answered by our night Omar, who will be moving around, and you can ask him anything you want, but also you can call him on this phone. Thank you so much for being here, and thank you for writing this story with us. There is a book right there, where our space journal, where you can write or draw something for us, if that's your thing. Just recommendations, how you're feeling, anything that leaves a footstep of you being here with us today. Don't forget, important, don't forget to trade in your gift cards. You have a bunch of interesting things from our sponsors waiting for you. And also, of course, the public transportation card. The gift card areas will be open throughout both days, so you don't have to run there right now. Don't worry. They're open all day long for next 2 days. Now, as you can see, the gift area is located on the first floor. Now, if you need a little break, if you are a mother or if you just want to simply work on your own for a little bit, we got you covered. Through the community space, you can get to our special rooms. We have a work room, mother's room, or a silent room. Now, where did the Reactive Conf actually came from? Once upon a time, there was a king and a queen, and the labs, vacuum labs. And that's where Reactive Conf was born. It's a company that has a thirst to improve and learn new things, and that's why we are here today. Don't forget to tweet about us. Please post pictures, post anything about your experience here. You can use hashtag #GoReactive, or if you like more difficult way, you can also do Mickey loves you, but with a green heart. We like to make things easy for you. And please, this is very important. Please help us to be better, to do better. Let us know if you see any violation of COC whatsoever. It is extremely important to us that everyone feels welcome and safe here. Let me introduce you to the queen of all questions, Teresa. If you have any questions, if you need any help whatsoever, you can reach her via our Reactive Mickey, via chatbot. But if it's something urgent, don't hesitate to call her. Don't forget, Mickey loves you. And without further ado, let's go. So let me welcome here our first speaker. He is a crowd-funded open source developer, and he will be helping us today to look to the future by reassessing the assumptions of the past. Ladies and gentlemen, let me welcome Benji Gillum.
HDMI. Hello, everyone. My name's Benji. I'm a community-funded open-source developer working in the GraphQL, Node.js, and Postgres ecosystems. It is my absolute pleasure and privilege to be here with you today, speaking alongside all the incredible people that we'll be seeing, talking about the various technologies that will shape the future of software development. There's at least 8 talks, including this one, that relate to GraphQL at this conference. And rightly so. I fell in love with GraphQL 3 years ago, after 15+ years of building and consuming APIs. And my feelings have only gotten stronger. My main open source project is called PostGraphQL. It looks at your Postgres database, and it helps you to build a highly customizable GraphQL API very rapidly. I'm also a contributor to the GraphQL specification working group, and I help to maintain the graphical GraphQL IDE software, and I have various other projects in the GraphQL space. But I'm not the only one passionate about GraphQL. Since its release in 2015, GraphQL has been growing in leaps and bounds, fixing the problems of the biggest and the smallest companies alike. And I'm certain that we will see it continue to grow over the coming years. With its shiny new technology, skyrocketing growth, and huge impact, it makes complete sense to see GraphQL well represented at ReactiveConf. But it might seem strange that my talk is also about Postgres, a relational database system. Even at my age, it seems like relational databases have been around forever. How do they fit into the technologies that will shape the future of software development? Well, it turns out that relational databases have been shaping the future for at least the last 30 years, and are continuing to do so without no signs of slowing down. They are everywhere, from the biggest internet-scale companies to that save game file on your computer. They're in your TVs, on your set-top boxes. They're in your smartphones and in your car's multimedia system. In fact, many of us are wearing relational databases on our wrists right now. The term relational database was coined in 1970, but they really started to get big in the mid-80s. By the mid-90s, they were the dominant technology for large-scale data processing, and they still hold that position today. In the 2000s, as the web began to get more dynamic, it was natural to build our web applications on top of this pervasive database technology. Server-side languages such as PHP would construct the web pages and turn them into HTML and send them over the internet to the web browser to be rendered. Databases weren't really as advanced back then, focusing primarily on their central role of data storage. So many people and engineers would treat the database as basically a glorified spreadsheet, with the columns and the rows and the tables like you have tabs in Google Docs. The application layer, the layer that sat between the end user and the database, written in a language like Ruby, PHP, Perl, or Java, was responsible for implementing the business logic, the access control, and other related concerns. And this worked pretty well. Enter the 2010s, and frameworks like Backbone.js, and later React, Ember, Angular, Vue, and various others began to take center stage. As JavaScript and the languages and the frameworks available within it became more and more powerful, websites started moving their rendering logic from the back end to the front end. Let's look at an example. Imagine that we've built a fully client-rendered blog. For the purpose of this example, we're going to pretend that we're using React on the front end and a Rails API on the back end, but the pattern is similar for many other languages and frameworks. Now we want to add a feature to our blog. We want to give users the ability to comment on our posts. This might look something like this. First of all, we need somewhere to store the data. So we're going to use something like a Rails migration in order to create a database table like this one. This one allows us to have a reference to the post that the comment relates to, the author of the comment, and the text of the comment. We need to represent this database table in Rails, and for that we'll use a model, such as this one, again stating that we have the relation to the post and the author, and noting that certain of these are read-only fields. We shouldn't update them. We need a way of sending this data to the user, and for that we'll use a view, or in Rails, a serializer, to tell the framework how to take this model and to export it to the end user. And at this point, we'll take the opportunity to maybe rename a few fields if they were in snake case and we want them in camel case in our API. We might remove certain fields we don't want exposed or add additional information that might be useful. We need a controller to describe which actions can take place. And we need to expose those actions via something like a router so that our client can actually issue them. Now, parts of this process we've just seen can be templated, but a lot of it requires human intervention, especially later on if we get performance issues. We might get issues like the n+1 problem, or maybe the opposite. Maybe we're fetching too much data, and that's giving us issues. And for that, we may need to consult our old friend, Stack Overflow, and figure out what the best way of solving this problem is. In the client, the story is similar. We need a model to represent this data that we fetched from the API. And in TypeScript, it might look like this. In Elm, it might look like this. But we've probably had to define this model by hand, since we don't have a way to automatically generate it from our RESTful API. We also need to manually write the code that coordinates the fetching of these related data models from the server. And that needs to handle things like chained fetching, network errors, and maybe has something in it like some retry logic, so we can handle those errors and still display something to the user. We also probably need to write the code to handle our mutations. And in order to build those, we need to know what mutations the backend allows, and for that, we'll probably have to consult the backend documentation. I hope it's up to date, and that it tells us what the type of inputs expected are. So we've just written a lot of code, and we're not even going to be able to deploy it anytime soon because of the amount of both manual and automated testing that we need to do to give us confidence in the software that we've written. For a typical web application backed by a relational database, probably about 80 to 90% of your API will be like this. Fairly straightforward mappings from the database types all the way through to the front end. And this is true for things like customers, products, notifications, emails, teams. Very many of your database tables represent your business domain objects. And they are then used throughout the entire stack. Sometimes you might need to add or remove fields from them, or you might need to change the names of things slightly, but overall the structure is very similar. So let's go back to the drawing board and think about what we actually need in our code base in the year 2019. If we minimize the amount of code we need to write, then we can significantly increase the speed at which we can deliver awesome software to our users. The first thing we need is a concise but expressive data definition language to describe what the shapes of our various entities are, what fields they have, what types those fields are, and how do those entities relate to one another. And for that, we've already got our create table statement we've already seen. We also need to describe what actions can take place on this table. In Postgres, we might do this with a grant statement, saying which actions you can do. And this is fine for our basic CRUD permissions, create, read, update, delete. But if we need to go beyond CRUD then there's a way to do that in Postgres by using a function, such as this one, which allows us to flag inappropriate comments. Functions in Postgres can be written in many different languages. SQL, of course, but also Python, Ruby, and even JavaScript in our database. So we've modeled our data types and their relations and the allowed actions on them. But another need that we have is to define exactly which users are allowed to perform these actions and which rows or entities in our database are they allowed to manipulate with them. Now, this is the tricky part. For most of the past 2 decades, there hasn't been a good way of expressing these granular security policies in Postgres. So when people have attempted to solve this problem, they may have used things like views and triggers and functions, or even creating an individual database user for every application user that uses your application. But these methods aren't really a good fit for our modern web applications. They've caused lots of issues and headaches, and this has led many people to say, don't put your business logic in the database. Instead, relying on the application layer to implement these permissions. However, it's key to note that technology advances. It changes and improves. And what was true in the past may not always be true in the future. In fact, the security policies that we need for our modern applications are now a feature that exists in Postgres. It's called row-level security, and it was introduced in Postgres 9.5 not even 4 years ago. Row-level security is very powerful. It finally gives us the ability to express declaratively the granular permission system that our modern applications require. When you define a row-level security policy, the filters defined within it are applied against every table access automatically. And this is not only enforced for directly accessing the table, it's also enforced when you access it through an aggregate, or through a join, or a subquery, or a function call, or any other way that you access that data. And with row-level security, you share just one database role between all your application's users, so it's very straightforward. You can indicate the application user at runtime by just setting a session token in the transaction. So row-level security is very powerful, expressive, and concise. Let's take a look at it. Our first policy starts with the create policy statement, and we give it a name. We want to be able to manage our own comments. It applies to the comments table, and it specifies what actions it governs. In this case, all of the actions. But most importantly, it then gives us a filter. In this case, we want to filter it to only the comments where I am the author. Here we're using a viewer ID function that we defined to find out what the current user's ID is. We might define other policies, like one that says that admins can delete any comment that they want, because maybe it's inappropriate. And also, we have another one that says that everyone can view comments because they're publicly visible. An important thing to note about these is those filters are just SQL fragments. So they can do anything that SQL can do. They can query from other tables in subqueries. They can call functions. They can do various other things. So this looks to be exactly what we need for our modern applications. But when it was first introduced, it often suffered from quite significant performance issues. And this isn't really surprising. Postgres follows a great pattern of software development that you may all be familiar with. Make it work, make it right, and then make it fast. In 2016, with the release of Postgres 9.5, they'd achieved the make it work part and a fair amount of the make it right part. But it wasn't until the release of Postgres 10 in October 2017, just 2 years ago, that they made it fast. The legendary Tom Lane significantly improved the query planner so that well-written row-level security policies no longer have a performance penalty. So we've seen that the past can be informative, but it can also be misleading. Anyone who analyzed putting your permissions logic and your business logic into the database before this October 2017 release and found that it wasn't really a good fit was probably right. But this is a conference about the future of software development. It's time to reassess these outdated conclusions. With new legislation such as the GDPR, privacy in the news frequently, and major security breaches seeming to happen all the time, it's becoming more and more important to protect your users' data. Why settle for putting all of this data in a big vault and hoping that no one gets in, or that anyone that you let in behaves responsibly, when instead when in addition you can also have each piece of data have its own protection? With row-level security, if an attacker gets a direct connection to your database, they still can't access other people's data. That's really incredible. So we've learned that the SQL of 2019 can do a lot more to protect user data today than it could in the past. But there are many reasons that we don't want to expose SQL to the client directly. Not least of which is because it doesn't fit the concerns and workflows that web application developers have. They'd still need to abstract this data access, like they do with typical REST APIs, in order to perform their everyday tasks. Can we remove the need for this layer of abstraction with a well-designed API? I think we can. Enter GraphQL. GraphQL encourages us to think in terms of the different entities or nodes in our business domain, their properties and how they relate to each other. These nodes, their properties and the relations between them form a graph, hence the name GraphQL. The query language, the QL, allows the client to query this graph using a query such as this one, retrieving all the data they need and only the data they've requested in a single query, eliminating both under and overfetching. But more importantly, since we can get all the data that we need from the API in a convenient domain object-oriented shape, we typically no longer need the client-side models in order to wrangle it into a more useful structure. We can just use it directly. And because GraphQL is strongly typed and introspectable, our editor can look at our GraphQL API, and it can give us a type ahead to build our query. It can even tell us when we've made a mistake, or show us our documentation right there in line. But it gets better. This query, which we wrote in next to no time thanks to autocomplete, can be automatically converted into type-safe code for fetching the data, using something like the Guild's GraphQL code generator. To use this query in a React component could be as easy as this single line of code. This reduces the amount of code that we need to write quite significantly. It makes it easier to write that code, and it eradicates entire classes of errors thanks to the increased type safety. However, building a GraphQL API can be time-consuming, and it has a lot of performance pitfalls you need to be aware of. But this is where the power of Postgres comes in again. Thanks to Postgres' powerful features and strict contracts, we can look at the database and automatically build a GraphQL API by looking at the tables, the relationships between the tables, the indexes on those tables, the data types of our columns, and the constraints, the functions, and the permissions, and anything else that we see in the database. Of course, we don't want to expose every structure in our database, but we can use permissions, hinting, or even explicit instructions to govern what is exposed via our GraphQL API. So a significant amount of our GraphQL schema can be generated from our database, massively reducing the amount of code that we need to write. But this is only one piece of the puzzle. We mentioned before that this is probably only going to work for about 80 to 90% of our domain objects. We also need to be able to add extra types and fields to better express our API. For example, adding custom mutations, or enabling access to services beyond our database, or even integrating with third-party APIs, such as a payment provider. PostGraphQL enables you to accomplish this with schema extensions, or through its powerful plugin system, which enables comprehensive manipulation of how the GraphQL schema itself is generated. Now, once we've got all of this in place, adding this commenting feature to our blog application becomes much more straightforward. In the database, we model the data and the relationships with our table statement. We then outline the actions that can be performed on our table with the grant statement, and we indicate which users may perform those actions with the policies. In the front end, we then write the query that describes all the data that's necessary to render the page. And finally, we write that single line of code that runs the query and fetches the data in a type-safe way. And this is all the code required to model comments and their permissions, and for the clients to fetch them. When the client wants to do mutations, it will be similar to the code on the right-hand side. So we don't need to write by hand the controller logic, the serializers, the routers, the server-side or the client-side models, the data fetching logic, or the cache updating logic. We can solely focus on the parts of the application where our efforts add value, because everything else is standardized and automated. And the icing on the cake is that both GraphQL and SQL are declarative rather than imperative or functional languages. So we can see the entire action that needs to take place ahead of time, and we can plan accordingly. For example, our automated API might turn a GraphQL query such as this one into an SQL query such as this one, fetching all of the data that is needed, and only the data that is needed, in just one query. This allows us to offload the complex task of figuring out how to retrieve the required data in the most efficient manner to software that has been honed over the past 2 decades for exactly this purpose. Modern Postgres even uses genetic algorithms in order to find the most efficient way of executing our queries. So transforming our queries like this can lead to massively increased performance. It also reduces the workload on the database. It enables higher concurrency and reduces our request latency. This delights our users. It pleases the people that are paying the server bills, and it leads to wonderfully fast feature development, which keeps our developers happy too. So by embracing this modern tooling, automation systems, and code generation, we've been able to massively reduce the amount of code we need to write, and we've made it easier to write the code that we do need to. We've reduced traffic, not just from the client to the server, but also between the server and the database, minimizing the number of round trips and the amount of data transferred, and reducing the workload across our entire stack. We've also improved type safety, not just within each of the individual layers, but also between all of the layers, which has helped to eradicate entire classes of bugs. And most importantly, we've increased the speed at which we can deliver excellent software to our users. If you'd like to support or follow my open source endeavors, you can find me on GitHub sponsors or Twitter as Benji. I also carry stickers and a few cheat sheets, so come and say hi during the conference. Thank you for listening to my talk. It has barely scratched the surface of what is possible with GraphQL and modern Postgres, but I hope that it inspires you to reevaluate your preconceptions and to build things faster than ever before.
Thank you, Benji. And now, it's still me, I changed. And we'll look at the questions from you, not that many. Feel free to still send some. So Benji, they're asking, what are your thoughts on Apollo and Relay?
Apollo are incredible. They write a huge number of very important bits of tooling for the GraphQL ecosystem. I personally use the Apollo client for most of my GraphQL projects, so I'm a big fan of it. Relay is also a great framework. In my experience, Relay is more opinionated and structured. So if you follow the Relay patterns and you're happy with them, it can be very, very productive. However, if you want to do things a little bit custom or do things that are outside of what Relay wants to do, then you might want to go with Apollo client, for example, because it is more flexible.
Thank you. You know, Benji is the first speaker, and that always means that you guys are still learning a little bit about asking those questions. But I know that actually Benji will be tomorrow at 5 p.m. Discover stage. So you can ask more questions of him. And of course, he will be hanging out around. So thank you so much, Benji.
Thank you.
It was a pleasure to have you here. And let me invite on the stage. This is for you. And let me invite on the stage our next speaker, who is a curious programmer, musician, and a teacher from Brooklyn. He also helps run the Affordable Kitchen Table Coders workshop from his Brooklyn studio. The name of his talk is Are We There Yet? Remix. Please welcome David Nolan.
Hello. Good morning. This talk is called Are We There Yet? Remix. I'm going to explain the title in a second. Just a little bit about me. I was an early adopter of React. I think that's how I kind of got involved in ReactiveConf, is because I think in 2013 I talked about why I thought it was cool. Some of you that were around, that have been using it that long might remember. But since then, I've been doing a lot of professional Clojure development. I'm currently a software engineer at this company called Vouch.io, where we're kind of rethinking security and cryptography. But that part's interesting, but it's only 5 developers at Vouch.io. It's kind of a startup. But our entire stack is functional programming. We use Clojure and ClojureScript for everything. Clojure's for all our backend services. We use ClojureScript plus React Native to build our mobile client. And we also do this neat thing where we have an SDK version of our code base where we need to deploy that for both Java consumers as well as Objective-C Swift consumers. And we only write that code once in ClojureScript. And we ship ClojureScript inside of a wrapper which exposes the idiomatic APIs for whoever is consuming that particular version of the SDK, which is pretty cool. So we're able to be very productive with a very small team. Very agile, which is interesting. I'm not going to talk that. Oh, one other thing about Vouch.io that's pretty cool is we use this thing called Datomic Cloud, which is a product from this company called Cognitech, where I used to work. So I don't work at Cognitech anymore. It was great, but I work at Vouch.io now. But we're using Cognitech's Datomic Cloud, and that actually is an interesting piece of technology if you're interested in Clojure and ClojureScript, because it's basically Redux in the cloud, right? So if you like Redux and functional programming and having control over your state, imagine if you had that level of control over your entire database. Datomic Cloud is effectively a gigantic immutable JS map in the cloud. We can time travel over our entire business domain, and that's pretty crazy and pretty cool. So if you have questions about that, I'm not going to talk about much more about that today. Feel free to ask me questions after the talk, and I believe I'm going to be on the discovery stage today at like 5:30. So if you have questions, come find me. I'm going to talk a bit about Clojure and ClojureScript, but this is not like a pitch, right? I'm not trying to convince anybody to use Clojure or ClojureScript. Clojure and ClojureScript are great bits of technology. I would say we have a modest community. It's sustainable. I think that's the most important thing about a programming language. You have a sustainable community. Clojure is now 12 years old, and ClojureScript is about to be 9. It's 8.5 months. I've been the lead developer of ClojureScript since 2011, so I've been there since the beginning. again, they're great technologies, but the point about this talk is you're probably doing ES6 or you're doing TypeScript. Maybe some of you are doing Flow, but based off the surveys, I'm really, most of you are doing JavaScript and TypeScript. It's to think about what are the semantics that TypeScript and JavaScript give you, where are they going, and what is it that these other interesting languages like Elm, like PureScript, like ClojureScript that target the same platform, right? The benefit of something like JavaScript being ubiquitous, kind of like what I said we're doing at Vouch.io, is that we're able to completely leverage the fact that JavaScript is everywhere. We can target Node, we can target phones, and there's a lot of power here. And I think that now more than ever, because I think things are changing with how quickly JavaScript or TypeScript can evolve, it's a good time and it's very low risk to say, well, I'm already on the JavaScript platform. Let me play around with some of these different languages and see if they provide new tools for solving problems. I mean, that's really why one chooses a programming language. A programming language may or may not let you write better software, but it will definitely show you new ways to solve problems. Hopefully, your whole team can understand that, and that will allow you to ship better software faster. You can't do it by yourself. I mean, it requires effort. Programming is, in the end, a social activity. So the name of this talk is a riff on this talk by Rich Hickey that he gave 10 years ago. Yes, 10 years ago. Just a little more than 10 years ago at the JVM Languages Summit, which is a yearly summit for both language designers and JVM implementers, people who implement the virtual machines, to come together and talk about what are the challenges for implementing languages which are not Java on top of the JVM. The JVM has a published bytecode, and so you're able to target that technology, but of course there are things that the JVM could do to make the job easier or harder for language devs. So when he gave this talk, he was pointing out that in 2008, I mean, Java, and nothing has changed in 10 years, and we're going to come back to that, that mainstream OO has really succeeded. And this is not a bad thing, right? Mainstream OO, people learn it in school. It's effective. There's a lot of literature on how to write good software using OO techniques. And Java and C# to me are kind of like the high water mark of what's possible. Like, there's not much in that space that's happened significantly, right? Those technologies are good, and there's some sort of minor activity around making things a little bit cleaner. But I would say in 10 years, not that much has changed. And in fact, when Rich Hickey had given this talk in 2008, not much had changed since really JDK 1.5 or the versions of C# that were floating around. And in this talk, he talks about, well, what if we did things differently? What about functional programming? What about immutable data structures? So if you're familiar with Immutable.js from Facebook, something that came out in 2014, those data structures are actually ones that Rich Hickey designed himself, and he did that work in 2004, right? So there was a 10-year gap from when Rich Hickey innovated using some existing literature, but did a lot of innovative work, that 10 years later that appears as Immutable.js. So again, this is all pretty old stuff, but you really could give that talk again today, and that's why I'm sort of giving this talk, and why it's called Are We There Yet Remix. I follow the JavaScript community. I don't do much JavaScript, but of course I have to follow it. I maintain a compiled JavaScript language. I have to know what's best practice because users of ClojureScript want to be able to leverage the ecosystem. They want to use the same tools. They want to be able to access all these libraries that are great, that you all have access to. And perhaps in a simpler way because the tooling is already set up. In ClojureScript, for us, because we use things like the Google Closure compiler, there's a bit of more work for us to do. But we also want it to be easy because we believe there's tons of value in the ecosystem. But so I follow things in the JavaScript community. And this last survey to me was very surprising because you see this massive ES6 adoption, which of course I think it's clear, right? For me personally, I've been doing JavaScript since 2005. So I remember back in the days when the only clue you had was when IE6 would crash, right? When it crashed, and then you could start putting like try catches or until the point where like, okay, it hasn't crashed yet. So I remember the dark days of JavaScript. So things have, of course, improved a lot. Specifically with ES6, personally, I'm extremely happy that they added modules as well as async await. Those two, for me, removed so much incidental complexity. I mean, 10 years of JavaScript, there was no standard way to load some other bit of code. I mean, that ruined the ability to do serious library development. It ruined the ability to have a very sophisticated dependency chain, like you have a lot of components you want to pull in. And just solving that was huge. And then, of course, all JavaScript, all meaningful JavaScript that you're going to write is going to involve asynchrony. And that was never fun. And I believe async await reduces the sort of incidental sort of complexity around, OK, what does that code look like? Is it readable? And how can I do the error handling in a sensible way? And I think async await covers just the most basic activities there. So it's not surprising to me that ES6 plus async await is seeing rapid adoption. But the surprise for me was TypeScript. You know, and this is last year that more than half the survey of people that took the survey had used TypeScript, right? Almost half, 46%, not half, not quite half, but almost half. And that's very interesting to me. And one thing that was hard to figure out from this survey was that is that because you have JavaScript people who like ES6 and they're interested in typing ES6, or is it also the fact that you have a massive demographic of Java and C# programmers that are like, TypeScript lets me do Java and C#, which it does, right? It has all of the typing features one would expect. Generics, a very sophisticated form of generics. They've done a ton of work to be able to type relatively sophisticated functional patterns. So there's very good coverage on JavaScript semantics, but it lets you, if you wanted to, you could do full-on factory style Java programming or C# programming. TypeScript enables that. So my question is that number based off an influx of people who are like, finally, enterprise programming in JavaScript? And again, I'm not saying that's a good or bad thing, but it's interesting, because what does it mean for the evolution of JavaScript and how we use it and how we think about it? You know, is the end game for JavaScript that JavaScript is basically a slightly more expressive, you know, Java or C#? Is that really the high watermark for this language? One interesting property of TypeScript, and TypeScript is a very cool bit of technology, is that the thing that I like about TypeScript is that it has this thing called interface. So you don't have to make a class. So the interface allows you to decouple the shape of the thing you want to talk about from having to make any class for that thing. And that's actually really big. It means, I mean, you could say, oh, that lets me take an existing untyped program and make it type, and that's one way to think about it. Another way to think about it is it lets you stay sort of data-oriented. You can focus on writing a data-oriented functional sort of program, and TypeScript allows you to express specifications about that without having to write a bunch of class-oriented boilerplate, right? You can just write an object literal that has the properties you want. You can write the TypeScript interface for that, and you're going to get a nice specification, a nice compile time error. And I think that's really, really nice. And I'm curious, again, I don't use TypeScript, and the survey doesn't drill into this dimension. Is that something that people are going to really embrace? That TypeScript really does, because of that feature interface, it lets you think about constructing your type-checked programs very differently if you were open to this idea than you would be if you were just had your Java or C# classes on. But in the end, even if you do that way, and I think that is interesting. That would be an interesting way to think about typed JavaScript programs. The question remains, I mean, what's really next, right? Once JavaScript got async await, and once JavaScript got modules, it becomes harder and harder. And now that TypeScript is available, and you can have comprehensive typing of all interesting major JavaScript idioms, what's really next for JavaScript as a programming language that's significant, that's not about like platform stuff? WASM, of course, there's a ton of work to do there. Concurrency, there's a ton of work to do there. And possibly things like, OK, we want long or enhanced numerics. Because again, that actually is more about platform stuff. But purely from the standpoint of features that the language provides that help you solve problems differently, what more can JavaScript really provide? And I would actually argue, given how long it took to even get to async await, as well as modules, because there's so many stakeholders. I mean, Google, Apple, Mozilla, and Microsoft, they all have to be OK with anything that gets proposed to TC39. Any of those people vetoes it, and it's unlikely to happen because they implement the VMs. So looking into the crystal ball is that actually I suspect innovation for JavaScript as a language is probably going to slow down to a snail's pace. You'll probably see some syntactic sugar. You may see some minor additions. But I don't see that much happening. And this is the moment where I think you can say, look at the existing ecosystem of JavaScript as a platform and say, OK, we love the ecosystem. We love the platform, the technology. But maybe it's time for us to be like, we can do all the stuff we were doing, but maybe we should assess Helm, PureScript, ClojureScript, because those give us new tools, new insights on how to write simpler programs that solve the same problems more effectively. So the last bit of my talk is going to show some ClojureScript. You don't have to know ClojureScript. It's not important. All I want to demonstrate are some features of ClojureScript that I now consider essential, that in fact are missing from JavaScript without me doing a bunch of like boilerplate work that I don't think is interesting. I'd rather just use a thing that solves that problem for me so I can just focus on my problem domain. So there's 3 key things that I'd like to talk about. The REPL, equality, and specification. I suspect there'll be a lot of talks about TypeScript, and the previous talk was also about TypeScript. Again, TypeScript, ES6, all this stuff is cool. I want to show you simply a different way of thinking about the same types of problems you might want to solve, but with different set of tools. So the first thing is the REPL. So you all are familiar with the Node REPL. You fire off Node, you use it. You get to check a couple things. But the thing is that that's very different from how a Lisp programmer or, say, a Smalltalk programmer thinks about this. Like, if you've ever seen Dan Ingalls talk about Smalltalk, you should run and see that if you haven't seen that yet. And the idea there was that the programming system should be alive. It's a living thing. Like, it's not just I load a REPL and I test a thing, but really the REPL is a whole interactive environment that's just on all the time. So here in the background, I have, sorry, one second. Here in the background, I have the browser open here, Chrome. I have Chrome open, and it's on this page, and I can type in an expression here, and I'm in IntelliJ. Oh, but let's start this again. Sorry. Sorry, one second. So here I have Chrome, and then let's see if this works. Yes. So what's interesting here is that, you start Node, but I have the same thing that you would have in Node, except I have it in my editor, right? I'm in my actual development environment, and I have a REPL, and I can, for example, load this file, right? And all of this has been evaluated. I've loaded. Oh, you don't see anything. Sorry. Somebody should have said something. Let's fix this. Displays. Arrangement. Mirrored. Sorry about that. OK, that's better. All right. Let me speed this up, and let me just repeat what I just said. So here I have Chrome. It's open. Here I'm in IntelliJ. In my source code editor, I have a REPL here. I've loaded this file. I can run expressions. And what's happening is that this REPL has a connection to Chrome, and it's compiling the JavaScript on the fly, and it's evaluating it and returning it here so that I can work from this text editor. So I can put my cursor here. I can switch into this library, and I can evaluate these expressions. Right? So my first demo here is equality for all, where I show that I want equality to make sense in the sense that in JavaScript, this was something you can't fix. Equality was set so long ago, there's no fixing it without breaking the internet. In ClojureScript, this is something that in Clojure, equality was just done right from the beginning. So there's no coercions. Equality is not coercive. 1 is never going to be the blank string. I don't have to use a special equality operator. 0 is never going to be equal to false, right? No coercion. But more importantly, I can take compound values, right? I can take 2 vectors, and these are exactly the same as JavaScript arrays, but they're immutable. And I can say, are these the same? I don't need to go find a third-party library to check 2 values, right? So if you've written any non-trivial UI program, you're like, is this domain entity the same as the domain entity that I currently have, right? And you have to go find something. Or you're writing tests. This is very common in tests, even more so than inside of your program. Is the value that gets returned the same as my example value? And the fact that I don't have to do anything, it's just a fundamental feature of the language, is great. Down here, I have a map. It has a foo and blah, 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 so I can do the same thing for maps. That's not that interesting. But down here, I can do complex keys. So in JavaScript, with JavaScript objects, you can only have string-based keys, and that really limits how you can use the object inside of an algorithm, right? So a lot of times people say, in order to write a good algorithm, use the right data structure, right? So because I can embed complex keys, I can often shape the map so that it fits the algorithm that I'm writing. I don't have to go through some convoluted thing. So here I can say, find the item that has the key, which is a vector with 1 and 2, and it gives me the value that I expect. You may think that this works with ES6 maps, but this is not true. If you've ever tried to use ES6 maps, it's, in my opinion, completely broken. So here I'm going to make an ES6 map, and I'm going to go get, this is a JavaScript array. This is not a vector. The JS says make a JavaScript array. And I made this map, and I say, give me the value that has the JavaScript array 1, 2, and I get back nothing because ES6 maps only do lookup by reference. Right? I cannot use ES6 map in algorithms out of the box. I can't use it in an interesting way. And to me, the fact that this was even shipped this is definitely one of those cases where I have a lot of criticism because even you can do this in Java, you can do this in Objective-C, but ES6 maps and sets, because of the same implementation really, they're broken. I have to pass the original array to get the thing that I want. Okay, so let's we talked about that, and I want to move quickly to specification. So this is going to be interesting for people who do TypeScript or are interested in TypeScript. So what does ClojureScript offer for specification, right? It's a dynamic programming language. We don't do compile time checking. You can use this for compile time checking, and people have done it. That's not its main purpose. You can use it for that. But I want to demonstrate things that are impossible to do, or nearly impossible, with a traditional compile time check type system. So here I'm going to make a specification for this thing called first name. It has to be a string and last name. These are going to be keys inside of a map. In TypeScript, that would be like interface person, first name, last name. Cool. They have to be strings. This is semantically the same thing. A person is a map, a ClojureScript map that has these 2 keys, first name, last name. Then I go, is this map with just Bob a valid person? It better be no, because there's no last name. Down here, I say, explain to me why that's not a valid person, and it tells me a person needs to have a last name, right? So I have a very succinct way for taking some data. I might have written this data a year ago, but I have a specification mechanism that lets me now talk about what that stuff should look like. Very similar to TypeScript, this idea of doing something gradually. You wrote a program, now you want some more clarity about the meaning of the program. You can do this. So down here, I go, is this valid? And it's true. I'm going to add a new thing called school, and then, okay, nice. And then, what's a teacher? We can reuse specs. So you can't do this in TypeScript. You can't just make a bunch of interfaces and say, this interface is not, I mean, inheritance, we really want to talk about inheritance. I don't really care about the inheritance relationship. I just want to reuse an existing set of specifications and add one new piece of information. Like, there's no real way to do this with TypeScript. If you know about it, please tell me. I looked around at the documentation, but I couldn't see a way to do this. So here I say a teacher is a person who also has a school. This person is not a teacher because they only have first and last name. But this one is, right? Because there's a school. So to take it one step further, types are great because they really serve two purposes. One purpose is for the computer. The computer checks that all your types match. OK, that's cool. And the person gets that back. But really, to me, the most valuable thing about types are their function as a specification. That when I look at somebody's code, without compiling the code, without running it or doing anything, the types tell me something about what the original author intended. It's a form of documentation. I actually think that is far more important than the compile time type checking. I don't think it's not important, but I think the documentation part is the most important because, again, programming is a social activity. How do we communicate with other programmers? So down here, I'm showing you that we can take our specs and we can annotate them. So not only can I tell somebody, this is what I meant, you can take my spec and you can make examples from it. Right? This is something you can't do with TypeScript or in most type systems. So here I go, OK, first name, last name, and school. And for each of these, I now provide a set of example values. Down here, I can say, generate me a first name, generate me a person, right? And generate me a teacher. Like, that's amazing, right? I can jump to anybody's code. If they gave me a spec and they took the time to document what the examples should look like, I can generate the example, right? So many times when I look at an API, it's a convoluted domain object, and I have to go find a test, copy and paste the thing to figure out what does the thing actually look like. The types don't tell me enough, right? And it's very tedious. Here, we're really adding a next level of documentation to the specification that we're making. So just to wrap it up, I know I'm running out of time. So here I have a function that takes a teacher and extracts the school. OK, whatever. So here I'm saying I want to specify that this has to be teacher. Notice that the function itself isn't annotated in any sort of way, but I'm able to provide a spec after the fact. And people often want to munge the types and the specification together. And I think when you separate them, there's a lot of power. For example, this spec actually can be used from Clojure or ClojureScript. We can use the specs anywhere, right? It doesn't matter which platform we're targeting. And by keeping them separate, that's actually very valuable, because it may be the case that the platform implementations are different. So here I'm going to instrument this function saying I want this to be checked. Here I can say generate a person. And I want to call that function. And it's going to fail because teacher to school expects a teacher, not a person. And if I run the second one, it's going to work because that person has a school. And finally, this test is a broken test, right? You would think, oh, it's not compile time checking, but with instrumentation, you have to write tests anyway. I don't care how many types you have, right? For your domain business logic, you're going to have to write tests anyway. So instrumentation gives us this ability when we run the tests, we can get this feeling of interactive checking, because here it says teacher to school. Down here, this doesn't conform to the spec because it doesn't contain a school. So let me fix my test. School, bar high, right? I redefine the test. I rerun the test. Boom. And notice I never left my text editor. Like this idea of I run a REPL only to test snippets, it's just not how I work. What you just saw is exactly how I actually program. It's actually when I sit down to work, everything that you saw me do is how I sit down and solve problems. And hopefully, again, this is not use Clojure or use ClojureScript. It's compare my approach to solving problems to the set of tools that you have for solving problems. And maybe, I mean, ideally, this could influence the way that, hopefully I'm wrong, that JavaScript has a lot more to learn, has a lot more to grow. Some of these things can happen through TC39. Perhaps some of the things I'm demonstrating are just you writing a library saying, that's a great idea. We should embrace that. Again, just some controversial statements. Like I've been doing functional programming for a long time now for all types of work, UI work, backend work, systems, doesn't really matter. But I haven't used classes or inheritance in years, data all the things. I think this is really important. You should try this in JavaScript. Don't use that stuff. No unmanaged state. So people, you use mutation. So if you like Redux, why is Redux the only place where you use managed state transitions? What happens if you use managed state transitions everywhere, all the time? Does your program become easier to reason about? And finally, generality of specifications versus compile time checking only of types. This is not anti-compile checking of types. I'm not anti that, but hopefully I demonstrated some things that I know you must know that it's very difficult to do with traditional type systems. That's it. I went over. Sorry, but thank you.
David, thank you, David. It's good that you went over because I think you answered all the questions in your talk. There are no questions, but be aware that David will be also in our chat zones today at 5:30 on Discover stage. So if you have any questions, you can ask him personally. But thank you so much, David. What we have ahead of us is a coffee break till 11:30. When we have another talk. But before you guys go for coffee, please don't forget to rate your talks, or our talks, actually, because it really helps us to become better and improve ourselves, and also it's a good feedback for the speakers, too. And don't forget to ask questions during our talks. Use the reactive chatbot, Mickey. If you don't know how to use it, ask our volunteers in green shirt. They will help you with that, or ask me. Enjoy your coffee. I'll see you at 11:30. Hey, hey. Hello, welcome back. Take your seat. I hope you enjoyed the coffee. You are good with time. I don't know why that surprised me. I shouldn't. We have a packed day ahead of us, and we're going to have another speaker. This time, it's a she, Liz Crane. She's a developer advocate at Sentry and founder of Learn, Teach, Code, which is an organization that empowers inspiring developers. She loves finding new ways to combine code with other disciplines like art and music. In grade school, her nickname was Lizards, and her current hobbies include juggling, programming, and Elm. And as she puts it, embarrassing herself on stage. I believe she's not going to embarrass herself right now. I'm super excited to hear her talk. This is Liz Crane.
Wow, that was a very exciting start. Thank you for the kind introduction. Hey, I'm Liz. Super excited to be here. A little bit about myself first. I'm a developer advocate at Sentry. I have the pleasure of working with an amazing team of people who are building a tool to report errors across a bunch of different SDKs. We're an open source product. Obviously, won't have time to talk about all of these today. I don't know very much about all of these yet because I come from the strange land known as web development. So I'm just going to be talking about JavaScript. Since this is a JavaScript audience, I'm sure you can relate to me when I say that JavaScript sometimes makes me want to throw things, sometimes literally. I got curious about how this works. Like once we generate errors in our code, how do we then put it somewhere where it becomes useful to us? For example, all of our modern-day error reporting tools that really make our lives easier, instead of taking it for granted, I wanted to figure out some of the history leading up to this, and how did we get to where we are today? Specifically, how did JavaScript evolve to the point where we can make use of its features to do this? Because it didn't used to be possible. Now, in order to learn some of this, I got to indulge in my favorite hobby, which is reading old books, specifically old technical manuals. It's the best section of the library. I highly recommend taking a look at that. Now, I'm going to start with a few quotes from some of my favorite old books that I found in learning about this. So the first one here, Laura Lemmy's Web Workshop from 1996. Does anyone here, quick show of hands actually, anyone remember Netscape Navigator 2? Did anyone use that? You were programming JavaScript in 96. Yes, I want to talk to you afterwards. So in those days, the way we programmed JavaScript was by using alert dialogues. And it's not really the best way to do JavaScript, is it? In Laura's book, she outlines two techniques for debugging JavaScript at that time. The first is to use those alerts, window.alert, and she says basically just sprinkle it through your code. So every time you do something in your program, change variable, alert, run a function, alert, and then once you figure out how to solve all your bugs, you go back and delete all the alerts. There's a slightly better way that she recommended, which is to use window.open and then write to that window all the debugging information. So then you have something that looks more like this. Not that much better than alert, but people are very creative with finding solutions to this early on. Now, in 1997, which I was surprised that this happened so early, we had a JavaScript debugger in Netscape. This is the official manual. And you can see that they actually had breakpoints and a bunch of other cool features. If we skip ahead just a little bit, I mostly just wanted an excuse to show the cover of this book, because this guy is amazing. I really feel like he's looking deep into my soul when I look at this. Now, his book outlines some ways that the debugger evolved over time. This was published in 2000, and you can see some of the ways it got better, definitely a little bit closer to what we have today. You could actually see the call stack. You had breakpoints in a visual way, so you could actually click on the line numbers the way we do today, and then see a list of your breakpoints on the side. Fun fact, it was a total tangent, but I couldn't help myself. How many of you are familiar with the origin of the term breakpoints? Anybody? I think maybe I saw one hand. I see one. OK, one hand. So if we go back to the 1940s and 50s, which I've heard a lot about thanks to my dad. He actually used to work at IBM in the early days of like mainframe computers. A little bit before that, the ENIAC computer was programmed. You can see all the cables. And one of the first programmers who worked on it was this woman standing in the front, Betty Holberton. She was one of the 6 first programmers of that computer, and she's credited with inventing breakpoints, or I guess at least coining the term breakpoints. And she says in an article, an interview with her, that the reason we call it that, the reason she started calling it that, was because we pull those wires out to stop our program and then see what's happened. And that's how debugging worked in the 40s. And in doing so, you literally broke the point of contact. And then there you go, a breakpoint. So fast forward again to 1997, here where we left off with our JavaScript history. I found another interesting article this time posted in 1997 by Microsoft. I found very interesting. They recommended to avoid having users see the default error dialog, they say you should use window.onError to trap the alerts and display your own message instead of the error. So that way your users won't really get to see under the hood of your application. So this is the code that they recommended. You copy-paste. Alert, error handled. Return true to avoid default behavior, and then set that to window.onError. So we had that error handler at least as far back as 1997, almost as old as JavaScript itself. This is what it looked like. So imagine you're using an application in the early days of the web. You click a button, maybe you're submitting a form, and then you see this, and then this, and then this, and then this. And you're like, oh, great. This developer really knows what they're doing because I don't see any error messages. I just know that everything's under control. Great. Apparently, that was how you did it. What's scary to me, though, is if you fast forward all the way to 2011, as you can see in this O'Reilly book, I'm going to show another quote from this one, which is one of my favorites. So they recommend another usage for window.onError, but they say that the onError handler is just a holdover from the early days of JavaScript, back when we didn't have try-catch. And, quote, it is rarely used in modern code. That made me very sad. But maybe just because I work at Sentry and I'm looking at JavaScript stuff, I feel like the window.onError is used all the time. It's actually the backbone of our reporting tool and all the other ones that work on front-end JavaScript. So why in the world did this book say it wasn't used? Why weren't people using it? Because I'm thinking, this seems like one of the most useful global error handling, event handling functions. The reason is because they only had 3 parameters available back then. So you had your message, URL, the file, and the line number. And so you get these alert dialog boxes. You see the URL, the line number, and the message. The important thing that's missing here, though, you'll notice, is where's the stack trace? I take this for granted. Anytime I'm working on a website, I always have the console open in my browser, and I get to see this stuff. With every single error, I just see exactly what happened and when, and the entire call stack, and I can actually click through and see everything. But you couldn't do that in the late 90s. Now, it wasn't until 1999, 3 years later, after people were using JavaScript with all these crazy workarounds, this was when they finally introduced try-catch into the ECMAScript standard. So you got your try-catch. Imagine we're running a function, let's say, called breakEverything. And in an ideal world, when something like this goes wrong, we want to be able to send this to some sort of centralized error reporting tool so we can actually see what's going on. And we want to capture that error object, which includes the stack trace, and then send that whole thing, right, instead of, say, just the line number. Problem is, since at the time you couldn't get that error object from the window.onError handler, you had to use try-catch for everything. And there's a lot of different places you could have errors. It doesn't make sense to just try-catch once for your entire program, especially since JavaScript is asynchronous. There's a lot of different places you need to worry about this. Never mind that try-catch wouldn't work with asynchronous code back then. So you had to basically just try-catch all the things, and your code didn't look so great. It's a lot of extra typing. So the other big problem even if you did try catch all your stuff, was how in the late 90s would you actually send the error to somewhere? Right? How do you send requests behind the scenes so the user doesn't have to worry about it, doesn't have to refresh the page every time they do something that might cause an error, which is literally every interaction with the web page. Back then, of course, we used forms, right? You want to send information, you have to go refresh the entire page. It's not really the best way to handle errors. Now, I thought it was really interesting. When I first read about debugging in the 1940s, I thought, wow, they had it really rough. Like I can't imagine debugging my program by walking around a room with my physical body, like moving through space and like pulling wires and looking at things. I mean, I guess I would get more exercise than I do these days, but it seemed pretty difficult. But on the other hand, they also had it easier than we do, because all of their code ran on one machine. They didn't have to worry about potentially millions of different clients running their code on other machines that you have no control over, that you can't see inside. So we have all these black boxes to worry about. Now, as far as sending information to all of those different machines, from all those different machines to a central place where we can see at least some of what's going on in them, we needed another technology that was being formed as early as 1996, but took quite a few years, roughly 10 years, to really catch on. And you can see some evidence of when that became mainstream from articles like this in 2005 from the Wall Street Journal, talking about things like Ajax, the programming technologies that's the buzz of Silicon Valley. Oh my God, Ajax, what's this new invention? But of course, Ajax wasn't anything new, and it was just a convenient acronym. It was actually coined by Jesse James Garrett in 2005 when he was outlining what people were already doing at the time. One example you may or may not remember is Google Suggest back in 2004. People wrote all these blog posts saying, oh my God, this is the most amazing thing I've ever seen. You can type into this box, and this stuff appears in real time, showing you how many people searched for each of these related terms. And autocomplete was amazing. That was thanks to Ajax. Now, it actually wasn't standardized by the W3C until 2006. So you'll see a general trend on the web. Anytime we have to deal with standards across lots of different people involved in developing these things and experimenting, it takes a few years for the standards to catch up. Now, another tricky one that made error reporting a little bit more difficult, and something you definitely have to keep in mind, is the same origin policy. I'm sure you're all familiar with this and have to deal with it every day. I know when I was starting out in web development, this was a big headache, because I also didn't totally understand it. But as a quick recap, imagine that you're pulling a third-party script, say from a CDN, which is very common today, and you're using window.onError to get information about errors that went wrong in your application. But you're going to see messages like this. No stack trace, no line number, nothing helpful at all. Now, the same origin policy is as old as Netscape Navigator 2.0 and JavaScript itself. It's a fundamental tenet of the internet. It just says that a web browser can permit scripts from two websites to communicate only if they have the same origin, like the same domain, for example. There's some great slides, these are kind of old, from I think Stanford's web security team. Basically just showing if you have two windows open without the same origin policy, you would be able to just go from one, like, quote-unquote, evilwebsite.com to somebody's bank website, if that was also open, and just literally do, like, .inner.html, grab their bank account information. So it's good that we can't do that. On the other hand, there's even more danger that's less obvious that I found pretty interesting. This is also from 13 years ago, about letting error handlers give clues about what users are doing that are unintended. So even if you can't run scripts on somebody else's domain, even just being able to see their error messages can be a security vulnerability. So this example that he's pointing to here looks like this. If you include a website, for example, Gmail, you'll get an error message by trying to do this. But the interesting thing is, if you're logged in, you'll see some error on line 8. This was his example. And if you're not logged in, you'll see the error on line 3. And people could exploit that to find out which services a user was logged into at the time and use that to make a more targeted attack on them. So it's tricky. Security is very tricky. How do we protect users while also having the flexibility to be able to understand what's going on in our code? The solution for now, it's also a bit messy, but cross-origin resource sharing, you may also know it as CORS. Here's a standard first solidified in 2014 here, and it's just a mechanism to allow us to say which domains can share information with other domains. And there's only 2 steps you have to do to get your third-party scripts to work with this so that you can actually see your error messages in full detail. First step is set this lovely header, it's best name ever, access control allow origin. Rolls off the tongue. In this example, it's just set to an asterisk, meaning any domain. And then on your client-side code, in your script tags, you just have to include this attribute, cross-origin. The default value is anonymous. And there you go. It'll transform this not-so-useful script error message into your full stack trace. Yay. OK, so now we're able to get that error object, say using try-catch for now. We're able to use Ajax to send it to the reporting tool in the background so it doesn't affect the user's experience too much. And we're able to then do something cool on the other side with our reporting tool if we want to. But the problem is, again, window.onError only gives you a few things like just the line number. Of course, at some point, we started writing a lot more JavaScript code than we used to and using it in ways it wasn't intended to be used. So if you were to use this in your error reporting tool back then, you would see error on line 1 for literally everything. This is line 1. Your entire application is line 1 because your code is minified. Not so useful. You can use source maps to get around this, of course, and that's a topic for another day. There's a lot to say about that. But the interesting thing to me was how this on-error handler evolved over time. We can look back. This is a commit from 2012. You can see all this history backlogs in the Whatwig GitHub. This is the HTML where they're documenting everything that you can use with the DOM. And somebody suggested the brilliant idea of adding a column argument. So at least that way, you can see the line number, which is your whole program, but at least with the column number, you can identify where exactly something went wrong. Now, even more importantly than that, there's, of course, the idea of getting the stack trace. So up until now, there was still no way to get that stack trace using window.onError. So what I found interesting about this is this issue was open 13 years ago, and it was closed 6 years ago. It took a little while. But finally, here in 2013, you can see they added that argument, the error object itself, to the on-error handler, which it's funny that it took so many years for on-error to give you the error. I don't know. Now we got those last 2 parameters. So not just the message URL and line number, but also the column number and that wonderful error object. So if you take a look at can I use right now, you can see getting that stack trace, the stack property on the error object, is really well supported. So we're good. Problem solved, right? Then there's this little note at the bottom. This feature is non-standard and should not be used without careful consideration. Oh, why is that? I actually didn't know that. I thought it was standard because I see it everywhere. Well, if we were to try this, what would we get back? You actually shout it out. Yeah. So it actually just gives you a string. I thought it was going to be an object, or at the very least an array, right? Because a stack trace is like a list of things, but no, it's just a giant blob of characters. I could not figure out why. I've done a lot of digging in here. I still don't know why it's just a string. Because back to 1997, when we had the debugger running in Netscape Navigator, there's our call stack. It's right there clearly we could get that information. The browser has it somewhere. And if you're using Node, you can get access to that. It's a lot easier, but on the front end, blah. But you know how it goes with front-end JavaScript reporting. Now, because it's a string, it's readable, obviously, with formatting, but this is what it looks like in Chrome. And then this is what it looks like in Firefox. A little bit different. And then this is what it looks like in Safari. You'll notice it has this global keyword at the end that neither of the others have. So I guess the solution is, well, we just have to parse all of everything from each browser differently. And this is where we are today in 2019. That, unfortunately, is the answer, everybody. Thank you. OK, bye. Regular expressions. Yay. This is how we do it. This is still how we do it. Luckily, of course, there's libraries that handle this for you. So we've got TraceKit, which is actually a really nice open source one. This is the one that we use at Sentry. We just pulled that into our repo, and one person on our team single-handedly rewrote it to get it to do only the parts that we needed. But it's a really good tool. It's been around a while. Another one that has more features on top of it and is still being used and updated today is StackTrace.js. So definitely recommend checking out both of those. Obviously, you could roll your own parsing. I mean, you can write regular expressions, so you're good to go. But it's obviously nice to not reinvent the wheel. And another layer on top of that, of course, are then all of these error reporting tools that we have. So this is just one example of how you would do this with Sentry. It instruments your code in a very nice way, and then also has, in addition to parsing those stack traces and a bunch of other things, like giving you a nice UI. All of the error reporting tools out there today basically do the same thing, and they all work like this. You import the library. You initialize it in some way. In our case, you give a unique identifier, the data source name. And then anywhere in your code, if you're throwing an error, behind the scenes, it's already capturing that and sending it to Sentry. So you can, or if you're running it locally, since it's open source, you can handle that yourself and just get it. And then you get this nice UI. So there's a lot of tools that do this today. It's pretty nice, but a lot had to happen before we could even get here, unfortunately. And I don't really see this changing too much too soon. I think we really need that .stack property to be standardized, so hopefully that's on the way. I don't know how long it'll take, maybe another few years. But that's where we are. So JavaScript errors, I mean, they're not so great, but we found ways to work around them. And hopefully, in the future, we'll have even better tools. We've had a pretty good track record so far of people coming up with creative solutions to all of our limitations in JavaScript, even though we have a lot more tools available to us with other server-side tools. But front-end's starting to catch up. It's definitely something, I mean, as you all know, the reason we're all here definitely can't be ignored. There's a lot of innovation happening in this space. So I just wanted to say a really quick thank you to some of my teammates who worked on our JavaScript SDK, helped me understand it, giving me some feedback on my research, and just being really cool people to work with. So if you're interested in learning more about some of these tools, here's a few links to get you started. And thank you very much. I'm more than happy to speak with any of you later. You can find me on the internet at Learning Nerd on Twitter, GitHub, and thank you so much.
Thank you, Liz. Let's see if we have any questions for you from the crowd. And I think there are no questions. So again, you probably answered them all. I'm sure you're going to be hanging out around, so people can ask you directly.
Yes, come find
me. Thank you so much for your talk.
Thank you.
So this was Liz Crane, everyone. And we have another speaker ahead of us before we break for lunch. Let me remind you that if you want to go to the Discover stage, you can go through the teleport, also known as the elevator, in the Social Baker stand. Just go there, take the elevator to the 3rd floor, and you will be right there. So our next speaker is from California. He is one of the youngest ones. He's only 21. And the internet says about him that he's an American artist, brownie, and child prodigy. I had to look up what brownie was. Do you know what brownie means? Apparently it's the fan of My Little Pony, according to Wikipedia. So he's a Lego master builder and an open source developer at Expo. Please welcome Evan Bacon.
Yeah. Okay, sweet. What's up, guys? I'm Evan. Today I'm going to be talking to you about building universal applications. I'm really excited to talk about this. When I say universal application, what I mean is an application that you write once and then you can run anywhere. And today we're mostly going to be focusing on mobile apps and websites. So this presentation, just like any great project, starts with the question of, do you build an app or a website? And the reason you need to choose is because the stack is totally different. For apps, you can use a cross-platform tool like React Native or Xamarin or Flutter. And to build a website, there is a bunch of options like React and Angular, Vue, WordPress, of course. But what if you could build both? Like, what if you had the bandwidth? What if you could afford to? Like a lot of big companies, Facebook, Twitter, Instagram, YouTube, I can name a lot of companies. What would that look like? And the answer is basically an identical product. So this is Twitter. We have the web version and the native app version. And they look almost identical across like everything. And there's a lot of great reasons for this. Like, you don't want to lock your user into the platform. You just kind of want to lock them into your service. So having it look the same everywhere is really great. So going back to that list of solutions I showed you guys earlier, I'm going to discuss how one of them can be used to create truly universal apps today, and that is React Native. So let's talk about React. That's like a phrase I say almost every day now. Let's talk about React. It's got a lot of great features. It has an amazing community. It's got great examples. It's got hooks. So when you make a website with React, you use something called React DOM. And React DOM uses an XML-styled system called JSX, which renders to HTML. And I promise this will get more complicated here in a second. So it looks like HTML, but it's not. And then React Native came along, and it provided all of those great React features, but now you could use them to make iOS apps. And instead of going for platform-specific names like React DOM, it used these platform-agnostic names like Vue and Image and Text. And because of that, a guy, Christoph Majira, who was working at Facebook, created React Android, which didn't need to change any of the API. It just used that same Vue, Image, and Text, these primitives. So what is a primitive? Well, say you want to render text to a screen, right? Any text, any screen. In the browser, you would use something like a span or a p or an h1 or any kind of element. And then on iOS, you would use a UI label. And on Android, you would use a text view from the Android SDK. But a primitive would be something like text, where you write it once, and then based off where you run it, it binds to the correct native element. So it seems difficult, but well, I mean, it is a little difficult. And this is something that Nicholas Gallagher worked on solving when he was at Twitter and made React Native for Web. And the reason I give this really long-winded explanation is because the name React Native for Web is pretty bad. It kind of insinuates that he took React, which is awesome. It made it work natively, which is awesome. And then made that work back on the web, which is like kind of redundant. But that's not what it does at all. What it really does is it takes that primitive style of using Vue, image, and text, and it applies that to web. And it's really cool. A lot of people are really into this. All of these dope companies here, like Major League Soccer and at times, they all use React Native for Web for their PWAs, desktop PWAs, supplementary websites, personal projects, lots of things. And Twitter, which at the time of giving this presentation, which is like the 6th biggest website, is written in React Native for Web. At least the new version is. So it's awesome, and everyone must be using it, right? Well, not fully right. It's used a lot less than React Native. This blue line up here encapsulates Android and iOS. And then down here, this is web. And so my first inclination was just that like maybe people don't actually make websites. Maybe they just mostly make native apps. And then I added React DOM and realized that was very wrong, 16 times wrong to be exact. So why is this? Because if you used web with React Native, you would have like that identical website and native app. It's very performant. It's a proven technology. So like, why isn't everyone using it? And I kind of identified a few major issues with how people were approaching React Native for web. And now we will explore them in order of most interesting to least interesting. So to first understand the issues with React Native for web, we need to understand the issues with React Native. And the biggest core issue with React Native is that if we look at some of these apps, these are all iOS 13 apps right here. As you can see, they're very complicated. There's a lot going on the screen. And all of these apps cannot be built with the modules provided by React Native. That's because React Native, like React DOM, is a library and not a framework. So it relies heavily on community libraries to create comprehensive apps. But whereas with React DOM, you can create those community libraries with JavaScript. React Native, you need to know Objective-C and Java, so it's thoroughly harder. So if we look at just 3 of these, we have like maps, gestures, videos, navigation. I read everything off the screen. If we look at just these, none of these are provided in React Native, and they're all pretty critical to making a lot of different apps. Like navigation, every single app uses that. So when people want to make production-ready applications with React Native, what a lot of people do is they use a framework called Expo. Now, I love Expo. It's the best. I work on Expo. And with Expo, you can use it to create production-ready applications for iOS, Android, and pretty soon web. Well, I mean, kind of already with web. And it's really exciting. I work on Expo for web, which is this new project which kind of takes and solves the same problems that Expo solved with React Native, but it does that for web. And Expo makes things easy by providing kind of 3 things, or at least I could fit 3 things in the talk. So the first one is the universal API, arguably the most fun. And the second one is it's a bunch of services built around Expo, which just makes it easier. It kind of lowers the barrier for getting into building native apps, and we'll look into that in a second. And then the last one, Webpack, or just kind of the config. There's a lot of dev tools built around it because native apps are hard to develop, and as we'll see here in a second, React Native for web can also be very hard to dig into. So I find the best way to demonstrate the Universal Expo API is just to clone an app with it and then to walk through how I cloned that app and show you guys how things work. I built this natively first with iOS and Android, and then was able to just run it as a web app, which is really cool. I've got this little demo just in case the Wi-Fi didn't work, but it is working. So I'm going to hop over here. This is a website. It's published now, so you can go to it if you want. It's called expogram.netlify, and I'll tweet out all the links afterwards. But here we can just scroll through this, and oh, I see. It's not on the screen. That is troublesome. Well, luckily, I have that video. It's almost like I planned for things to go wrong. OK, so here's the video of what the website looks like. Again, it's expogram.netlify, so you can visit it if you want. And right here, this is just a standard mobile browser running on an iPhone. As you can see, it's got a live camera feed running. It has a blur view running on top of that. There's nothing special here. There's no native modules involved. It's all just standard browser stuff. There's no WebAssembly. It's using cutting-edge browser features. And it's just a recreation of what the Instagram camera looks like. So over here, it's also pulling in a bunch of audio from the iTunes API, which can stream on top of that. So there's a lot of very intensive things. Usually when I show people this demo, it's a lot of things that maybe they didn't know could even be done in a browser. Before making it, I didn't actually know they could be done in a browser. And so we'll kind of walk through how it all works. So if we look at like the profile page, it's got a lot of these very basic primitive elements, things like images, buttons, texts. All of these are provided by React Native, so you don't really need anything special to make them. But then when you dig into like the camera stream, and this is my Soylent collection, when you dig into the camera stream, it gets a lot less forgiving. There are so many native modules in this. So we have fonts, SVG, audio, and you might be thinking like SVG and fonts are very easy to do in the browser, and you're right. They're a lot harder to do natively, though. And so every single thing that you can do needs to have a library which works universally across everything. So if it's difficult on one platform, it needs a library so you can make it work universally. And then, of course, there are various libraries, like AR is a good example, that are platform-specific. AR stands for Augmented Reality. And we need a way to like get around this platform-specific functionality when it's not supported. So here I've got a pretty scientific graph, and it shows how AR probably works in the app. I use it for like face filters, like the dog filter in Instagram. So here we've got AR. Maybe we put it in a file called ar.js, and then it renders cool stuff. That's computer science. So then in web, where it's not supported, we might have a file called .web.js. And then the bundler knows to do some like bundler magic and resolve the file with the more platform-specific extension. So from a DX perspective, it's pretty straightforward to create and then to also circumvent features that don't work everywhere. And a really cool side effect of this is that PWAs, or progressive web apps, are extremely easy to build with this system. In fact, you don't really need to build them at all. They just kind of work automatically. And nowadays, a lot of people really expect all of this functionality in your website, like offline support and, well, mostly just offline support, right? So if we look at like this diagram here, I think safe area view is a really good example of this. It's something that you don't think about when you actually develop your website, because you have a URL bar, which prevents you from getting into the notches. But when you make a native app, you have to think about the safe area all the time. And that means that all the libraries, like navigation, they consider the safe area, and lists. So if you build a native app and then you run that in the browser, when you make a PWA, it kind of waters down any features which aren't available, but then you kind of end up with this PWA which looks pretty much identical to your native app, which is really cool. So you get things like the splash screen and the app icon and offline support all just kind of bundled into it by default, because it knows how to do that automatically, like you already built it in there. So let's take a look under the hood really quickly. That's like a car reference. Let's take a look under the hood, and I can explain how it got to be easy, because it was not always very easy to use. So who here knows what a bundler is? OK. And who here knows like how that bundler works? Nice. So for the people watching on the stream, everyone just raised their hands, because they can only like see my face. But I will explain how a bundler works. So essentially, a bundler is like the build step for your project. It's going to take all of the files and put them in one big file, and then it will remove all of the code that you're not using, or at least it will tell you that. And then it will minify it and break it out into smaller files. So there's a lot that can go wrong there in that build step. And something that I found, like maybe the only thing more inconvenient than working with a bundler is working with two bundlers. And React Native, it uses this bundler called Metro, which is a custom bundler made at Facebook, and it exists. And then the rest of the React Native, or the React community, uses Webpack, like Next and Gatsby and Storybook and Create React App. Everyone, I love Webpack. It's awesome. So for the web projects, we use Webpack, and then for the native projects, we use a totally different bundler. So getting that configuration to be right can be tricky. And as much as I love Webpack, it does have kind of an issue with it, and that issue is that it's very difficult to use. There is a lot of configuration, and if you want to get started with React Native for Web, you need to remove all of the iOS and Android code from your project. All that happens in the bundler. You need to remap React Native to React Native Web. So you kind of need to have like a pretty thorough understanding of how Webpack works, even just to like get started using it. Whereas with Next and Gatsby, you don't really ever touch the Webpack config unless you need to. And then to add on top of that, if you wanted to use React Native for Web with any of your favorite tools, which why wouldn't you? They're awesome. You have to now take their proprietary config and mix it with your config. And so that pretty much just requires a very thorough understanding of how it all works. So maybe you can kind of start to see why it hasn't really taken off as much as it should have, or at bigger companies where they've got very talented engineers, why they love using it, and then anyone passively using it for a side project is not picking it up. But it doesn't need to be that way, right? We can make it easier. So I actually have a thing here where I can demonstrate how easy it is, but I don't know if I'll be able to get that showing. I'll probably go over here, mirror the screen. Cool. All right, there was that demo I was going to show you earlier. So right here, this is a website called snack.expo. If you're familiar with Code Sandbox or CodePen or JS Fiddle, it's a code editor in the browser. The only difference is this one is it lets you write native apps. In fact, this is probably the easiest way to make native apps because you can just hit this URL and start coding them. But we added the web feature to it. And if I open up the file browser over here, you see there is no Webpack config, no Babel config. You can add them and then start extending it. But you do not need that by default. All of that functionality has very meaningful defaults, and you can build on top of it. And then you can just start coding it live in the browser. So I can add a bunch of random junk, and it'll update over here. Or if I wanted to add a camera, like I could import the primitive, import camera from Expo Camera, and then just export that object, like that JSX. I'm going to actually open this one over here in like another browser window. And just like that, it is now running a universal camera, which runs the same way on iOS, Android, and web, and any other platform which Expo chooses to support. That's a really bad angle of me. So it's that simple to just use these primitives, just roll them into production. If I kind of add this back, maybe I'll like add the camera in here. Oh, dang it, I forgot. I can't code when people are watching. So I'll add the camera, and then maybe I'll add like the blur view on top of it. I say maybe, but it's commented out here, so you definitely know I planned this ahead of time. So I'm going to just add a blur view on top of the camera just to kind of demonstrate how simple it is to do a lot of this stuff. Open this up in a thing over here. You don't usually need to open up the second browser window to do this. This is just unique to streaming it. And let's start cutting out features till we get to the a working space. So here's the camera working. And then if I add a blur view on top of that, now it is blurry. And as you can see, you can just kind of construct these advanced primitives all on top of each other. And it's a very simple, very easy to use system. So I'm going to jump back over to the presentation now for a second. Well, actually, while I have it open, I'll just show you some like examples of how this works. So like here's a game that I made with Expo Web. It's really cool. It's called Crossy Road. It's based off another game that already exists, which yeah. So I cloned this using it just kind of to demonstrate that you don't, like it's not limited to UIs. You could also build games using any of the awesome game tools that already exist. So like this one's made with 3JS, and I fell into the water, and these are all React Native views that come on top of it, and it's very bright and colorful. So you can make really any kind of thing that you want with it, and this runs the same way for iOS, Android, and web. I tried to put it in the App Store, but as you can imagine, they did not approve it because it is a copyrighted thing already. So now I'm going to switch back over to the keynote. That's the part where I talk about the video games. And now I'm going to talk about what is next. So what can we do with this? Where's the roadmap? Where do we want to go with this in the future? In the first place is to stability, right? We want to move it out of beta. There are still some open questions about things which don't make a lot of sense universally. The biggest one is just navigation, because navigation for mobile apps is very different from navigation in web apps. Like here we've got stack navigators, we've got tab navigators. These are all way different than routing, because like a stack navigator, you kind of load all the pages into memory, whereas with a web page, you just switch to whichever page you want. Another cool native navigation thing is shared element transitions, which is when you take one element on the page and you move to another page, and that element comes with you. This is something which is a part of Expo. It's in this library, React Native Shared Element, and it's already in React Native, so it would not be too difficult to add it to web. And it is, I mean, it looks awesome, and it's got like anime, so I would also like to have it working in web. And just like going forward from there, Expo kind of made it very easy to, probably the easiest ever, to build an iOS and an Android app using the same code base as well. And now with web, you can render to all of these new browsers, and all of these new targets can run your app. And it's not too difficult to see how you can add desktop support from there, maybe using Electron or Project Catalyst, which is Apple's new way of running iOS code on OS X. And then just building out from there, there's a lot of ways that you can add and extend this. But whenever you add a new platform to Expo, your existing Expo app, it doesn't need to be updated in any way, right? It just, that same primitive code will apply to whichever platform Expo supports. I like to think of it like when you write a JavaScript app, you don't think if it like targets Skia or something, you just know that if it runs on Chrome, then it will run wherever Chrome runs. And it runs like that, except fully natively with access to all browser and DOM features. So anyways, in summation, that is why I think Expo, now with the addition of web, is how people can truly write their apps once and run them everywhere. And that's all I got for you guys today. Thanks so much for listening. You guys have been great. I'm going to be around answering questions. I'll also tweet out the link to the slide and to all the websites and things that I mentioned in this presentation. And yeah, if you guys have any questions, feel free to let me know. I'm done talking now.
You can hear me. You can hear me now. That was Evan Bacon. Evan, come here. I want you to see what he is wearing for his shoes.
Oh, yeah.
That's the real dedication to our cause here, so thank you for doing that.
Oh, yeah, that's what I was doing.
So I know we have 2 questions for you. Dude is asking, so Expo is nice to show components, but what is about routing, React Router? Is that possible, or will it route to a different domain?
Was that asked before the navigation part? I think there is still like this kind of open question around like how routing will work with native navigation, but I think that there is something that we use called a switch navigator. We're also investigating more lightweight options besides React Router, but currently the way I recommend people do things, the way that a lot of websites are using Expo Web right now, is they are just using React Router for web, and then they're using a native solution like React Navigation for their native router. And it works for them.
And then we have a second question. Are your implementations of Instagram and Crossroads open source?
Of course, it's all open source. I'll tweet out links to it. The people who make Crossroads have asked me to take it down a lot, so maybe they will after they see this. But the Instagram one it's open source as well, and it's all on my GitHub, and you can just get all the code there. I don't really close source anything or even have a pro GitHub account.
Well, thank you so much, Evan. It was Evan Bacon, everyone. I'm sure he's going to stick around. You can ask him more. You can build Lego with him at the Social Baker stand. So as you can probably smell, we are approaching lunch. And I will invite my helpers here on the stage and someone who can bring me a clicker to the presentation, which is on the table right there. Thank you, Mickey, the captain. kept on herself. So maybe you're wondering, who are those people? It's fruit, obviously. So now, if you are sitting on yellow chairs, you will be following a banana. If you are sitting on the black chairs, we didn't have red chairs, you're going to follow strawberry. The lunch is happening on the first floor above you. So you will all go back to the staircase and then follow your own fruit. Don't worry, the food is the same on both sides. There's plenty of food for everyone. It's basically like an airport-style, buffet. And there are plenty of options for you. We have vegan, vegetarian, gluten-free, and lactose-free, so all will be satisfied. So please, fruit, if I can ask you to go down the stage and lead our friends to food. Enjoy your lunch. Be back at 2 p.m. I cannot wait to see you back here. Bon appetit. Thank you for the applause. Ladies and gentlemen, my friends, we are the most time-managed conference ever, and we actually managed to finish 5 minutes ahead of the time schedule. So the catering needs a little bit more time to be prepared. So just if you can hang out and meet your friend next to each other and do a little networking before your tummies get some food in, it will take just 5 more minutes. Or see our partner stands, check them out, see what the games they have, our presents and gifts for you. In 5 Before we start with our talk, so feel free to grab a coffee or anything you need, and we're going to start shortly. Oh. All right, we are back to learn more from one of each other. And my next speaker, Gleb Bahmutov, is a JavaScript ninja coming from Boston. And his son loves to buy him funny socks for presentations. So, Gleb, would you mind showing your socks today? I don't know if you can see that. These are fishing
hooks. Fishing hooks. Hooks, yeah.
So I hope you will enjoy this presentation. Gleb Bahmutov.
Thank you. Hi, everyone. It's a pleasure to be here. I'm Gleb Bahmutov from Cyprus. I live in Boston. I work at Cyprus remotely. And I will talk about the state of art in end-to-end testing. But before I do that, I have to talk about very something important. Our planet is in immediate, imminent danger. Like the heat waves during the summer, Arctic without sea ice, burning California right now, India, Bangladesh running out of water. The system is broken. And imagine the heat wave that you experienced during the summer lasting for 1 month. It kills all the crops. What's your plan? What's your plan for melting Arctic and the sea rising 50 meters? And I'll tell you, there is no fucking plan. So I'm trying to act and change my behavior today. So I only have one son. I'm cutting down on flying. I only use public transportation, try to eat less meat, solar farm, so on. And I'm trying to tell everyone to do the same, because we can all influence ourselves and our immediate family and coworkers. And finally, you have to affect the way the government acts. In the United States, I'm trying to lobby for carbon pricing, because I think we have technology to change our lives today, and the only thing stopping from changing and averting the global climate catastrophe is the fossil fuels that are trying to squeeze one more dollar before we all die. Here's my pledge. Here's my email, Twitter. If you're working on profit or non-profit organization that tries to change our climate and solve it, I will help you for free. I volunteer to help you with testing. It's always hard to kind of switch back from that theme, but it's serious. OK, testing is a drag. It slows you down. Oh, thank you. Testing is a drag. It slows you down. While you're writing tests, you cannot actually do features that you get paid for. And testing doesn't pay. It's like scaffolding. You have to build it in order for you to finish the building, but then you have to remove it because you're not selling the scaffolding. And finally, testing is boring. And I'm surprised so many people actually picked me, because I would expect everyone to be at a different stage. In this presentation, I will tell you how I personally avoid writing tests, and how I pick which tests to write, and how to make it fun. So I have a lot of open source projects, a lot of blog posts. I do run engineering at Cypress, so if you go on GitHub, give it a star. Every day, I'm working on test runner, coding every day. These slides are available on slides.com. And finally, if you want to argue with me or praise me, I'm on Twitter as well. So why are we writing tests? Well, personally, I know that I write shitty code. Every time I write something, it's not going to work. I know that. In any language, for any platform. I know it's not going to work on a second try or third try. So the only reason I write tests is because I know myself. So the simplest way for me to actually prove myself correct is not to write tests, but do a lint check. So in this case, I'm adding to VS Code, TS check, and immediately it shows me, hey, you messed up. Here's an error. There are a couple of linters. So I usually talk about linting pyramid. At the bottom, we have Prettier. Prettier reformats your JavaScript code so it looks uniform, easy to read. It's not an actual linter, but it makes the test, or your production code easier to read and easier to understand, and for bugs not to hide there. Then you have ESLint. This is an actual linter. It understands the structure of your code, and it can tell you you're using a variable that you have not declared. It probably is a mistake. And even above it is things like TS-check that actually use type information to test my code and tell me if something's wrong. And you can get all the benefits of TypeScript checks without writing TypeScript. So here's how you do it. You start with your regular JavaScript code, let's say a function add, and you write a comment. I know, a comment. Kind of weird, right? But in that comment, you can say, first parameter is a number, and second parameter is a number, and immediately you get benefits. Because if you hover over the function every time you use it, there is an IntelliSense pop-up that tells you, hey, this is what this function does. But it also can underline and tell you, hey, you're trying to pass a string, and this function expects a number. So you're doing something wrong. You can actually set it up as a precompiled step where it will type check all your JavaScript code and tell you all the places that you're calling function incorrectly. But this brings me to my biggest pet peeve with every project I've been on. Nobody writes comments, even when comments are that useful. So when we were working on our comments for Cypress, we made a decision that every method that the API exposes should be well documented. So anytime you try to write tests, you can hover over, let's say, type, and it tells you, here's what type does. Here's an example. Here's a link to actually find more documentation where we spend a lot of time writing docs for every command, because we know it's very, very important. I was thinking, why is it important? And I realized that I actually make more mistakes not even writing my own code, but more mistakes using someone else's code, or more mistakes even using my own code. So here's the situation. I write something, and I don't document it enough. I have confusing API. Maybe I have options that don't make sense, that are not named correctly. So 10 developers try to use that library. They all make mistakes. They all have to submit an issue, look at the code. And so what have I achieved? I became a 10x developer, which is my goal. But it's negative 10. I just slowed down 10 developers by writing bad code without examples. No one should be an Einstein to actually use your library. No one should look at the code and know the whole system just to fix a small issue. Please, make nice abstractions, document them to make yourself more productive. So use static types, linting, and please use more examples. I love looking at examples. When people talk about testing, they usually talk about testing pyramid, and they argue till they're blue in the face about types of tests to write. Should I write more unit tests because they're faster, or should I write more end-to-end tests because they're more productive? And I say, forget about all that. Like, stop arguing about testing pyramid. If you're writing code, you should test it. If you're writing API, you should test it. If you're writing a web application, you should test it. It doesn't matter how you call the test. It has to be a test. There's only a test, and only the thing that you doubt works. If your thing is a function, and you're not sure if it works or not, you write a test. If your thing is a component, in this case, a React component, you write a test. In this case, Cypress can mount this component and interact with the component, and you can run it, and it looks kind of like this, where you can see how your component reacts to events that you're sending. If your thing is an API, well, there is a plugin that I've written where you can call your API with given arguments, inspect back results, maybe even show log messages from the server side. I don't care how you call the test. I call it a test. If your thing is a complete web application, when you write a Cypress test, where you visit the site and you exercise that site, you drive it just like a real user. So if your thing is not a web application itself, but the style, the CSS, the visual appearance of your web app, you write a test. You just add plugins from other libraries that do visual diffing. So in this case, if someone submits a pull request, and the pull request changes the SVG field style color to something else, well, that test can tell you, pizza that used to be yellow now got a green crust. Is that what you wanted? And you probably will say no. Tomorrow, Gil Tayar will show how he does visual diffing and visual testing. So make sure not to miss his presentation. He's an excellent presenter. If your thing is not the web application and not its style, but its accessibility, you write a test. In that test, you can inject very popular X accessibility testing library and just check everything. For example, in this case, a color contrast. And it will tell you, hey, you cannot read it, right? Because the color contrast is so low. So the test will tell you your website doesn't pass accessibility test. You can always write a test. It's just a question is picking a right plugin that tests the thing that you're trying to prove works. With Cypress, we created a platform where people can write in JavaScript plugins that do all sorts of different things, more than we actually imagined. There are two things that people ask me about testing. What should I test? And how long should my test be? So what should I test? There are a couple of ways you can say you have to write new tests or the tests are duplicate. You can do it manually, carefully collect user stories, and for each user story, write an end-to-end test. But the thing that makes it difficult is that you have to maintain this one-to-one relationship as you add features or modify features or even deprecate features. For example, with To-Do MVC, you can say, well, what does it do? Well, feature A, user can add to-do items. OK, users can complete to-do items. And users can delete to-do items. Excellent. So we have 3 features, and we'll keep track of them manually. So we can write a test, and we'll take the feature name as the test name. So it adds to-dos is a test. It completes to-dos is a test. And then we can think, oh, wait, none of my tests is named delete to-dos. So we write one more test. And it's a very simple example, but I think in general it's a very hard system to maintain. Because it's easy to match one test to one feature, but once you start writing a couple more features, more tests, it becomes harder, and after a while, you just get swamped. You cannot maintain this thing manually. I don't know what happened there, like this is weird. OK, so we need an alternative. Alternative is to automate this feature mapping to tests. We can collect code coverage. We can instrument our application code so we know which lines of code we executed during the test. So imagine you starting to implement this app, and you say, feature A, user should be able to add items. So you write some code, and then you implement the second feature, and you write some more code. You maybe change old code. And then you implement the last feature, which also adds code. And then you run end-to-end tests. And because your code is already instrumented, you can tell which lines of code those tests touched. In this case, marked in green, and the rest is red. And you're like, oh, the red lines are features that I have not tested, and you play Sherlock Holmes, and you figure out what tests to write. And you write one more test, and now you're covering all the lines. So that's how code coverage works. And it's not direct measurement, right? Because it's indirect measurement. You know that those features are implemented in code, and you know this code gets executed when you run those tests. And people strive to get 100% code coverage. But it doesn't mean that once you get to 100% code coverage, that you'll have 0 bugs. But one problem is that your code might not actually implement the features correctly. You can still cover the code, but that code is doing the wrong things. And the second problem is that your end-to-end test cases might be unrealistic. Yes, they're covering the code, but for example, they use very simple email. So if a user uses a realistic email, your code might not actually work. So 100% code coverage doesn't guarantee 0 bugs. So for Cypress, we have written a code coverage plugin where you instrument the code, which is very easy to do, and then that plugin does the rest. Here's how it works. You write your test. It's a single end-to-end test where the user visits the site, finds the input box, types 3 to-dos, and then checks that there are 3 to-dos in a list. And we found that end-to-end tests like this one are extremely efficient at covering a lot of application source code in a single test. This one test, if you look at the report, covers 72.5% of all application code. Just a single test, because the whole application has to load, initialize, start processing events. And then the code coverage and 100% is not the goal of itself. Instead, you should use that code coverage report as a guide or as a map to which tests to write. So in this case, if you look at this test and you look at the report and you look inside each source file, inside that report, you will see which lines were executed. In this case, I'm looking at the Redux store for that application, and I can clearly see that the case add to do was covered, because my test really added 3 to-dos. And in yellow, you see the switch statements that were not executed. And in red, you see the source lines that were not executed by this test. So you can see we need to write tests that delete to-do, edit to-do, complete to-do, and so on. It becomes almost like a game where you just see the lines that you have not tested, and you write an end-to-end test to hit those lines. So I've written more tests, and I get 99.26% code coverage just from end-to-end tests. Except there's one tiny problem. I can see that one file missed something. So if I look inside that file, I can see a default case statement. This little file implements the view filter. Do I want to see all to-dos, active to-dos, or completed to-dos? And everything is fine. The end-to-end test is correct. It's just this default statement is not reachable from end-to-end interface, from the user interface, because my application is actually wired correctly. So in that case, I don't have to write end-to-end tests. I have to write a unit test that just executes this piece of code and hits that line. So I write unit test by importing that class directly and calling it with invalid filter. And Cypress can run unit tests just as well. In this case, there is no website, but it does execute your code, and there is code coverage information. And when I look at the report, I can see that in this particular unit test, I hit just that line. It was very targeted, specific test. And the cool thing is that Cypress can combine information from end-to-end tests and unit tests. And if you look at the combined report, you get 100% code coverage from your tests that run by Cypress. But wait, there is always more. So usually my web application is not just a static site. It's not just a web application. It has a backend. And if we're writing our front end in JavaScript, we probably are writing our backend in JavaScript using Node. So if you instrument your Node code, your server-side code, in practice, it's really easy. So here's how you do it. Instead of saying npm start and running Node server, you're saying start with coverage, where you run a tool called nyc, and you say instrument and start my Node code. That's it. Behind the scenes, nyc will instrument every loaded file, so when my backend is running, it actually collects code coverage information. And Cypress implements middlewares where you can just import depending on the server that you're using, but can return that code coverage information. So when the tests finish, Cypress code coverage plugin will ask, hey, give me everything from the backend side that was covered by this test. And then it just combines everything. And now you get full stack code coverage from the same end-to-end tests. In this case, 91%. Again, you don't have to exhaustively write the tests, because end-to-end tests are extremely effective at covering all parts of running system. Even more, tomorrow, make sure not to miss David's presentation. So he's advocating and shows examples and has libraries that show final state machines that can drive application. And if you can derive your application from final state machines, you can also derive your test automatically from that final state machine. It becomes a graph problem. So in this case, those tests are not written by me. Instead, I ask the final state machine, give me all the possible paths for a tic-tac-toe game, give me all the draws and a single win for X and a single win for O, and then Cypress runs those tests, and these tests were automatically generated. And I know that it's exhaustive set of tests because it's exhaustive set of paths in that final state machine. Excellent. So please use code coverage not as a goal. Don't strive to kill yourself achieving 100% code coverage. Instead, look at the code coverage report and use missing lines as a guide to the test that you want to write. Don't look at the number by itself. Don't look at 92, 94, but instead, on every pull request, try to see if there is sudden change. If that number drops on a pull request, you probably have written code that you haven't tested, or you omitted some necessary tests. So it's the delta in code coverage that matters, not the number itself. And finally, I'm really interested in looking beyond this simple lines of code coverage number. So state machine code coverage is an important metric, I think. And the second question that people ask is that if I'm writing lots of tests, some of my tests are short, some tests are long. Usually end-to-end tests are more realistic, so they're longer. How long is too long? So a lot of unit tests, a lot of short tests that we write are very short. And they follow a couple of steps. So first, they arrange some data. We may be importing a function, set up arguments. When they call that function with arguments, they act. And then they get results, and they have a single assertion. And I think those tests are short and have usually a single assertion, not because it's useful, but because most of tests so far that we're running run in a terminal. So if a test fails, it becomes extremely, extremely difficult to debug a long test because it might have multiple assertions and multiple points of failure, because we would have to rerun things in terminal, maybe enable debug logs, concentrate on that particular test. So the terminal is not a good environment for running tests and debugging their failures. And I'm here to tell you it's OK to write longer tests if you have a better test runner. It's fine. Start writing tests now. Write realistic tests. A test that represents a typical use case, where a human comes in and uses your system. In this case, I'm testing a medium clone, right? Where I'm writing a new blog post, I'm filling all the fields, and then submitting comment, because there is a command log on the left. Right now, I'm hovering over each command from my test, and it shows how the app looked during that step. I can even click on a command, open DevTools, and debug, XHR call, for example, in details, and see everything that the application and my test performed. So if there is a failure somewhere in the middle of a test, I can debug it easily. I can see the behavior of the app, and I can understand why it failed even before that assertion at the end. And still, it's easy to get carried away. Everyone has their own time tolerance, but I would say that for me, anything longer than 20, 30 seconds is way too long of a test to work with effectively. Because every time I change something, it has to go through 30 seconds of stuff before I know if my last command is passing or not. So here's a typical example. Imagine you're testing this multi-page form, so you fill all the fields on the first page, click Next, fill all the fields on the second page, click Next, and then fill everything on the last page before you actually click Sign Up. I slowed down typing here just to prove my point. So this is way too long of a test, and it goes through the setup of multiple pages just to confirm that the sign up works. What can we do to make it better? We can split it into 3 tests, but wait. If I'm filling each page separately, how would my last page get all the data that it needs to sign up? Well, the way you do this is that each test ends with a checkpoint, almost like a game checkpoint where you save yourself and then respawn later. Every new test doesn't start from the very beginning. Instead, it starts immediately from the previously saved checkpoint. Here's how it looks. In my application, if I'm running inside Cypress, I will expose the app reference variable. Now my tests can access the application. If they can do that, then I can write a first test that only fills the first page, goes to the second page, and stops. And at the very last command, after it stops, it grabs the window, grabs that app reference, accesses the Redux state, and makes sure that it's correct. It does deep equal and has a big object with all fields that I expect that form to fill. So I know my test goes through the page and ends in the same internal application state as I expect it to be. And here's the start of a second test. The very first command my test does, it goes to the window, grabs the application reference, and in a single call says, set your internal state into the checkpoint object. And then it starts filling the fields. So here's the second test, and here's me hovering over just set state command. You see how the application immediately switches from first page to the beginning of a second page, and its internal data is set exactly the same way as if it filled everything on the first page. But now I kind of respawn at the start of a second page. And to the application, makes no difference if I fill the page or just reset the state. Every state starts at the last checkpoint of a previous, almost like relay racing. So I want to finish with a summary. Please, 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 document your code. If you're writing JavaScript and I look at your library and it doesn't have examples, I'll be very angry, and I don't want to be angry. The code coverage that I've shown is not a target of itself. It's just a tool for you to write tests that cover something else and don't repeat themselves. And finally, don't accept slow tests. There are better ways to test, so you don't have to wait for hours and hours and hours for them to finish. Thank you, and shoot for the stars. Thank you.
Thank you so much, Gleb. We actually have a bunch of questions for you.
Oh, wow.
So we are not going to be able to answer all of them, so let's start. What do you think about mutation tests?
I love mutation. So mutation testing means you take the source code of your application and then randomly change variable or command, and then you run all your tests and you see if tests actually fail, if you actually detect a mutation. And if they don't, that means your tests are not covering your application very well. So I'm all for exploring mutation. I didn't have time to implement it yet, but if you want to talk to me, I'm all for it.
Next question. Does Cypress support other browsers than Chrome? If not, then will be in future?
Are there other browsers other than Chrome? I don't know any. No. So we support Chrome. We're coming out with supporting Edge, Beta, and Brave because they actually run on Chromium. But we have a pull request with Firefox support. We have 3,000 full browser tests passing in Chrome, and out of 3,000 tests in Firefox, we have only 15 failing. So it's like this close, this close. We're coming out with Firefox support.
Can I use Cypress to test React Native?
No, so Cypress is only for anything that runs in the browser. If you haven't converted your React Native to the native app, you probably can test it in the browser. But after that, unfortunately, no.
Checkpoints are only working with Redux. How would you do it with React context?
So the checkpoints it's just an example that I used. Every application where you can control it, you can control it from end-to-end test and set its state or set its internal properties. So it should work with every platform. We have examples for Vue and Angular and anything under the sun.
How to check if my test is good, the quality of it? I have doubts that I'm testing right, and it disappeared. No, it's there. Testing right things, right scenarios.
I would say the person who doubts that they have written a good test and they're actually trying to see if it's good, it's already on a path to writing good tests because they're doubting themselves and they're trying to improve. I'm not sure what makes a good test, but I think if you review the test with your team, just like you review your production code, you can agree on a quality test.
Does Cypress support integration in,
Yes.
Did I skip one? CI/CD?
So you can run Cypress on your machine locally on every continuous integration platform. Go to our docs. We have example and running on every platform, including GitLab.
How does Cypress mock calls to and from API?
It mocks them beautifully. Go to our docs. Look at the documentation for network stubbing. You can spy and stub on AJAX calls from your application. We're coming with a feature where you can use stub and spy everything, like everything.
Is Cypress using Percy for visual tests?
Cypress is just a tool, and then there are plugins for visual testing. So Percy has written their own library to make sure that when Cypress runs, it sends the thing to Percy. Applitools has written a library for Cypress as a plugin, so you can send things to Applitools. There are open source image comparison libraries where Cypress can generate a snapshot, and that library will do visual diffing for you. So it's both commercial and open source things. Just go to our plugins page to find them.
Is possible to test React TypeScript with Cypress?
Yes.
All right, this is quick. We have problems running Cypress tests on a CI. Requests often time out when doing CY wait. Is this a known Cypress problem, or could be something on our side?
Do you remember I said that I write bad code? Right? So I've written bad code and it fails, right? If you give us a reproducible example, we'll debug it and we'll fix it.
Is Redux checkpoint state committed to versioning system? If yes, isn't it too hard to maintain this test in long run as store is extended?
Yes, so you commit it because I used it as an object. It's up to you what to do. But if you, for example, use just match snapshot, it's kind of the same thing. You have a trade-off between large fixture objects versus the test. So you have to pick your battles.
Is it possible to extract test results in e.g. GUnit format or code coverage in different formats?
Yes, so the Cypress plugins save the coverage report in multiple formats, and you can configure additional ones, so you can send it everywhere.
I'm going to say last 3 questions. How do we E2E test and slow API?
OK, you don't. If your API calls end-to-end are slow, you mock them.
Who should rate Cypress test front-end developer or the QA?
I think the developer who's working on application should write end-to-end tests. I mean, QA can write them, but when you're working on a tool, the tests help you to actually write better code right away.
Last question, Gleb. What about integration of Cypress with visual regression testing, like taking screenshots when running some tests and comparing images?
Just like I said for Percy and Applitools, there are plugins that use open source local tools that do image comparison. So just go to our plugins page, or we have a visual testing guide in our documentation that covers pretty much every scenario.
Thank you so much, Gleb. As you can see, there's so many questions for you. So I'm pretty sure that if you are interested, Gleb, you would be willing to answer questions personally in a foyer, right?
And I have Cypress stickers if you want one.
There you go. All right, we have to move forward. Thank you so much. That was Gleb Bahmutov. One more time, he deserves that. We have now 4 lightning talks. So they will be really quick. Each of the speakers have 5 minutes to talk, 2 minutes for questions. So without further ado, well, let me remind you one more time, don't forget to rate the talks, please. Use the reactive bot as your chatbot, as you did right now with the question so well. Well done, well done, really. This was really great talk, a really great reaction from you too, and that's what we want to encourage, the interaction between all of us together. So, my next speaker, Javi Velasco. He works as a full-stack engineer at Site, and most people might know him as the author of React Toolbox that was used by companies such as Netflix and other open-source projects. He's very passionate about his job and tries to make the code look like poetry. That's my kind of a guy. He is also deeply devoted to his dog, Cora. Please welcome Javi Velasco.
All right. Hi, everyone. This talk is called the Monorepo Odyssey, but it's not going to be such an odyssey as we have just 5 minutes. But I hope you find it valuable anyway. That's my name, Javi Velasco. That's my Twitter handle, my dog. And as I said, it was said before, I work for a company called Site. In case it doesn't ring any bell, maybe some of the stuff that we're building sounds more familiar, like Next.js or Now. Now, at Site, we have, you maybe don't know, that we have a public API that you can use to build products around our API. From the very beginning, this was designed trying to embrace best practices. And when it comes to architecture of applications, like REST APIs, one pretty well-known architectural approach is the microservices architecture. Now, you don't need to be familiar with microservices and all, but this is the definition. It's an architectural style that structures the application as a collection of services that are highly maintainable, testable, loosely coupled, independently deployable, organized around business capabilities, and owned by a small team. I am most interested in the first 3 bullet points there because I am interested in the implementation. So for the case of our API, we have a gateway which is going to basically receive any request and then route it to the service that is responsible from processing the request and generating a final output. The way we split those services is not that important, but it's enough for you to know that we have like different projects, and sometimes it's just one endpoint, sometimes it can handle many different endpoints, but eventually we have separate projects, API domains, API deployments, API users, and so on. Now, the thing with this is that there is a massive benefit when you're using microservices, which is that you can abstract yourself from the language and from the implementation, so you can use different languages and so on. But in our case, we were not leveraging that at all. We were actually implementing our services using TypeScript, using JavaScript, more TypeScript, and then every single of them is a separate GitHub repository. So this is kind of accomplishing what we are trying to achieve with microservices. It is easy to test and maintain, it is loosely coupled, it's independently deployable, but there are also some problems that we encounter with that, and basically all of it reduced to the code reusability. Your services are supposed to be as independent as possible, but there are cases where you want to share code. And sometimes you also want to not share utility code, but business logic. For example, authentication, event publishing, or in our case, for domain business logic, creating an alias, that's stuff that can happen in every single service. And since we are using the same language, we are interested in sharing that code somehow. So this is also a collocation problem because we have so many different services that are modeled at separated projects that live in different places. So how can we try to solve this at first? We started, well, you know, everything was written in JavaScript and TypeScript, and all of them have a package JSON. So our first approach was, what if we get all of this logic that should be reused, put them in packages, and publish them to NPM? That is kind of not the best solution because you are publishing pieces that you want to share into repositories. and you don't even know sometimes what is the name that you want to give to those utils. So for example, you end up with auth utils, domains utils, search utils, and so on in your private NPM registry. But there's a huge problem with that when you're working. Imagine that you want to ship something that is reused in every single service. In that case, then you need to update the code in the utility package, publish to NPM, clone a dependent service repository, then you have to update the dependencies, make sure it works, release a new version, run the service, and repeat 35 times, so how many, depending on how many services you have in place. You can imagine that working with that is actually a nightmare. So one step to the right solution was using a monorepo. So we moved everything together, we put all the code together, but that's not really solving the problem anyway, because we still have to update the code in the utility package, publish to NPM. You don't have to clone dependencies anymore, but you still have to make sure that it works, and you have to do that for every single package. So eventually, the problem was that we had one system in reality, because many code was shared between those services. So we end up changing the build system, so we are still able to create these small bundles with just the code that the microservice requires and deployed it independently. We implemented also the dependency injection mechanism, and we added testing and some tooling around it, so we can do stuff that it wasn't possible before, like, for example, starting a dev server with the whole system in your local host. But most importantly, we model here a new abstraction, because now we are not thinking about servers, but instead we are thinking about request handlers. So in the end, we have benefits from all of this microservices architecture. We can still deploy independently. It's easy, but it's also easy to do stuff that is not that easy with microservices, like running locally, code reusability, and so on. So that was my 5 minutes. Thank you very much.
Thank you so much, Javi. Do we have any questions for Javier? Yes, we do. What monorepo solutions have you tried, and which do you feel fits best the front and life circle?
Well, first of all, this is not actually living in the front end is not living in the system. This is like the API system. We tried out Lerna, and I think we also tried to combine with Yarn workspaces and stuff, but it didn't really serve to the purpose that we wanted to achieve in the end, because what we wanted is to get rid of packages. Internal packages were just like the workaround to make it work with different services that are separated with different packages and so on. So we just removed that, and we don't really need that monorepo solutions.
Thank you so much, Javi. That will be all for now, but please don't hesitate to ask you more questions, because he's going to stick around. We're going to move forward to our first Czech speaker. This is such an international conference, so it's exciting to invite on a stage Ladislav Navratil, who works as CTO in Nangu TV, company which generates 70% of Czech internet. But today he's here to actually introduce his own project. Please welcome Ladislav Navratil.
HDMIčko tady. Super. Hello everyone. How are you doing? I hope that you are enjoying the conference. My name is Ladislav Navratil, and today I would like to introduce you my new project, Unlim. Unlim is the best place where developers, designers, and product managers can collaborate together. It gives you instant preview of your project for all your team. Normally when you want to show your progress on your project to someone, you have to build it. You have to deploy it somewhere, and you have to notify the user that you have new version. Usually you're trying to automatize this kind of things, but still you have to maintain it. And you don't need to do it with Unlim. It does that all automatically, right above your Git, without any pre-build and any deployments. So how does it work? You can take your existing project and just drag and drop it to the Unlim. It works out of the box without any special setup. Unlim analyzes your project, understands what it needs, what kind of development tools, what kind of dependencies, and install it for you on the background. Also, it's adding the Unlim tooling. Don't worry, it doesn't touch your code too much, and it lays next to it and just extends it. So, after you and all the users which you invited, you receiving the live preview of your application. And because it lays above your Git, you can even travel back in time and be notified when there is something new to check. It also understands your media marks in your project and showing you that your application behaves differently on different devices, so you can interactively check out how does it look, if it's all right. It's also bringing the presentation mode. So if you want to show your project to someone else, you can do it in this presentation mode to bring bigger impact to it. But most of all, it's a collaborating tool. So the designers and product managers can review it and write the comments, like what should be changed. And it can even create the issues in the GitHub for you. And it's also tracking the issue. So if someone comments it or just making the work done, you are getting notification that this is done and you should review it again if it's all right. It's doing all automatic. And it's not ending here. There is more. There are some features which I would like to show you, which will be public a little bit later after the launch. One of them, you can select any component in your project, because Unlim recognizes the components and show you the name, description, its preview. It's showing you all the APIs, what you can do with the component, all the internal states of the component, and where the component in your application is used. It's also creating component library for you, so you can see all components what you're using in your product. The same thing it's doing with the styles. It's creating automatic style guidelines for you. So the designer can come and check if all the styles are correct. And don't forget, this is above live project. It's not in the tools like Zeppelin and so on, where you're working above the graphic. And right now, it will get even more crazy. Because of the Unlim tooling, you can even change the styles and see how it will happen in the real life in the application overview. So you can change things like styles, text, and other things, and see immediately. So this orange color, it's out. So this is Unlim. Let me a little bit summarize it and wrap it up. Unlim gives you instant preview of your application within your team. It works out of the box with your existing project. It creates component library and style guides in one place. And last but not least, it lets you collaborate together to create the best product possible. So please visit unlim.io. We're launching soon, so subscribe to keep updated. And let us know. It will be amazing if we'll be the first people who will try it, and let us make this product even better. Thank you so much.
Thank you, Ladja. Don't leave yet, because we do have questions for you. So,
Perfect.
what technology stacks are supported by Unlim?
Great question. We're starting with React, but another technologies will come after that. We're for sure counting with Vue.js and most probably with Angular. We're trying to focus also for mobile applications, but it will be a little bit harder, but I think that one will succeed.
Is it running on Chrome or something else?
No, it's a native application. Basically built on the Electron, but it's a native application in your computer.
How does it work with secrets and other required API credentials?
I don't know which API credentials. Basically, the application have it inside. When you have it built in, the configuration for a project in the Git is there. If you have something of pre-building, we don't support it yet. A good point, maybe.
Can Unlim connect with online repos and update automatically when repo is updated?
Yes, this is the main thing what it does.
That was a question, is it free?
We don't know yet. This will be a little bit what we have to figure out. It will for sure be in some free version, but we will search for the model, basically business model behind it, most probably in some collaborative way of for the bigger teams. But it will come free on the beginning for sure, and it will stay free for some limited usage.
Last question, what about REST API?
Which one is it?
What about REST API is the last one. It's on the top of the page.
REST APIs. Yep, it works with them. Like it's how you program it, right? It can work with GraphQL, REST, whatever. It's not something together with it, I would say.
All right, thank you so much, Ladja. I believe you're going to speak tomorrow again, correct?
Friday.
So if you have more questions, obviously he's going to be hanging out around, and also you can catch him on Friday. Thank you so much. That was Ladja Navratil. Thank you so much.
Thank you.
Let me introduce to you another speaker, and actually, he is an MC at the Discovery stage, and also he's a team leader at Social Bakers. His name is Gil Goldman. Gil built a robotic microbrewery. He likes cats, dogs, and for some reason ducks. I believe he has a very special good luck talisman in his jacket that he will show you later. The talk name is Giant Cows, Flying Rabbits, and the Moon. Humor and the unexpected as tools for productivity. Please welcome Gil. Gil Goldman.
Thank you.
Lajana.
So first off, thank you very much, Pavlina, for that wonderful introduction. Give it up again to Pavlina. She's doing amazing work here on this stage. Wonderful work, and thank you very much. Basically, I'm here to pitch to you an idea. But let's start with a story. It's hot. It's humid. You are in an undisclosed location in one of the most top-secret facilities in the world. You're inside a simulation, and you're learning how to operate a tank. You can feel the sand, you can smell the grease, and you turn a corner in your simulated tank. And something's not exactly right. Something feels a bit off. Something doesn't really sit together in your perfect simulation, super accurate world in which you're supposed to learn how to drive a tank. Something's weird. So when we looked at this, we consider enormous cows as a terrible failure. I mean, look at it. It's enormous. It's huge. This is not a cow. This is not to scale. What's up here? So we were embarrassed. This is a failure for us as developers, but the soldiers loved it. To them, this was wonderful. They laughed at this so much, they remembered it for weeks later. They remembered the simple comms training they've done because of the giant cows. This is ridiculous. They loved it. We saw it as a failure. They loved it. Basically, my name is Gil Goldman, and I'm working with companies on making work more engaging and a bit more fun. I've recently worked at Bohemia Interactive Simulations, and now, Social Bakers. So, I'm here to pitch to you an idea. By pouring some of yourselves, a bit of you, into the code and into the work you're doing, we can guarantee a better product, a better working environment, and definitely a lot more laughs. Example number 2 has to do with this lovely picture inside one of the world's best simulations. This came to us from a customer who shall be anonymous for this chat. They've given us an enormous mission with thousands of simulated soldiers and tanks and airplane and naval forces, an enormous 2-hour-long exercises that kept on crashing at the exact same point, and we had no idea. We've been debugging this for weeks until we finally figured out what happened. one of their developers wanted to have some fun. Let's make this realistic. This is a simulation, after all. So they've added rabbits. And they had little rabbits scampering around, running around. And one of them had a trajectory plan for it to go left, and then to go right, and then climb up a hill. And it climbed up a hill. And it kept climbing. And it kept on climbing forever, and it started flying. It flew all the way to the end of the simulation, reached the top of it. The engine looked at it and said, well, this is at the top of the simulation. This is obviously a soldier dropping from an airplane. Let's open a parachute. Wait, this is a rabbit, this is a parachute. Everything crashed. We would have never tested for that. Nobody in the office, and we're all crazy, no one thought about dropping bunnies from airplanes. But the customers did. By putting a bit of themselves into their code, they've made our product better. And this is not new. Everybody has been doing this for years, some of the best and the brightest. NASA has been doing this. This is actual code snippets from the Apollo 11 navigation computer. Temporary, I hope, temporary, I hope. This is the final code, the temporary, I hope bit. Off to see the wizard. NASA code. This made it to the moon and back. And this is not just a long time ago. This is still being done by some of the best and the brightest. This is the meowing duck of Amazon. Amazon has this in their source code. You can go there, you can find it. It's lovely. And it's not just me saying this, it's basically science. Doing things a bit differently and a bit of yourself. Pouring that silliness that is inherent to all of us as developers into our code makes our work better. And some of you might still not believe me. So, all of us know this, don't we? And we all know this because someone at Oracle wrote something and left, and nobody knew what he wrote. But everyone remembers him. So, pour some of yourself into your work. It will make a better product. It will make the working environment better. And we'll laugh a bit. Thank you.
Gail Goldman, thank you so much. We do not have any additional questions.
Perfect.
Did you show them your duck, though? This is his good luck duck. Thank you so much.
Awesome.
As you know, as I told you, you can catch him on the Discover stage because he is my fellow MC besides him being a team leader at Social Bakers, which you guys know, the stand for Social Bakers is right there. There's the secret elevator to the 3rd floor to the Discover stage. And now our last lightning talk speaker, Richard Feldman. This is Richard's 4th year speaking at Reactive Conf. He is an instructor for front-end masters and the author of Elm in Action from Manning Publications. So please welcome Richard Feldman.
All right, HTS on this side. Sorry? No sound. All set? All right, welcome everyone. This is Distributed Markdown Apps. I'm Richard Feldman. So like many people, I have a blog, which I don't write for very often. And also like many people, I know what you're supposed to do right now if you have a blog, which is to say you're supposed to self-host, get off of Medium and off these platforms that take all your monetization opportunities away from you. And you know what? I'm going to get on board that train. I know it's time. I'm going to self-host, I'm going to build my own stack, and I'm going to put rtfeldman.com on there on my own stuff that I coded. Which immediately leads to the next question that I will do instead of writing blog posts, which is figure out what is my tech stack going to be. Now I'm thinking like, okay, I know there's all this stuff out there that's like really, really cool, but you know what? I don't want to over-engineer this. I want to keep it super simple. So I'm just going to start with just Markdown, like plain old Markdown. Like Markdown's great. You know, you write stuff really concisely, really nice looking code, spits out stuff that looks really nice. It's really great for static content, and this is a blog. That's all I'm doing. It's static content here. Cool. Markdown it is. So I'm thinking about tech stacks and like how my stuff renders, and I realized, you know, so I use this thing called Instapaper. Anybody here use Instapaper? Yeah, okay, so it's a couple people. It's basically something where you get to look at articles in the style that I want. Like it's all about looking at somebody else's content using my style as the reader. So it's about taking somebody's content, putting the reader's style on it rather than the author's style. And now that I'm thinking about this from the perspective of an author, I'm like, that's like, I kind of like that, but also kind of don't. Because like, I mean, I put all this thought into how my blog post is going to look and the style and the look and feel of it. And it's kind of an expression of my personality. Like, you know, I like to have the title be green because I like the color green. It like goes with my hair, you know, and stuff like that. And it's like I want that to kind of come through for the reader, and I really don't want them to override all of that. Like, what if they don't care about the title? What if like Instapaper could have like a default style and say like, okay, the author gets to say this is the default, and then the reader can override whatever they don't care about. So maybe my personality can come through just in the title, but not in everything. I think that'd be kind of nice. Maybe that's a nice feature suggestion for Instapaper. Anyway, enough of that distraction. Let's think about this blogging engine. So I'm thinking about this. I'm like, you know, I'm gonna want to spice this up though. I'm not just gonna want to have plain old blog posts. I want to add a little bit of spice to the end of each one. I want to add a random Douglas Adams quote to the end of each blog post, something like this. It'll just end at the end of each blog post with just a nice Douglas Adams quote. It'll just be randomly selected. And I'm like, I'm a programmer. I don't want to do this by hand, copy paste, like find a quote each time. No, I want to have just like a repository of quotes and have my system just automatically inject one at the end of each post. And so I'm like, okay, well, what technology should I use for that? And I'm like, again, don't want to over-engineer it, don't want to get too overcomplicated, just gonna write a bash script for it, you know? Bash is great for small scripts, and that's all I need. And then I'm like, okay, but now I'm thinking about how am I going to monetize this thing? Because when I'm writing all these blog posts, they're going to get millions and millions of views. I know this. And so I'm going to want to monetize all those views. So I'm thinking, okay, I'm going to sell T-shirts. That's like the best way to monetize a blog, obviously. rtfeldman.com T-shirts, you know, coming to a store near you. But by store, I mean like I'm just going to put on some online thing. And so I'm looking around at these like online stores. I'm like, man, all these checkout systems, like they want to take a cut of my money. It's just like Medium, man. They just want to take some of my monetization away from me. Forget that. I'm going to roll my own. I'm going to build my own checkout system for my T-shirts, for my blog, because that's the whole point of all of this. So I'm like, cool, I'm gonna like make a shopping cart. And then of course the next question is like, well, if I'm building my own shopping cart, what's the tech stack gonna be for my shopping cart? And so I'm like, all right. Well, look, I don't want to go and like get some really fancy thing. I already got this good thing going. You know, I already got Markdown for my static content. Checkout's mostly static content, like what are the prices, what are the images? And then I'm like, well, and then also, you know, I got Bash for my little small scripts. I could use that to make things dynamic. And then I'm like, oh, and actually, I can make things dynamic on the fly. That's like how we used to do on the web back in the day, right? Like if I combine Markdown for the static content and Bash, like as I get the HTTP request, dynamically decide which Markdown to render into HTML to send to the client, boom, I got dynamic content. I don't even need to change stacks. So then I'm like, cool, except oh, wait a minute, I forgot one piece, which is like as my shopping cart gets more complicated, the styles get more complicated, and then I'm like, oh man, okay, so like how am I going to deal with all these different styles that are going on? This is like a lot more complicated than what Markdown can do. But then I remember my Instapaper idea with the like default styles and reader styles. I'm like, cool, all these ideas, it's all coming together. This is great. If I put Markdown and Instapaper and Bash together, I can build a whole app. This is a great stack. And then this is when I get the like galaxy brain amazing idea. I'm like, this is not only a good idea for me, this is a good idea for everyone. This is gonna be the future. It needs a name. This is gonna be distributed Markdown apps, and it's gonna take over the world. This is gonna be like the way that people build applications in the future. I can see it just all over the planet. People are gonna be building these things and shipping them to everyone. It's gonna be amazing. It's gonna revolutionize the way software is built. I know what you're thinking. You're thinking like, whoa, dude, you've gone like way off the rails here. Like, what are you even talking about? Like, all of these technologies are being used for like the opposite of what they were designed for. Like, Markdown is for static content, not dynamic content, and not user interfaces. Like, Instapaper, the whole point is that it's the reader's style, not the author's style. And now you're using it to style an application. And like, Bash is for small scripts. It's not for building entire applications. Like, there's no chance that this is going to become the thing that takes over the world. And I'm like, really? That could never happen? Like, that's impossible? That would not... I don't know. I think there's reason to believe that could happen. That could actually take over the world. Now, okay. Now, I know what you're thinking. You're thinking like, okay, yeah, fine. But let's be real. Nobody's going to want to maintain like 100,000 line of code Bash. Like, no, that's just a disaster. Like, nobody's going to sit through that in real life. It's okay. I thought of the solution. Yeah. Thanks very much.
Richard Feldman, everyone. Thank you so much, Richard. If you have any questions for him, Don't hesitate to talk to him afterwards. We do have a coffee break right now for half an hour till 3:30. Thank you so much. Enjoy the coffee. We'll be back soon. more and more important and interesting information. I have to say, I don't think I've ever been into one room with so many smart people, and I feel really grateful that I can be here. The next speaker likes to be called Sir Brian, because he is the knight in an Azure order and swears fealty to Lord Clippy of House of Microsoft. Before obtaining his knighthood, he was a vassal in the great house of Netflix, LinkedIn, and Reddit. He has, I think, very interesting opinion, and I'm sorry, my German friends, but he thinks that the Czechs have the best sausage and beer. I agree, and please welcome Brian Holt.
Yeah. Yeah, let me fix that. There we go. All right. Well, if that wasn't the most ridiculous introduction that happens today, then I have not done my part. So, today we're here to talk about futurist code base, integrating the future today. That is like the worst title I can think of. It just sounds like super buzzwordy. But here we go. We're going to talk about it. So I work at this little company. Anyone ever heard of this one? No? Cool. It's pretty underground. You probably haven't heard of it. I work for this company called Microsoft. And I work on these two things. Node.js on Azure, and this other, again, little indie project we have called Visual Studio Code. How many of you are using Visual Studio Code? All right. How many of you are using Azure? Literally all of you? Just kidding. I expected that. Cool. So here's kind of what we're going to go over today. The theme of this is abstraction. Why do we have abstraction? Are things going to get more abstract? Are they going to be less abstract? Yeah, kind of like what's the future going on here. And then at the end, I have a special demo for you, something that literally has never been shown off before. Hopefully it works. Otherwise, it's going to be real embarrassing. So let's talk about abstraction. What is abstraction? Well, a lot of people like to complain about JavaScript because it has garbage collection, or that it's slow, or that it's inefficient, or that it's too abstract, right? Kind of drives me crazy. And I'm going to rant to you because you're here and you have to listen to me. So just by raise of hands, how many of you could design and manufacture a silicon chip by hand? I think I see two. 2 hands? OK. So not many of us. I'm not putting my hand up. My hand's like way down, like I should touch the floor. OK? Well, let's move a little bit up the abstraction chain. How many of you can architect computer systems? Again, not many of you. Code in binary? Couple more. Code in assembly? Couple more. OK. Code in system levels, like C, Rust, C++. OK, now we're about to like 10% of the audience. Scripting languages. How many of you can code in like JavaScript or Python or something like that, right? Do you kind of see my point here? It's kind of ridiculous to me to make the point of like, it's too abstract, or like it's not, it's dumb because everyone's just moving further and further up the abstraction pipeline, I guess, if you will. And so for someone to like say like, this is the proper amount of abstraction, I only code in assembly, and everything beyond that is dumb because it's it doesn't make any sense to me. And it kind of gets me to like, why is WordPress so popular? Like, I guarantee you there's at least someone in the audience right now telling a PHP joke, right? Because it's a tech conference and that stuff kind of happens. But I want to again point out why that's ridiculous. So why is WordPress so popular? It's definitely not the quality of the code. Like, no offense to the WordPress developers, well, maybe a little bit of offense to the WordPress developers, but it's not, in my opinion, the best architected system. It's still PHP 4-ish. So, but why it is popular is it allows people to iterate quickly. It allows people not familiar with code to do amazing things. And it's an approachable abstraction on a content management system, right? That's why WordPress is so popular. That's why it's a third of the internet is WordPress. So what do we have to learn from that, right? It's that useful abstractions, even if they're not the best code or the most popular, the most shiny, are still extremely useful to us, right? So that's my point too, is that we're going to continue going in this direction of being more and more abstract, right? Like if you go from the 70s when we were still, doing punch cards, or 60s or something like that, right? And then you come forward to the point where we're writing things in like compiled to JavaScript languages, right? We're abstract upon abstract upon abstract, right? And I think the direction is for things to get more abstract, right? Because the more abstract they are, the more accessible they're going to be to a wider audience, right? So this is kind of the point, is that the abstractions allow new patterns like functional programming. Functional programming was not possible in binary, right? You're not having, pure ones and zeros, or maybe you are. I'd have to think about that. Anyway, abstractions allow permanently solved problems to become permanently solved, like garbage collection, right? You don't have to worry about freeing up memory because an abstraction takes care of that for you. And then it allows new developers to enter the field. If we were still programming in binary and assembly, I probably wouldn't be a developer, right? I'd be doing something else, right? But then you move on and find people that are just WordPress developers. These abstractions allow them to enter the field, these people that would have never otherwise entered the field. And my point is that the future of programming belongs to everyone, not just the people in this room. So it falls to us, the people that can do it right now, to make these abstractions so that other people can join us and have these kind of programming superpowers, if you will. All right. So that brings me to my first point. The no-code revolution is democratizing the power of programming. So what is no-code? Well, you can see here on the right, I have this GIF that I took from KissFlow, which is a no-code provider. But I'm talking about things like Webflow, KissFlow, Microsoft Power Apps. There's a bunch more that I'm obviously missing. That it's kind of this idea that it's like drag and drop programming, right? So you just like take blocks of programming power and you just drag them into paste and then it suddenly works, right? So you give people building blocks and they give you back, constructed programs. Like we have Lego back there, right? It's kind of the same idea just with code. So my point is that you should ignore no code at your own risk, because if we, the JavaScript or the Python or the Ruby developers, says like, that's too abstract, that's ridiculous, those people aren't real programmers, we're kind of like those other people, right? We're kind of like the C programmers, like, nope, too abstract. You guys are ridiculous, right? And they're ridiculous to the assembly programmers, right? So that's my point, is like these people are real programmers, right? This is a real job. It's hard and you have to learn. And they can probably do things that we can't, right? They can go faster because these tools, if you're familiar with them, allow you to go very fast, right? That's why I don't make fun of Rails developers, right? I don't like Rails. I don't want to write any Rails ever again. But if you ask me and a Rails programmer to sit side by side and code something, they're going to finish first, right? Because they can use their tools in a way that I can't use mine. Mine's just going to be better. I'm just kidding. That's going to get me in trouble. Anyway. All right. The next thing, we'll talk about JavaScript, because I like JavaScript. So what's coming in ES 2019? What's coming in JavaScript? We're getting new abstractions into JavaScript. And I know people like to complain that JavaScript changes too fast and there's too much being added to the language, but again, it's the same thing. We're adding new abstractions to allow ourselves to go faster, to allow new people to enter the field because these things are easier to read. So here's actually what made it into ES 2019, if you're curious. Flat map and flat, which is not smush, which some of you might get that joke, the rest of you, God bless you. Object from entries, that'll be a good one as well. Yeah, some good stuff. The one that I'm actually most excited about is indeed the flat map and flat. And so I just gave you an example there. Let's see if I can show you. So you have these arrays right here, and they're nested arrays, right? And so if you call flat, like you see right there, it'll actually return to you this kind of flattened array. Now, this was not very hard to write in just normal, you could do it in a reduce, basically, right? But this is a way easier, right? You just like, I know I want this to be a flat array, so I'm going to do it that way. And then flat map is kind of the same thing, where I have like Golden State Warriors, and I want that to be one string, like you see down here. So like this, Golden State Warriors. So the way that I do that is I do a flat map, and so I give it a map function, just like normal map. I'm saying join, so it's going to call that on the interior ones, and then it's going to flatten the result so that you don't have arrays of arrays, right? So this is available today. I actually just tested it in Firefox, and everything works OK. So those are the ones I'm most excited about. But again, those are all the new abstractions, all the newest language features that we've gotten in ES 2019. All right. Frameworks. These are obviously abstractions that we work with on the day-to-day. So how long are React, Angular, and Vue going to be around? Anyone know? I don't know. Like, these things come and go. I'm actually surprised that like React and Angular in particular have stuck around for as long as they have, right? Because it feels like those have been churning for a while. So I don't really know how long these things are actually going to stay around. These are more transient abstractions, in my opinion. So they're in vogue right now, but they're not going to be here forever, right? Otherwise, jQuery would still be around, or Prototype, or something like that. However, I can tell you what I think is coming. And I don't know if this is going to be like React and Angular and Vue adopting these patterns, or if it's going to be new frameworks that are going to be built for these patterns. But the first one is PRPL, and this is a term from Google, which I don't know if I'm supposed to endorse Google on stage. Might cost me my job, but it's a good pattern, so I'm going to. Okay, so PRPL, purple. Push, render, precache, and lazy load. It's kind of a way to do PWAs, progressive web apps, that allow you to basically have a very small initial page load and then get all of the additional files once that has happened, right? So you can imagine maybe like Netflix, right? So Netflix sites load, you can see the husk of the application, and then it's going to go prefetch all the data in the background, so everything feels very fast, right? So go check that out. I think you can just Google PRPL and you'll see their blog post from Adi Asmani. I think that's going to be the next big thing. And I think HTTP 2 and HTTP 3 are going to be affecting us more and more. Because HTTP 2 is now in every browser, I think, since 2015. Which means about now is when we should start relying on browsers to have HTTP 2. Which means that things like concatenating files is actually an anti-pattern now, right? And minifying files might be an anti-pattern, right? Because HTTP 2 actually adds things like multiplexing requests, long-running HTTP pushes, better compression, all those kind of things. HTTP 3 is only in Chrome Canary and soon in Firefox Nightly, and allows for more efficient streaming of data, handles packet loss much better. And so that's just going to make things a lot faster as well. All right. Serverless. I think this is going to be a bigger thing going forward, particularly for a crowd like this that has a lot of you have like a front-end focus. So this allows you to ship more functionality with less code. So serverless, for those who are not familiar, yes, there is a server, but you worry less about the server. I think that's the definition we're going with, because everyone, like, there's always someone that raises their hands like, there's a server there. It's like, yeah, I know that, right? You don't have to tell me that. I understand that a server serves a request. Anyway, so actually, let's just jump to this next one. So we're going to go all the way from bare metal to serverless. So a bare metal is like you own your own servers. Here's all the things that you have to worry about when you have a bare metal server. You have to worry about data centers, hardwares, operating system, runtimes, scaling to your traffic, server logic, and business logic, right? You have to worry about everything. You have to worry about the temperature of the data center. You have to worry about what hardware you own, right? But you get ultimate flexibility, right? You can have whatever hardware you want. You can change it whenever you want. You own all of your own, you own your destiny, but you also own all of the problems. I don't know, like as a front-end developer, like I don't want to do that, right? I don't want to worry about what temperature there, or what, you know, the physical security of my data center is, right? So that's when infrastructure as a service is really nice. This is things like EC2 or Azure VMs or something like that, right? This allows me to not have to worry about data centers and hardware, but I still have to update the operating system. I still have to deal with the runtimes, like what version of Node I'm on, how many VMs I have, right? Those things. It's still not fun, right? I still don't want to do that. So then you enter platform as a service territory. This is things like EBS, Elastic Beanstalk. Is that what it means? No one cares about AWS anyway, so it doesn't matter. Just kidding. That would be like Azure App Service or Google App Engine. And this allows you to kind of skip operating systems. You get to not worry about what runtime. And this will scale for you, right? So if you start getting a lot more traffic, they're going to start scaling out your app for you, so you don't have to worry about it. But you still have to worry about like what version of my framework I'm on. You have to worry about like handling requests and sending out requests. Like it's still, you're solving solved problems, right? And in this theme of abstraction, right, we want to not deal with solved problems. We want to just worry about business logic. And that's where something like serverless comes into play, right? I don't actually worry about dealing with requests. I don't worry about scaling out. I just worry that when this event happens, when someone calls this API endpoint, or when this database gets written to, then do this, right? You worry about just the business logic, and everything else is taken care of. So that's what serverless is. So my pitch to you here is just go try it out if you haven't. All of them are really easy to get started with: Lambda, Azure Functions, or Cloud Functions. There is one you should obviously try over the other ones. Hopefully that's obvious to you. If it's not obvious to you, I can emphasize that a little bit more. Obviously, I like Azure Functions. All right. Containers. Not as scary as you might think. How many of you feel comfortable working in Docker? Just raise the hands. How many of you think Docker sounds scary? Some of you are lying. I appreciate your honesty, right? So I used to be scared of containers because I kind of conflated Kubernetes and Docker. Docker is not scary. Kubernetes, very scary, okay? So I just want everyone to be aware that Kubernetes and Docker are not the same thing. One is very useful to you as a front-end developer, and one is just this like sprawling behemoth that will consume all of your time and your soul, actually. So Docker is not scary, though. So the future is contained, and I'm very convinced of this, that this is going to become more and more important to you as front-end developers because it has abstracted away dealing with VMs and a bunch of stuff that was really messy about working with infrastructure, and now it's actually approachable to everyone. So that's another invitation for you from this talk is like, go play around with containers. Because I think our development environments are going to become contained. I think all of our servers are going to become contained. I think this is going to be a very important abstraction to all of us. If you develop in containers, that means your environment can exist anywhere. It opens the possibility of like developing on thin clients. So it's actually possible today to just pull out your phone, connect your phone to a laptop, or so to a keyboard, and start developing with a remote environment. That's totally possible today, and I think that's going to become even more popular as we go forward. And then once your app is perfected, you can just containerize it and ship it off to production, right? So instead of having to have like a whole ops team around you, you get to just operate independently, which I think is really cool. So just to call out that last line, every JavaScript developer will have to use containers in the future. That is my prediction for you. All right. Coding in the clouds. So this is going to be my demo, and hopefully it works. This is pre-release software, and again, I think this is the first time this has ever been shown. So wish me luck, I guess. All right. Today, you are going to get a sneak peek at Visual Studio Online. Now, this has been announced. So Visual Studio Online is Visual Studio Code in the browser. And it's actually going to be spinning up a whole development environment for you so that all you have to do is point it at a repo, and we'll spin up an entire environment for you to begin working right away. Okay? So right now, I don't have any environments. I'm going to say create environment. And just to show you the app that I'm going to be working with, GitHub, BT Holt. Oh, damn it. All right, hold on. This is also my first presentation on a Windows laptop. I probably should admit that. Let's see. Mirror. Display, system display. Nope. Only show on. Nope. Duplicate these displays. Here we go. Woo! Windows. All right. So, Visual Studio Online. I'm going to show you first the repo that we're going to be working with. This is just in another fine Microsoft product, GitHub. Woo! All right. So it is literally just like the simplest happy.js app, like require happy, and then start the server. Very complicated stuff. OK, so I'm going to come in here to Visual Studio Online. And I'm going to say, this is going to be called Reactive Demo. And we're going to say, point this at bt-holt/node-example app, the one that I was just showing you. And we're going to do a premium environment, because I don't have to pay for it. And we'll say, once I'm done using it, it'll wait 30 minutes before spinning it down. But you can say, do it after 5 minutes, or never spin it down, whatever you want to do. I'm going to say 30 minutes. You can also have it pull in dot files, right? So if you have like a very particular bash setup that you want to have on every cloud environment, you just put up another GitHub repo with your dot files, and it'll automatically do that for you. I am not picky, so I'm not going to do that. OK, I'm going to click Create. It failed to create. All right, let's try one more time. Maybe. This is, again, under very active development. So there's like a 50-50 chance that this just is not going to work at all. If not, I got some other cool tricks. Example app, premium environment, create. OK, that looks like it's creating. That's the hope. So it's going to read my repo. It's going to see that it has a package.json. It's going to say, oh, OK, you're going to want node 10 probably. It's going to run npm install for me. And then it's going to dump me into that shell whenever it finishes provisioning the container behind the scenes. Now, this actually will work with VS Code directly. So you can just say, hey, VS Code, connect to this cloud environment. And you get to use your normal stock VS Code installation, which is pretty cool, right? So you can connect to like a 64-core mega VM and just like crush some Rust compilation or something like that. I don't know. I'm not going to do that. I'm just actually going to do it directly in the browser. So I'm going to click on this BT Holt right there. Please work, damn it. That doesn't look like it's working. Oh, no, hold, it's working. So again, you can see this is just running in Firefox, right? I didn't do anything else beside this. And you can see it's starting. You can see all the file that it's cloned. It assumes that you want to look at the index.js, so it pulls that up for you. OK, looks like it's already installed all my node modules for me. And let's just go ahead and start it and see if it works. So I'm going to click breakpoint right there. I'm going to say, I would want to debug this. It's going to ask me, it's like, hey, I don't think you actually have anything running here, but it figures out that you probably want to start Node.js. And so you can see there, it's come here, and I'm debugging. So I can go and do step over. And you can see it's stepping over my code right there. Now, let's click play here. It looks like everything has started up just fine. And so it's actually now running this on the server. This wasn't working earlier. So let's see if it's, no, OK. So they actually broke this part. But in theory, what you should see is the ability to connect to the server and hit its local host, right? So I can actually do live debugging directly from the browser, right? Which is crazy. So this is coming. Yeah, thank you. This is coming, obviously under very active development. We're hoping that you'll be able to sign up for private preview starting soon. Soon, TM, right? I don't know exactly when that is. But I will get you all a head start. Because you came and saw me here at ReactiveConf, if you go to here, this aka.ms/vsfutures-sign-up, you can sign up for it, and you will get first access to Visual Studio Online. Now, it's not quite a free service, right? You have to pay for the VMs, but it's going to be affordable. We'll put it that way. We haven't settled on how we're going to price it yet. So yeah, that was Visual Studio Online. That was the first peek at it. Hopefully you're excited about it as I am. And with that, I think we'll take some questions.
Thank you, Brian. Brian, you know, I must say that as a knight who swears fealty to Lord Clippy of House Microsoft, you made lots of jokes on behalf of Microsoft today.
I did. It's my job.
Anyway, we have a question for you. What do you think about Gatsby.js and PRPL?
Well, Kyle's in the audience, so I think he's going to kill me if I talk shit on Gatsby. No, I actually really like Gatsby. I develop all of my personal courses and all that kind of stuff. I all use Gatsby. So I'm a big fan of their project. I'm a big fan of everything that they're doing over there. In particular with PRPL, they have been kind of blazing the path on that by kind of just making it like the sane defaults of Gatsby so that you don't have to do anything. You don't have to know what PRPL is. It just kind of starts working for you. So big props to the Gatsby team.
Great. What is the good and bad scenario for going serverless?
The good, so let's talk bad first. The bad thing is that if you do everything yourself and don't do any serverless, you have all of the control, right? You're not vendor locked in, and it is cheaper. Like if you compare it like side by side, it will be cheaper to run your own apps rather than going serverless. But the thing that people they neglect to think about is you're not paying for anyone to manage your infrastructure. You're not paying for anyone to like sit there and worry about architecture and how to scale out and how to do bindings to all these various different services. So where you save money actually with serverless is with human time, right? Because I'm always of the opinion that human time is worth more money than computer time. So the good is that it scales instantly for you. It can be cost effective if you look at it in terms of human cost. And yeah, it can scale infinitely large.
And last question, or actually we have two more, and we do have time for that, which is great. What is the good and best, wait, we just said that, if contained ENVs are the future, how management of contained microservices will be? Kubernetes is scary.
If contained environments are the future.
I just love you have to read that. I don't blame you.
Yeah,
You know,
no, it's cool. English is hard.
People.
So I'm of the opinion, I'm going to just answer my own question that I'm going to invent from this.
Yeah, sure.
So Kubernetes is scary just because it handles a lot of things for you, and it's a very complicated thing to handle a very difficult problem. I think that there are going to be cloud provider managed container services, something like App Service, or again, something like EBS, where you just put containers into it, and then it just kind of handles the scaling independently. Those are often easier to use than Kubernetes. Kubernetes allows you more flexibility, and you can lean into that, but you need a Kubernetes expert on staff to be able to handle that. So yeah, I stand by my statement that Kubernetes is scary.
Are they NVS online shareable?
Yes. Yeah. So you can share the configuration, you can share the environment. Yeah, so it's shareable in all the ways that you want it to be shareable.
And you demoed with Firefox. Will you support Edge?
No, probably not. I don't think we like Edge. Where's Sean? I know you're here. That is Sean Larkin. Yes, obviously it will support Edge and Chrome and not old Edge, and not Internet Explorer.
All right, the really, truly last question for you right here is why should I code in the web browser?
You should not use the browser for your primary development tool. That's not actually really our purpose. Our purpose is more like, hey, I'm on vacation. I just have my phone. I'm going to plug in real quick and fix my production problem and then disconnect, right? We still want VS Code to be your primary destination for where you want to code, but it's just adding the ability to start coding from anywhere.
Great, thank you so much.
I do have stickers. If you want VS Code stickers, come mob me afterwards.
Yes, Sir Brian, about your knowledge. Thank you. That was Sir Brian Holt. And please don't hesitate again to ask him questions. Thank you for using our chatbot, Reactive Mickey. We have another speaker coming in. His name is Matthew Gertzman. And he is a senior software engineer at Dropbox. He has seen about 150 Broadway shows, which he believes makes him the biggest Broadway fan in the JavaScript community. So, the Phantom of the JavaScript is here. Matthew Gertzman. It was my attempt for Broadway.
Cool. Hi, everyone. I am Matthew Gertzman, and today we are going to discuss TypeScript. And I realize this talk kind of sounds like I'm about to go on an indictment of TypeScript, but actually I love TypeScript. I adore TypeScript. I just want to kind of talk about it holistically to convince you that it is worth your time. So who am I? My name is Matthew Gertzman. I am a software engineer at Dropbox. I live and work in New York. You can find me on Twitter. And for some reason, people think following me on Twitter is a good idea. So I'm going to tell you why that's a bad idea. First of all, I tweet a lot about Taylor Swift. This is me whenever I go on a bad date. I also tweet a lot about Harry Potter. This is a replica of me as a teenager, just very angsty. And finally, I wrote a book on how to buy Broadway tickets, and that is my shameless plug. So thank you for indulging me. Let's go to TypeScript now. So the reason I put this talk together was at the beginning of the year, I noticed a lot of Twitter chatter about TypeScript. People were really, really excited about TypeScript. People were saying that their New Year's resolutions were to learn TypeScript, and someone was like, hey, it's been 2 weeks. We should all be experts by now, right? Because that's how tech works. And then someone's like, I'm going to try to embrace it. I really appreciated how Jane Wong stepped in and was just like, why is everyone saying this? This kind of came out of nowhere. And it wasn't just Twitter, right? It was Quora and Reddit and like Medium and just anywhere you could write an opinion, someone was writing about TypeScript. But this actually isn't new at all. This is the Google trend for TypeScript interest over the past 7 years, so since 2013. And you'll see it's been steadily increasing in popularity since then. So this isn't really new. And something I've seen a lot of is people like to compare TypeScript to CoffeeScript because they're both popular languages that add some fundamental new thing to the language that compile down to JavaScript. But CoffeeScript was 3 years old when it died, whereas TypeScript is turning 7 soon. So I don't think we can meaningfully compare them anymore. And CoffeeScript, I know a lot of people like to talk about it, and like poorly now because it's just legacy code, but that's what gave us promises, that's what gave us lambdas, it gave us a lot of really interesting things at the time. So today, I want to get past the hype. And the reason for that is I think when we are talking about our tools, we spend way too much time looking like this. And instead, we should really be looking like this. By the way, do I have any Futurama fans here? Yeah, sweet, cool. I will not. So we're going to go into the ugly parts, and then we're going to talk about why I think you should use it anyway, because I want to convince you that this is a tool worth using and learning, and frankly, that's not going to happen if we don't talk about like the bad parts of it. So let's take 10 steps back first. What is a type? Well, a type is an attribute of data that tells the computer how the programmer intends to use it. And even if you don't work in TypeScript, you're probably familiar with some basic types in JavaScript. We have Booleans, which are true or false. We We have numbers, so 1, 7, 3.5, whatever it is. We have strings, which are groups of characters. It could be the entire text of Harry Potter, which I would put in a string. We also have arrays, which are lists of things. And we have objects, which are maps. These are all types that I hope you're familiar with. We also have some falsy types, right? Most of you have dealt with something with null or undefined being different. And TypeScript decided, hey, let's make this a little more confusing and add never and void, which we're not really going to cover today, but no, they exist. Types can also be derived from other types. So we can do things like say the type of this is only one of these specific strings, like it's an enum, or we could say it's an object of this shape. And the final thing I need you to know about for TypeScript types is any. And what any is it's an escape hatch. It basically says, hey, TypeScript, you don't know how to type this, or I don't know how to type this, but either way, I really don't want you to do anything here, so just trust me. I'm a doctor. I got this. So what exactly is TypeScript? Well, TypeScript is a strict superset of JavaScript. Strict might need a little asterisk now because someone came up with a nifty little counterexample, but let's go with it's a superset of JavaScript. And it looks like this. In fact, if you look at this code, the only thing that makes this different from traditional JavaScript are these type annotations right here, these strings and booleans. So I have a function that takes a string, and if I run this code in my editor, or if I compile it using TypeScript, it will work just fine when I pass it a string. But if I pass it a Boolean, it's going to fail. By the way, Gryffindor is for people who peaked in high school. I have very strong opinions. TypeScript is also smart, like really, really smart. So we have these DOM functions, document.getElements by tag name. And we need to pass it different strings and return different types of elements based on what type of string we pass, right? Because A tags have hrefs, whereas divs don't, and P tags have their own attributes. So we want to return a completely different type based on what string is passed to this function. TypeScript also makes big refactors really easy, and that's where I'm going to show you some of it. So let me switch into, let me demirror for you. Cool. So I have this code here, and you can see I have a list of Slytherins. I said I was a big Harry Potter fan. And in what we're doing is we have Taylor Swift, who I've already told you I love. We have Lin-Manuel Miranda, who wrote Hamilton, which is a great musical. And we have Severus Snape, who is kind of a pain, but he's famous. Thank you. And let's say we want to add a prop. We want to add a points prop. So we're gonna put points here, and we are going to type that out. And this is super cool. VS Code immediately picks up that it can't find this variable name, which it could probably do in traditional JavaScript. I don't know. We'll ask Brian afterwards. But that's not really TypeScript specific. So let's add it to our function signature. Now, this is where we have an actual TypeScript error. Property points does not exist on type props with children, Slytherin props. And this is the type of error message that you have to learn how to read. But what this is effectively saying is Slytherin props, which is right over here, does not contain points. And this is probably the coolest thing about TypeScript, in my opinion. If I add this prop, you can see the second I type a P or any letter, it lit up at the bottom with this red. And the error message here is that we are missing the property points on all of these components. And if you consider, these are all in this file, but imagine if I had my component library on one side of my application and their usages on the other, you will catch these things very, very quickly. So let's give out some points, shall we? So Taylor Swift currently really just had a great album. I'm very proud of her, so we're going to give her a whole bunch of points. Lin-Manuel Miranda is literally printing money at the moment, so he can have more. And I don't like Snape, so he can have -3 points. Cool. And by the way, if you were curious, if you want to know what happens when you take this stupid little example and turn it into a fully fledged website, you end up building this, slytherin.dev, which I did for another talk for fun. Fun fact, Brian is not mentioned here because he is a Ravenclaw, but his wife, Nikki, who is present, is there. And also, Nico, one of our other great speakers, is on here as well because she is a Slytherin. So that's just fun, and I wanted to share that. Now, let's talk about vanilla JavaScript, right? So TypeScript claims to be incremental, and it is, especially at first. So if I want to make a string, Muggle, Vernon Dursley, or just Dursley, and if I want to do yelling Muggle, const yelling Muggle equals Muggle, you'll see I immediately get dot completion on every function that's on this string because I'm using TypeScript. That's the kind of thing that you don't have right away. So let's call 2 uppercase, which is great. And let's say I want to get a subset of this string, right? I want to call slice. But let's say I make a typo. I type splice. Well, it gives me the great error, property splice does not exist on type string. Did you mean slice? And that's the kind of thing that just like is amazing that when you get to start taking it for granted, because I could have easily made this typo, right? And then that would have appeared in my browser as opposed to in my editor, or even, if I'm lucky, my terminal. So we've got that, but these are just strings, right? Let's do something a little more complicated. Let's make a wizard. So we have a wizard, and we want to do wizard.name equals Harry Potter. Well, this is interesting. This is totally valid JavaScript this time. And it says property name does not exist on type empty object. That's a little obnoxious. OK, so let's fix that. So let's make a type. Let's make a wizard type. And wizards have names, so we'll do that. And we will add the type annotation. And now we get a new error. Now it's saying property name is missing on type empty object, but required in type wizard. So OK, so we have to do it this way. We put the name in the thing. And even though every example you just saw was totally valid JavaScript, TypeScript is making us do it this way, just because it needs to infer these types. Let's look at another example. How many of you use Lodash either willingly or begrudgingly? Yeah, most people use Lodash for something, right? So we import Lodash, and we get the same super cool dot completion on Lodash, which is an external library. And I think Lodash is a particularly cool example because of how powerful the types are here. So you'll see right now it thinks that I might want to pass a collection of strings to this. But the second I give it an array, it's going to assume that it is something array-like, and it could be anything. And when I start typing numbers, it knows that it's a number. And if I type string, it knows that it's a string or a number. So not only that, but in my predicate, it knows that value is of type number. So if I add slice to this, it's going to say it doesn't exist on number. So let's just make this work for values greater than 10. Cool. Doop. Sweet. By the way, Slytherin.dev was the thing I showed you. So one of the takeaways I want you to have is that TypeScript is going to get in your way for the first few months. How many of you have used one of these functions, Lodash.get or Lodash.set? Yeah, they're kind of becoming less popular, especially as optional chaining is a thing, but these are virtually impossible to type. Getting the type, so these allow you to arbitrarily drill into an object via a string and just kind of do something there. And it's really hard to get that right in TypeScript, and we're just going to kind of give up that tool. What about tests, right? Like, we have to write tests. Tests are going to require very well mocked data, or you're going to be using lots of any's. What if you want to test the absence of a prop on a component? Especially if you're writing a library, like where you don't know how your consumers are going to use it, or if they're going to be using TypeScript. You're going to have to start throwing in any's. What a lot of things come down to is advanced JavaScript ends up translating to advanced TypeScript. An example I love to give are higher order components. How many of you are still using higher order components? Yeah, it's like they're not as popular as they used to be, but they are one of the most interesting type cases, I think, because we have a wrapped component, which is inside of the HOC. It's receiving props from it, and then it also needs to receive regular props from the outside, which may or may not need to be read by the HOC. And just to make this more complicated, the wrapped component internally needs to be able to receive all the props it knew about, and then also the HOC props. This is really, really hard to type. You need to know about generics. You need to know about intersections. You need to know about discriminated unions. And I don't expect you to know any of those things today. You just want dot completion on your strings. Like, that's what you want early on. So if you are interested, I wrote a blog post. You can check that out on how to type a higher order component. It took me 2 weeks in 2017 because there wasn't a lot of documentation back then. The other thing is TypeScript is not sound. So what do I mean by sound? Well, soundness implies that we can know at compile time that our code is safe to run. And if it doesn't have that property, it's considered not sound. And the reason for this is anyone can put an any anywhere in your code base. And remember how I said any is just like a trust me, I'm a doctor, it's an escape hatch? It's actually a little more like this. Glad I got something. Cool. Anyway, so a great example of something that's very hard to type is React context. So we have a provider and a consumer and this magic data flow in the middle. And we can't really type that magic data flow. We can trust that React's going to do the right thing, but the best we can do is pin the type on the provider and on the consumer and hope for the best. React Redux takes this problem to the next level. We have to deal with context, and then we have funcs, which are functions returning functions, and inferring what each of those levels return. And then when we're dispatching with middleware, we're doing all this complicated typing, and it just starts to get really challenging. And all of this is because TypeScript is a strict superset of JavaScript. We're bolting on types onto an untyped language. This is totally valid JavaScript. It's stupid, but it's valid. So this function, if it gets Harry as an argument, it returns 7. If it gets Ron, it returns undefined. If it gets Hermione, it returns an object. And if it gets anything else, it returns wizards. And you may be thinking, why would I write a function that returns 4 different types? But I actually showed you that at the beginning of the talk. Most DOM APIs will return one of many different types based on what string you pass to it. They're just not all as contrived as this one. So here's where I tell you that all of this is still worth it. TypeScript is just another tool. TypeScript is not a silver bullet. And what it does do is it eliminates an entire class of bugs. How many of you have seen this error message in your console? Just like expect the entire audience to raise their hands. Right, of course. Like at some point you've seen this. And 9 out of 10 times, TypeScript's going to cut this out for you because it's just going to know undefined is not there when you try to access that property. Same thing for this one. When you try to call a function that isn't there, it's going to catch that in your editor with those red squiggly lines. And not just like these things. What about when the interface changes? What about when I add a prop to a component that someone else on my team is using and I forgot to tell them? It's going to tell me in advance when this happens. And this becomes an even bigger issue when you're talking about the scale of a company like Dropbox. We have hundreds of engineers working on the same code base. We have millions of lines of TypeScript, hundreds of features, and just to make it more challenging, we have 4 engineering offices in 3 time zones. So we have to coordinate well. TypeScript is a core part of our front-end workflow, and I want to show you some cool examples that you might not have thought of. One of my favorite ones is library upgrades. So there's this great typings library on GitHub called Definitely Typed, and what exists here are all of these types for any third-party library you can think of. If it's not in the library itself, it's almost definitely on Definitely Typed. And the first thing we do when we go to swap out to upgrade a library is we swap out the types. So let's say we're going from React 16.10 to 11. We will swap out the types, and then if there are any breaking changes in the API, we'll catch those almost immediately because it'll be in the typing layer and our compile will fail. So the very first thing we fix is compilation. Some examples of the types of things that change are what happens when a feature gets deprecated, what happens when we lose old context, or we get rid of old refs, or we get rid of component will do something. And then also the types are changing, right? Like sometimes function signatures change, sometimes we add something or remove something, and then often the types just get better. A lot of the times someone will bump the types on Definitely Typed, and they will catch something for us that is just some edge case where undefined was passed somewhere and you didn't even think of it. Honestly, at our scale, I don't know how we would upgrade libraries without TypeScript. We're talking millions of lines. TypeScript also allows us to place constraints on our engineers. And you might be thinking, I don't want constraints on me. I want the freedom to do whatever I want. And I'd like to give you a metaphor. So we have the beautiful Charles Bridge in Prague. And the simplest way, with the fewest constraints to build this bridge, would have been to dump a ton of concrete into the river. Maybe at the time, several hundred years ago, dump a bunch of stone into the river. And that would build a bridge that lets us cross it, but we couldn't have boats get through. We would ruin wildlife. We would do terrible things to the environment, and maybe we shouldn't do that. So when we're building bridges, we do proper constraints, and we want that with our engineers too. So remember how I talked about React upgrades? We often want to test the latest version in production. So we want to make sure that the newest, latest thing is going to run against the code that we have. But we might need to roll back. And here's the problem with that. Developers will start using new features as soon as we let them. Remember when hooks came out? This is a simulation of our web platform team dealing with all of our engineers excited about hooks. They are Simba. They are just trying to stay ahead of the pack to make this work. So to solve this, we roll out the latest version of React behind a feature gate, but we keep the types of the previous version so that at the compilation step, they just can't use hooks until we know that we're not going to roll back. And then once we're confident, we'll add the types. And this process sounds heavy. It lasts maybe a week. It's just, we want to run latest React against 10 or 20 or 30% of our users until we bump it up to 100 and leave it there. Another super cool thing we do is we restrict Lodash usage. So there's a lot of functions in Lodash that are no longer really relevant. They kind of made it into ES5, or they're just kind of heavy, or whatever. We don't want them. And also, Lodash is 25K if you ship the whole bundle. So you definitely want a smaller bundle. Excuse me. So what we do is we have this typings firewall that prevents engineers from using functions that we don't want in our bundle. And if they want to add it, they submit a PR, and it's a one-liner, and we probably say yes if we think it's a good idea. But otherwise, we just kind of default to not having this dependency and not sending down this extra code. We wrote a really great blog post about all that and how we did that migration. You can read that one later. But what about for small teams, right? I've been talking about hundreds of engineers, but your team is probably 5 or 10 or 20, or maybe it's just you. Maybe it's just you writing code. And some people are going to claim that TypeScript gives you free documentation. And I'm not going to tell you that. I think you still need docs, especially to convey why you did things. Some people are going to claim that TypeScript is going to give you free tests. And I don't want to make that claim either. You absolutely should be writing integration tests and end-to-end tests and dealing with that. But here's what TypeScript is going to give you. It's going to give you contract validation across the board. So this is kind of a standard application, right? We have our API, and then we have our data layer, which might be Redux, it might be Apollo, it might be hooks. Well, we might be using hooks, use reducer, whatever. It doesn't matter. It's probably here. Then we have our components, which are a little smarter and are doing some business logic. And then we have kind of our dumber components in the front, our component library. And we can enforce contracts across this. So a contract is a precise and verifiable interface for software components. And the most important part of this is that it's verifiable. So for example, on our API, an engineer who's probably writing in Python or Go or Rust is going to want to make a change to some endpoint. And what we do is we compile those types using a tool that we've open sourced called Stone. And we have TypeScript types then, and they will know immediately before they merge their code if they're going to break someone's usage somewhere on the front end. Similarly, on the entire opposite end of the stack with our component library, if you've got a slithering component and you want to add a prop that is now required, or you want to remove a prop, or add the type, or change the type, we're going to catch that across the usages throughout our millions of lines of code. And then not only that, but engineers can do this within their own features, which is super nice. In fact, I want to show you an example of that. So I wrote this small sample app. And the first thing you'll notice is that we have this type user. And user has a user ID, which is a number, and a name, which is a string. We have this function, which might be auto-generated from our tooling. It's called fetch users, and it returns a promise of list of users. So we've brought this type from the back end to the front end using TypeScript and automated tooling. In our Redux layer, we're going to want to dispatch actions that can fetch the user. And the payload is going to be of type user. So this type is slowly propagating across the system. Inside the function, we are returning a type which has guaranteed that payload. Then in our actual store, where we're storing the data, we are still using this user type that came from some arbitrary place in the backend. This could have been defined in a protobuf. This could have been defined very close to the database, but we are propagating this across our system. Now here is what I like to call a contract shift, because what we're doing is we are taking the store, or the shape of the store, and that has a user in it, and now we are returning a string. That's what that type on the far right is. So our view, which really doesn't care about the backend or how any of this works, has this name prop, and all it's receiving is a string, and it can just spit that out to the user. So this type, this user type from the back end, is being propagated everywhere it's needed up until we have a contract that says, hey, we need a string for type user, let's trade, and then we give that out to the view. I also like to argue that TypeScript increases in value over time. This is kind of just like a contrived graph where I said the number of lines of code that you could generate by yourself over 3 years, which is probably 20,000, maybe it's 50,000, maybe it's 100,000. You could write a lot of code by yourself. And what happens if the team becomes 5 or 10? You're easily producing hundreds of thousands of lines of code very quickly. Are you going to remember how every part of your application integrates with every other part of your application? How many of you have written a login form at some point in time as the very first thing you did and then forgotten about it? It's kind of a common thing. So what I like is that unlike tests, TypeScript gets in your way. It's in the middle of your editor. It's in the middle of your compiler. Now, it's not a silver bullet. Like I said, I want you writing tests. I want you doing code review. And I want you thinking about architecture. But I would argue that the metric for success on a code base is how few things you need to keep in your head at any given point in time. And TypeScript allows you to forget about other parts of your code base. And really, the only cost is learning it. So thank you so much. My name is Matthew Gersman, and I think we can do questions.
Thank you, Matthew. We have questions. Do you think duck typing is an anti-pattern?
So one of the interesting things about TypeScript especially is that it uses structural typing. So I've been in cases where I did something like I had 2 types that were exactly the same, and we decided to split them because they might change. Is duck typing an ANSI pattern? The answer is depends on your use case, like most things. I don't really have a strong opinion here. Chances are, if your UI props and your very back of your stack props or just function signature are exactly the same, they're probably going to diverge at some point and maybe make 2 separate types. But you can also start off with 1. The biggest thing I would avoid is just hasty abstractions, where you abstract things that don't necessarily need to be abstracted.
Why should I choose TypeScript over Flow?
Honestly, I would just push you to use a typed anything. I do not have a stake in this holy war. I work for Dropbox, not Microsoft or Facebook, so I really don't have a stake in it. I can say in my experience, TypeScript has a much stronger community. It has much stronger third-party types, and it seems to be getting more support. But if Flow is working for you, like, I'm not going to tell you to migrate your code base. Keep using Flow.
This one you might have to help me. How much different is TypeScript versus native async await syntax? Shows significantly slow performance with big data structures.
Interesting. OK, so TypeScript does the job for you that Babel traditionally does, which downcompiles your latest ES-Next code with all the latest features into something that the browser can serve. It can even do ES3, but normally it's doing ES5. I actually don't know the performance implications of using TypeScript versus Babel versus the native one. I would imagine that the native async await is probably the fastest one. If you're in an environment where you're really optimizing for that, you could serve the async await as is. But I don't think TypeScript really has much of an impact here compared to any of the other options you're going to choose.
Next is how TypeScript works with not typed dependencies.
Yeah, so if it's not undefinitely typed, which is rare, what you do is you make kind of an index file for yourself. It's called a .d.ts file, and it's similar to a header file in other languages. And what you do there is you say, this is the library, and you have 2 options. You can either take the time to type it yourself, and maybe you want to commit that to the outside world. Or you can just say, just trust me when I use this library. And it's not going to be type safe there, but that's one of the nice things, is that it's incremental, so you don't immediately have to type your whole code base. It's also really useful to think of this not just for not typed dependencies, but for just parts of your code base that aren't typed. A lot of the time when people do migrations, they tend to start very inside and then move outwards. There was a great talk from someone at Airbnb, I believe, about how they did that migration.
We're going to do last 2 questions, Matt. So how steep is the learning curve for TypeScript?
So I hope you saw some of that in the incremental step, that at first it's very simple. Like you have strings and you have numbers and you have primitives. It does get complicated very quickly. Like you don't have to go from 1 to 11, like on the knob from 1 to 10, but you do get to 6 rather fast. And the reason for that is third-party libraries like Lodash or React or what have you, those are going to require sufficiently complex types to be statically typed. Now, you can always make the trade-off. I want my code to be slightly less type-safe and get some of the benefits of TypeScript. That is totally a valid thing. But if you're going for that like perfect typing all the time, like yes, there's a steep learning curve. Yeah.
So I said last 2 questions, but we have 2 more questions that are both competing. So will there ever be integer type in TypeScript?
Ask Brian Holt after I leave the stage.
And then, sorry. And oh my goodness. And then last one, how do you pass generic type into functional components?
Yeah, I do that all the time. So you can do, what you end up doing is you do const, it's easier if I actually type this out, you do const React type, variable type of the React component, and then you can pass a generic to it. I don't think you can actually do generics with standard function space name of the function signature, but you can do it with the store it in a variable syntax. So there is one way to do it, but it doesn't work the other one.
All right, that's all the time we have. Thank you so much. That was Matthew Gertzman.
Thank you so much.
As we can see that you have lots of questions for him, ask him. Now it's a coffee break. Take 30 minutes, have a coffee, ask questions. we are back, and we have last 3 talks here at the Millennium stage for tonight, before we will have real fun, all of us together. So, if you didn't do so, don't forget to rate or draw a picture in our space journal that is located right there with our beautiful, beautiful reactive friend. I am going there quite often, and I check what you guys wrote, and so, I want to read new stuff there. The next speaker, his name is Nader Dabit, and he's a developer, author, podcaster, and developer advocate at Amazon Web Services, specializing in cross-platform and cloud-enabled applications. And he told me that apparently he really, 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 really loves Indian food, and he eats it everywhere he goes. So please, I ask of you, if you run into him in one of our parties, force him to try Czech cuisine, because he's gonna love the Czech dumplings and our sauerkraut and the pork, if he eats it. Anyway, enjoy Nader Dabit.
Thank you. All right. So, hello, first of all, thank you for having me. I'm really excited to be in Prague, one of my favorite cities in the world, actually. I was here a couple of years ago, and this time I'm getting to stay a couple of extra days and explore, so I'm really excited about that. But I want to jump straight into my talk because I have a lot to cover. This talk is it's really formed around GraphQL, but in reality, what I'm going to be showing is a combination of GraphQL and front-end technologies. So kind of mainly what I'm using is React, but the ideas can apply to any platform. There's 3 main ideas I want to drive home. One of those is around API gateway, and GraphQL as an API gateway. So essentially, instead of thinking of GraphQL as a way to just interact with your data sources, instead thinking of GraphQL as a way to interact with any service or any microservice or any function, anything that's outside of the core of your application. Also, developer velocity. A lot of the things I'm going to show today are kind of focused really on rapid development, rapid iteration, prototyping, experimenting, and essentially just developer velocity and developer experience. And then finally, the future of GraphQL. The things that I'm going to be showing today, I think, are really where we're headed in this community. And if you really have watched and seen some of the blog posts and talks that I've done, I'm really interested in the future. I'm really interested in futurism and where things are going and trying to ride the wave and kind of be where the next thing is as it's cresting. And that way we can benefit from that experience. So, welcome to my talk. This is Curious Cases of GraphQL. My name is Nader Dabit. You can follow me on Twitter, GitHub, Medium, and dev.to at Dabit3. I'll follow you back. I'm web and mobile developer, an author, and a podcaster. My 2 books are React Native in Action and Full Stack Serverless. Full Stack Serverless from O'Reilly Publications goes along with a lot of the stuff I'm going to be talking about today. And this is the layout of my talk. So we have an introduction to modern AWS tech. I'm going to build an API in 5 minutes, an API that includes authentication, authorization, database, data connections, relationships between the data, and we're going to test it out all within 5 minutes. And then demo overload. I have a lot of demos to show, so we're going to jump right in there. I work for AWS on the client technologies team. The 2 technologies I work most closely with are AWS Amplify and AWS AppSync. AWS AppSync is a managed GraphQL service, so you could think of this essentially as something like Firebase, but for GraphQL. And we have a lot of different features kind of built into it. One of the main ones that people really enjoy is that we have enterprise security and authorization baked in, something we really thought about long term. And then there's Amplify. Amplify is a couple of things. It's a command line interface. It's a client library that allows you to interact with services that you've created from the command line. A toolkit that allows you to do things like GraphQL code generation. And we have framework-specific components for React, Vue, React Native, Angular, and Ionic. And what I'm going to demo today for this API that we're going to build in 5 minutes is the GraphQL Transform library, which is an SDL over your GraphQL schema that allows you to add decorators or directives to your schema and build out a more complex application than writing all of this manually. A lot of the applications that we write today fall into the lines of CRUD list applications. So if you have a to-do app, you might have a base to-do type, but you need a way to create, read, update, delete, and list these to-dos. You also might need some type of data source to go along with this base type, and you need a way to connect the operations to the data source, so you need GraphQL resolvers. We have directives that can do things like generate all of this for you. @model will generate the database, all of the different resolvers and the schema for you from a base type. Auth will let you configure authorization roles directly on your schema. Connection allows you to model relationships. Those are the three that I'm going to cover today. So the challenge that I have for myself is I want to build a conference API for ReactiveConf in 5 minutes. That means we need a schema, resolvers, a database, authorization rules, and we want to model relationships between the data. We want to actually test this out also locally. So we'll get started. Here I'm starting off with an Amplify project. And what I'm going to do is I'm going to go ahead and add the API. Can everyone see that? Pretty good. So to add an API, you can run amplify add and then API, and we can choose between GraphQL and REST. I'll give the API a name, or I'll just take the default. I can choose the authorization type for the API. So if you'd like to bring auth0, you can choose something like OpenID Connect. If you want to use a managed authorization service or authentication service, Amazon Cognito User Pools is what I'm going to go with, because that's a managed service that we work with. We can then configure some advanced settings, which I'm not going to do. Now, if we have a GraphQL schema that we can reference, I can go ahead and choose that here. But since I don't, I'm going to go ahead and ask for a guided schema creation, which will essentially just give us 3 boilerplates that we can work with. And the boilerplates that we can start with are a single object with fields, 1 to many relationships, or a schema that has authorization rules kind of baked in for us to reference. But it doesn't really matter, because we're going to be starting from scratch. So I'm going to go ahead and choose yes, and we're going to go ahead and edit this schema. And what we get started off with is a basic type of to-do. And we don't really want this. We want a conference app. So I'm going to go ahead and delete this, and we're going to go ahead and start over from scratch. So we want a talk type. We want the talk to have an ID, a talk name, and a talk summary, speaker bio, etc. And then we want to have a way to have people comment on the talk. So we want to be able to have communication while the talk is going on. People can ask questions with each other, and then maybe when the talk is over, the speaker can then go back and look at the comments and maybe respond. Now we need to model a relationship. So what I'm going to do here is add a comments field to the talk. And you'll notice that we have these 2 directives now on talk. @model will scaffold out all of the resolver, resolver code, all of the different other operations. We can then modify those with our own business logic if we'd like to. @connection will allow us to define a relationship between 2 types. So I need to define a relationship between the talk and the comment. So therefore, we have a comments type on the talk, a comments field on the talk, and a talk field on the comment. Finally, we want to be able to add some authorization rules, because we don't want everyone to be able to create a talk. We only want admins to be able to create a talk. Therefore, we can now use the @auth directive, which will allow us to go ahead and scaffold out some boilerplate resolvers that will allow only people that are signed as an administrator to be able to create, read, or update talks. But anyone will be able to read the talk, because we've set query rules to null, so we don't want any rules on queries. Finally, the comment is very similar in the sense that we want to have some authorization rules, but our rules are going to be a little different here. We want to allow anyone to be able to create a comment, but only the owner of the comment to be able to update or delete this comment. So we're done now. Our schema is ready to go. We can now test this out. So I'm going to go ahead and jump back to the command line. And from here, we can now mock all of this locally. We don't have to deploy anything. All we need to do is run amplify mock. And this will go ahead and mock our entire application for us. What it's going to do is introspect our schema, see that we need 2 data sources, 2 databases. It's going to go ahead and create those 2 tables locally. So we have a talk table and a comments table now created. It's then going to run GraphQL code generation, and we're going to be given the GraphQL code locally that we can use to interact. And we're going to run an HTTP endpoint now on our local host. So we can go ahead and click this, and this is our graphical explorer. Thanks, big thanks to Sean Grove of OneGraph for helping us integrate this nice UX on the left-hand side. So what we want to do now is we want to go ahead and update our auth, and we want to make sure that the user that's signed in is just a regular user, because we want to test that authorization rule. So we're going to add a new mutation for creating a talk. We'll give a speaker bio. And we'll just do some basic data here. We want to go ahead and create this talk. And we'll notice that we're unauthorized to do this because we're not logged in as an admin. So we can go ahead and update and simulate an admin user by passing in an admin as the group and generating a new token. And now we'll be able to create this mutation. The next thing we want to do is take this talk ID and create a comment on the talk. And the comment that we want to create is going to be basically, just someone that's in the audience creating a comment on the talk. So I can go ahead to create comment. I can pass in the ID of the talk, and I can create a message. And then I can go ahead and actually return not only the message and the ID, but I can return created by, because we're going to actually read the user information off of the token and store that in the database. So next I want to go ahead and sign out and sign in as an audience attendee. And now I'm signed in as someone else. And I want to go ahead and create this comment on the talk. So we've created our comment on the talk. We've created our talk. Let's go ahead and now query for all of this. So we can now do the list talks query that will return our items. And you'll now notice that there is a relationship between the talks and the comments. So we can drill down and get the comments that relate to this talk, and we can return those items as well. So I'll go ahead and return the ID, the message, and who created it. So I'll go ahead and run this query. Now we'll see that not only do we get the information about the talks back, we also get the array nested comments. Once we're ready to deploy this, we can go back to our command line and then run amplify push. I'm not going to worry about that because we don't have time for that, but just wanted to show that. So next we're going to go ahead. Yes. Thank you. Next we're going to go ahead and do some demos. So the first demo I want to talk about is real-time SMS and Markdown. These are the curious cases of GraphQL, if you haven't noticed by the name of this. What if you could SMS, text message, Markdown, and do something with it? So I created an app for that, and it's especially good for this conference because you can now text message comments about this talk to me, and by the end of the talk, I'll go back and reference these comments if I have time and answer any questions. I'm bypassing the native conference speaker discussion thing, right? So let's go ahead and take a look. So if you want to comment, you can go ahead and text a message to +1 910 249 6765. And this is going to go ahead and create a new message, and we're going to go ahead and view that user interface in just a second. And now let's look at how we built this. I basically took the idea of using GraphQL mutations and having a screen that listens for these new messages coming in real time and displays them on a screen. That's what I wanted to happen. So how could I do that? I used a service that you can create phone numbers with, Amazon Pinpoint. You could also use something like Twilio. Once a message comes in, we send the message to a Lambda function. The Lambda function creates a GraphQL mutation. The client listening to that subscription will then get that data. So I defined the data basically like this. I needed an origination number and a message body. The origination number just tells us who sent the message. The message body is the markdown. Second, I created the GraphQL schema. GraphQL schema only needs an origination number, a message body, and an ID. And then finally, the Lambda function looks something like this. We take the message off of the data and we parse it. We then get the origination number and the message body off of that data, and we create a really raw HTTP request using something like Axios. And here I'm passing in the URL, the API key, and the information that is the actual variables for the message. And let's go ahead and demo this. And I'm curious if anyone else is curious enough to send messages here. So let's go ahead and take a look. And if anyone wants to create a message, I'll go back and check this out. But looks like we have one message from someone saying, hello world. That's pretty cool. If you want to send an image, anything like that, go ahead, check it out. Next, we're going to go ahead and do another demo. And I think what I need for this demo, let's go ahead and take a look. Yes, I'm going to need an audience member as a, someone that volunteers. So who wants to volunteer to come up and be part of this presentation? Yeah? Okay, come on. So what we're going to do is GraphQL image recognition. We're going to take an image, run it through a GraphQL operation to a machine learning service, get information about that, and return that in the response for the GraphQL. Hey, come on. Hey, I'm Nader.
Hey, I'm Michael.
Thank you, Michael. Let's give Michael a little bit of round of applause. So the way that this is going to work is we're going to take an image. It's going to be a picture of us. We're going to send it and store it in an image service. That's going to kick off a new mutation, or actually it's going to send an operation to a machine learning service with the image information. That will give us the data, and that's going to be returned back in JSON. So that's kind of how that looks. We're going to skip over the functionality because we want to jump into this demo. And when I come back, I'll kind of walk through how this all works. So come on, let's go ahead and take a picture. You can come right here. What we want to do is we can either toggle the camera or we can actually, yeah, there we go. All right, so we're taking the picture now. We're going to give this a little bit of time. This is going to upload the image. It's going to then, get the image information, run it through the image recognition service, respond in a Lambda function, GraphQL mutation, and we're going to get that back here. So here's where you want to check out the info. So we have two people. Yeah, you can go ahead. Thank you. We have two people. One is estimated at 30. One is estimated at 47. I'm the 30-year-old. We're both smiling. Neither one of us have glasses on. We both have our mouths open. That's pretty interesting. Yeah, and our emotions are angry and disgusted and disgusted and confused. So, yeah. I'm not sure what that's all about, but yeah. Thanks for the volunteer. So let's look at the function that did that. We basically have two types of images that you can upload, one of a person, one of not a person. If we send a type of labels, that means we're sending something that's not a person. So we want to kind of we want to recognize like a general image. Maybe we want to say, oh, there's a TV in this image, there's maybe a car. If there's a person, we want to then recognize labels on their faces. So we check to see if the type is labels or not. We set some attributes. We create a new params object with the image information, which is basically the URL of that image. We then call the recognition service, which is a machine learning service, and there are a bunch of them out there. This is AWS, but you don't have to use AWS. There are others out there. We call it detect labels or detect faces. Passing in that data, it returns some JSON. We stringify that, send it back, and then we display that on the screen. So that's kind of how that works. All right, so the next thing we want to go over is real-time music collaboration. How can we build a step sequencer that allows people to collaborate together and create music? So let's see how that's done. First, I needed a base project to start with because I cannot understand how to build this from scratch. I needed somewhere to start with. I then make it cloud-enabled. So what I found was the Traplord 9000. The Traplord 9000 was created by Ken Wheeler, and big shout out to him for creating this. I saw him give a talk in New York. I basically took his project and then made it cloud-enabled. And what happens here is that step sequencer, you have an array of different values that represent a slice in the sequence. So as we go from 0, 0, 0, 0, 0, if there's a 1, that means the sound gets played. If it's a 0, that means the sound doesn't get played. So all we need to do is just take this data, allow you to mutate it locally, and then send a mutation up to your GraphQL API. Any of the clients listening to this can then take that new data as it comes through in a GraphQL subscription, run an update, and then therefore you have people collaborating. So the way I built this was I created a drum machine type with an ID, a client ID, a beats, and a name. The thing that might stand out here is we have a client ID. The reason we do that is because we don't want to listen to subscriptions changes that we made ourselves. So if we made the change, we discard the data because we've done an optimistic update. If someone else has made that change, then we refresh our own client application. So the demo for this looks something like this. I have a website that I created for this demo, actually. It's called hypebeats.dev. If you would like to play along, go for it. I'm going to create a new drum machine called Reactive. And then we're going to go ahead and see if we can work on this together. So we have this reactive beatbox. I'm going to now open a new beatbox in another window. And what we're going to do is, once this machine loads, we're going to go ahead and set some steps here. And we're going to see that they come through in real time over here. And then I'm going to go here and play the step sequencer. And then over here, I can still make the updates, and they'll start coming through. So let's see if we can create some good beats. I'm not like a DJ or nothing like that, but you know, I do a little something. Okay, now some people have started stepping in. I don't have to do any more work. Okay, cool. So yeah, this can get a little rowdy when you have a bunch of people doing it, but yeah, we have some beats being made now. And it's all coming through in real time, and I don't have to really do any more work from here. So that's Hype Beats. I have 2 more demos, so let's see if we can get through these. What about GraphQL infrastructure as code? If you saw the way that we did that schema decoration using that GraphQL, those directives that create databases, they create schema, they do all this other stuff that GraphQL you wouldn't think would do. This kind of opens the door for many other things, because what if you have a reproducible backend that you would like to create? Theoretically, you could take a schema, decorate that schema to be that application backend, and share it amongst your peers, open source it, whatever. People could then use that to kind of have a base to start with. Infrastructure as code is something that isn't really that familiar to most front-end developers, and it isn't to me either. The cool thing about what we work on, and I think what you're going to see other people doing as well outside of AWS, is as you create your application from the command line, so you saw us earlier run amplify init, we're actually creating GraphQL and infrastructure as code for you in a folder that's called amplify. You can then share that amplify folder and redeploy your application to anywhere for anyone, and you have kind of a reproducible version of your backend that can be shared among other people. So the experiment that I had a few months ago was, what if I wanted to create a conference app that people could reuse over and over? I go to a lot of conferences, I talk to a lot of organizers. One thing that they keep on doing is they keep creating apps over and over and over. They cost anywhere between $10,000 to $50,000 to build, but they all do the exact same thing. I felt like this was a pretty good candidate for a reproducible app that we could then take this idea of full stack serverless and kind of put it together. So what I created was Conference App in a Box. Conference App in a Box is open source, and we have around 30 conferences that I've personally worked with that have used this. I've worked with 3 independent consultants that have averaged around $1,000 an hour because they charge their clients like $15,000, $20,000. It only takes them like 5 to 10 hours to deploy, which is great. That's the whole idea here, is being efficient. So around $500,000 of known value, and this isn't even something I've really tried to push, it's just something I put out there. People have really found it interesting, and it's basically a conference app that you can build and get up and running with and theme in just a couple of seconds. Not seconds, okay, let's be real. Probably a couple of hours maybe to get where you want to be. So to build this, I created a schema with a talk and a comment, the exact same application that we built earlier. And to create this, amplify init, added the API, and then push, deployed the backend. This is the infrastructure as code that you're left with. It's a backend folder that you can then take and update and then deploy again. You can share this with other people, or you can package this up with the front end, and what you are left with is the Docker version, or of mobile development, or whatever you would call it. I don't really know what to call it. I call it full stack serverless. It's reproducible applications that contain both a front and a back end. So what does this app look like? Well, it looks something like this. This is an app that I put together in my last talk, actually, a few hours ago. It took about 5 minutes. And what we have here is like a couple of talks listed. You can go in and drill down and view talk information. You can then create comments on a talk. And I won't demo the comment portion of this, but you can just create a comment. The comments come through in real time, and pretty decent user interface. If you'd like to theme it, we have a theme file that you need to change maybe 7 variables, and from there you're ready to go with a custom version of this. That's Conference App in a Box. And then my last demo is something that I released to the public a few hours ago, Jamstack CMS. Jamstack CMS is a full-stack content management system built with serverless technologies. It has Gatsby on the front end. It has serverless tech on the back end. If you think about WordPress and the reason that it became so successful and so popular, in my opinion, is that it had everything encompassed into one package, and you didn't have to be an expert web developer to get a website up and running. You could just go and deploy this thing. You end up with some pretty sophisticated authentication and authorization rules. You have a database, you have a front end, you have everything kind of built out for you, and then you can theme it, and you got a lot done in a short amount of time. It's how I got into web development, and I'm sure a lot of other people as well. I think we can do better now. WordPress is still amazing, but we're working with things like server-rendered applications. We want to use GraphQL. We want to be able to maybe iterate more quickly. So the Jamstack CMS is my take at that. And let's take a look at what this looks like in practice. So this is kind of like a deployment of the Jamstack CMS that I have right here. From here, you can kind of create pages in 3 different ways. You can create a blog post from the admin panel. You can create a web page from the admin panel, or you can hard code your own components locally, just like you can with any Gatsby site. If you want to take a look and edit an existing post, you can just click edit if you're logged in as an admin. Here you're given the WYSIWYG editor. You can publish and unpublish. If you're an admin, you'll also have access to this admin panel where you can publish, unpublish existing articles. You can create a new post. You can view all of the different images that you have available to you that you've uploaded securely. Or you can create a new web page, drag stuff around, and then when you're ready to go, you just save and publish. And then we have the settings area, which is pretty cool because here you can theme it a little bit. Let's say we want to create a reactive theme, and we want to create a border, and we want to change this up a little bit. Maybe we want to change the title of our site. When we're ready to deploy this, because it's Gatsby, the only people seeing this admin are us. The people that are actually viewing the site are not seeing this. They're seeing the static version of this. So to deploy a new static version, we can just click the deploy button. This kicks off a new build. This is triggering a webhook to either Netlify or Amplify Console or whatever other hosting service you're using. And then if I go to Amplify Console, give it a couple of seconds, I see now that we have a new build that started running. The new build was triggered by that webhook that I just ran. So that is full stack serverless. That was my demonstration of that. The idea to deploy these apps is you clone them, and if you're using AWS, you run amplify init, amplify push, and then you're ready to roll. If you'd like to see the code for all of these applications, github.com/dabbit3/curious cases of GraphQL. You can also go to github.com/jamstackcms and star Jamstack CMS. I would really appreciate that. Yeah, thanks for the Unsplash talent creators, Jens Johnson, Kareem Manjara, Christian Spies, and Edwin Andrade. And that's it for me. Thank you.
Thank you so much. Nader, David, I have 3 questions for you here, at least. So there is a hype about Resolver first implementation over Schema first. What do you think about this?
I think that it just depends on the person building the application. I really don't think one is better than the other. I think a lot of people get very opinionated about stuff when the end goal is that we just want to create things, we want to build things, we want to actually get things done. If you can get things done in a way that is like going against the way that the current person that is really hyping up something that they created themselves maybe is talking about, then I wouldn't listen too much to them. I think that both ways of doing things are good. I don't really see any reason that I would not continue with schema-first GraphQL development.
What happens if you want to change your data type model, any kind of migration support?
Yes, so you can continually migrate and change your schema, and as you change your schema, you can deploy new versions and revert back to old versions with versioning. That's built in.
And last question for today, can you run both REST and GraphQL at the same time?
Yes, absolutely. It's built in.
Awesome. Thank you so much. And I will let you know that if you want to have more questions, he will be tomorrow available at the chat zone at 5 p.m. at the Discover stage. So, Nader, David, thank you so much.
Thank you.
What a cool dude. He just needs to try the Czech food. That's my only issue, but we'll fix that. Next speaker today is already mentioned Sean Grove. He's a founder of OneGraph. He is an English native. English is his native language, but he speaks it so poorly, he says, that he gets compliments on his English as the second language. Sean is slightly prone to over-engineer solution. He lost his car keys so many times that he decided to cut open his hand and implant an RFID chip and installed a door popper in his car. Oh my God. You can still see the scar on his hand, so I'm sure he's going to show that to you. But for right now, he's going to talk. Sean Grove, enjoy.
Well, thank you very much for that warm introduction. I'm going to be talking about Rust for JavaScripters. Show of hands, who has heard of Rust before? All right, cool. Looks like no one raised their hands, as far as I could tell. All right, but first, a quick bit about me. I'm Sean Grove, coming out of San Francisco. I work at a company called OneGraph, but I won't really talk about that today. I'll give a little bit of context about my experience with Rust. The main project I shipped in Rust was a cross-compiled ARM embedded system in a kind of an IoT device. And so you can imagine that we have these bits of hardware that we're shipping out to the edge, and we need to be able to push updates to them very, very reliably. And so we had a lot of performance and a lot of security and a lot of correctness concerns with this project. Other than that, though, I used to work a lot in Clojure and ClojureScript. These days, I mostly spend my time in Reason and Rust. But I am here today to sell you on Rust. And this is serious business. That's actually why I am dressed so nicely, so that you know that this is serious business. But I do have my button undone at the top, so you know I'm trustworthy. I'm kind of a chill business guy. So with that said, I've been practicing my pitch. Working with Rust in the beginning is like banging your head against the wall. I know we're all excited about that, but I want to set expectations at the beginning of this talk. It's good to think about Rust from the negatives initially. So you're at least setting expectations. Basically, anytime you have a bit of JavaScript code, if you write the equivalent in Rust, it will be longer, it will be more intricate, and will have a lot more symbols. It's not always true, but it's just a good attitude to have because it's true enough of the time. Now, Rust itself is described as a systems-level programming language that cares about performance, security, and correctness. I don't know if systems-level programming is such a good description for it, because it goes in a lot of interesting destinations. But that's how they describe themselves, so we'll run with it. But from a JavaScripter's point of view, Rust is interesting because it's low-level, very, very, very low-level, but it has a lot of abstractions. They focus a lot on zero-cost abstractions in particular. It also has guaranteed memory safety, which is a big issue whenever you are working in a lower-level language. It also cares a lot about concurrency, so it has threads without data races. And it has some nice things. It kind of inherits some of the reason type of features, like type inference and pattern matching. And has a very minimal runtime. But why would you care? Why do you want to have low-level but with abstractions? Rust is very focused on very predictable performance at any given time. It's going to give you as much control as you need to eke out every bit of performance from your hardware. This includes things like memory allocation, layout, garbage collection, all of that sort of thing. But once you get access to all of that power, basically you have this amazing gun that you will immediately point at your foot and pull the trigger. It's very, very difficult to ensure data integrity whenever you have this level of control. And in particular, trying to maintain any sort of data integrity with that level of control, with concurrency, is next to impossible. So many of the bugs that we face in our day-to-day usage of servers is because of threads with data races. And type inference. type inference is a topic that's near and dear to my heart. But I would say, before we explain what type inference is for, like, why not step back and actually ask, what the hell are types for? And if you ask C, C says types are for performance. Types tell the compiler, for all of your data, how should it actually be represented at runtime, both in memory and on the CPU. And TypeScript and Flow, they don't care about the layout of the data. What they care about is correctness. Right, if you think about C, it can't prevent many of the mistakes that you might have where you pass one string when you should have passed an array. I mean, as long as they look like bytes, it's fine. And TypeScript, you can add as many types as you want, but it will never be used by V8 whenever you're actually running your code. So you kind of have these two different values that types might offer, and different languages will choose different pieces of it. And Rust says that, well, types are for correctness and for performance. Why not do both? And there is another language that has said this before, Java. I know Java is not very popular. And if you look at Java right here, so this is an example of declaring some variables in Java. And you say, hey, I have an integer called number, and it's 29. And I feel like this is like working with a compiler that's very hard of hearing, right? Because I say, hey, my flag is false. And you should know that it's a Boolean, right? What else could it be? I told you it's false. But the compiler's like, oh, I'm sorry, I didn't hear you. And so you have to kind of shout that it's, hey, this is a Boolean. And you have to repeat yourself a lot. So the idea is type inference actually says, what if the compiler were to look through your code and say, can I figure out the types for you? So in this case, I'm declaring a variable called elem, and it's going to be an element inside of my array. And it's just 5. The U8 is a literal for an unsigned 8-bit integer. You don't have to have it, but it's nice if you want to have it. And you see that I'm going to create a vector, which is basically an array. But I don't say what the vector is of. I just say, hey, it's a vector. And now whenever I push the element in to the vector, Rust knows this must be a vector of unsigned 8-bit integers. And the cool thing is that we have very, very minimal type annotations that a programmer has to do, but the compiler is still happy, right? The compiler can check for all sorts of bugs, and it can optimize the exact memory layout of your code as much as you need. And so the compiler is happy, and the programmer is happy. And it's kind of this principle in Rust where, wherever possible, the computer should be doing work for us, rather than us doing work for the computer. Now, why is a minimal runtime so important? Right, so traditionally with things like C or C++, you're kind of targeting beefy machines, right? You're pushing to Linux somewhere, and it has gigabytes of hard drive and gigabytes of RAM. And it doesn't matter how big it is, right? Because you'll download it once, and it's fine. But as we start to push to smaller devices or to the web in particular, that puts a lot of pressure on how much data you can actually ship to your client. So Go is another language that has been working really hard at having really great WebAssembly support. The challenge is Go was originally designed to run on servers, where space and size are not a concern. We care much more about performance than we do about size. And so what that meant is that Go has kind of built this culture where, by default, a Hello World Go application compiled to WebAssembly will start at 2 megabytes. And if you pull in any library, it's going to balloon to about 10 megabytes very, very quickly. And I'll give them credit. There's work on a thing called TinyGo, which is a subset of Go that starts at 10 kilobytes, which is amazing. But the challenge here is libraries actually have to add support for TinyGo, because the ecosystem has built up with this expectation that, well, having a big runtime is not a problem. But Rust was originally designed to go everywhere, including embedded devices that are so small, they can't actually fit libc. So you can write a Rust program that will compile with no standard library. You have to bring your own. But that gives you the ability to define exactly the size and performance characteristics of your application. And like I said, Rust inherits a lot from the ML language of family, so like Haskell or OCaml or Reason. In particular, pattern matching. So pattern matching is near and dear to my heart. So you can see here that I have a list of greetings. So there are 3 of them. And what I'm going to do is iterate over them. And I'm going to get the index and the item. And now I'm just going to have a switch here, basically match. I'm going to say, based off of this index, I want to print out a different greeting. So if it's 0, I'll print it in English, else Korean, or Swedish. And this right here is not too bad, right? We can look at like the list of 0 through 2, and we can see that, yes, there are 3 greetings there. But what happens when there's a third one? Right now we can verify it, but what if these 2 bits of data were actually apart in the code base? Then what will happen is this will crash. So what happens is Rust has exhaustive pattern matching, where it says, I have detected a case that you have not handled. And in fact, I will not compile this because it is guaranteed to crash if this case happens. And you can see here that it's giving me this nice error message. The error messages in Rust are heavily inspired by those in Elm. So it's a systems-level programming language that really cares about developer experience. And you can see that, hey, you didn't cover this underscore case, which is kind of a weird thing to say. What it's saying is, I looked at what you're mapping over. You're mapping over numbers. It's really hard for you in one source code file to list every single number possible. So you need to have a default case, which is this underscore. So it's literally telling you, hey, you need to add support for this default case. If it was something else, like, say, an enum that had maybe open or closed or some finite number of states, it would have said, hey, you have open, but not closed. You should handle that case. And the cool thing is they canonicalize all of their errors. So you can see here, if you want to know more information about that, you can just say, hey, Rust, explain to me why is this so important? Why are you bothering me about this? And it will actually print out documentation in your terminal or your editor saying, hey, here's a list of all the things that could go wrong that I'm watching out for you right now with this error. So we add a default case, and Rust is happy, and we're happy, because we know that this is never, ever going to crash. So from the correctness point of view, I would say debugging sucks. There is never a time that I'm excited about debugging unless it is so bad that I'm like, oh man, when I go to the pub tonight and I tell people about this, oh, it's going to make for a great story. But most of the time, I don't want to be debugging. So I would say there are 3 questions from order of easiest to hardest about debugging. The easiest is, who should be doing the debugging? Second is when. And third is where. So who should do it? Well, this is easy. The language. By virtue of construction, the language should make it so that it is impossible for me to add bugs into my program. Wherever that's not possible, because the language needs to give me more power that might introduce bugs, the compiler should start checking my code. Right? The compiler has access to all of my code. It has access to all of my dependencies. It should be checking through everything that the language couldn't to make sure that I didn't add any bugs. And then maybe some automated tooling around like linters. Maybe this is something that my company has about some rules about how I should be coding. Finally, there are tests. If all of that fails and I have to still debug, then I guess it's me. But if a developer doesn't do it, then the user does it. And that's the worst scenario. Right? How many times have we been on a plane or train booking website, and you go to submit the form, and it doesn't work? And so you open up the console, you get the HTML element, and you manually submit it in the console, and it works. Right? So that it's possible for the user to debug, and maybe that's a good thing, but it's certainly not a great experience. And so the next question is then, when should debugging happen? And like Elm, Rust says it should happen up front. You should push all of that up front because the moment that you introduce that bug is the moment when you had the most context to fix it. So it's going to list out all of the bugs that you have at any given time and say, fix these before I compile. And that means that by the time you actually get it to compile, it just works most of the time. It's actually a very jarring experience, especially coming from something like JavaScript, which is amazingly flexible and a lot of fun to program in. But it will allow you to make mistakes that will take you a long time to track down. And I want to give one last shout out to the Rust community here, because they have built a crazy, empathetic, and welcoming community. Most systems programming languages, the community is not known for being very welcoming. But this community cares hugely about the experience of new developers and experienced developers. So much so that they regularly have surveys about the experience of different parts of Rust. And then they will actually take the top pains and form a working group. So they knew that WebAssembly was going to be a really important task for them. So they actually formed a working group to say, your job is to make it so that someone who doesn't know Rust can come to this website, read through the docs, and have a fully working game of life in 30 minutes, which is an insane task. But it is, they've done it. So now, why would you care as a JavaScripter? And it's because Rust now actually compiles down to WebAssembly. And WebAssembly is pretty crazy powerful. It is, I think, unprecedented in how well designed it is and how adopted it is. Usually, a lot of great technology kind of never gets adopted. I want to give another caveat here, though. Using WebAssembly from JavaScript is currently a little bit unidiomatic. It feels a little bit weird, but it's not too bad. But that also means that because Rust is compiling to WebAssembly, that'll also be a little bit painful. But in particular, Rust is compiling down to JavaScript, or sorry, into WebAssembly. And WebAssembly literally is just a big array of bytes, ones and zeros. There are no strings, there are no floats, there are just ones and zeros. And all the things that we take for granted in JavaScript don't really exist there. And yet we want JavaScript to be able to call functions and pass in data and retrieve data, more than just maybe ones and zeros. So what we need to do is figure out how to interop between these two systems. By default, your JavaScript will load up. It will reach out and download a big blob of WASM data. It will instantiate it and pass in all of the functions from the outside world that the WebAssembly bundle is allowed to know about. And then having instantiated it, it can now call into functions that exist on the WebAssembly side. So you can imagine here that I have my WASM, and I call greet, and I pass in hi. That's going to go over to the WebAssembly side. I've implemented a greet function there, and I'm going to return a string back. But this bridge right here, going back and forth, has to be implemented by me. And when I'm implementing it, I have a couple of different goals. One is I want to minimize the copying. Because these are two separate worlds, they both have their own view of memory. Their memory does not touch one another. And so that means if I were in JavaScript and I just copied a bunch of memory and sent it over to the other side, that would actually be really slow. It would put a lot of pressure on the garbage collection. And it would kind of, in many ways, like defeat the point of using Rust, which is I want to have fine-grained control over memory allocation and performance. So what we're going to do instead is on the WebAssembly side in Rust, we're going to create a huge array of memory. And now on JavaScript, we're going to actually just call a function like, hey, Rust, can you create the game world for me? And this will initiate all of the, or initialize all of the data structures, the world, the players, etc. And then it will just pass back pointers to JavaScript side. And these are very, very small. And now JavaScript is going to just call functions using these pointers, and Rust will update everything. And then JavaScript will be able to just reach into the memory and see the result. And this is nice because JavaScript has so many things that we take for granted, right? Access to DOM, to garbage collection. Like, you have objects. Objects are cool. You have arrays and strings, like things that you don't feel are very special, but whenever you don't have them, you really miss them. Whereas on Rust, you have all this nice performance and memory management, but you don't really have objects. You have like structs, and you have arrays and vectors, and you have two kinds of strings for whatever reason. Rust people will say they don't. I will say they do. So what we're going to do is have this shared memory between them. JavaScript will call into Rust. Rust will update the memory, and then JavaScript can read that memory. So we have this nice cycle flowing, a bit like React, maybe. And that means that we can make sure that we only pass small bits of data between the JavaScript and Rust side. And everything is able to actually kind of exist inside of the uint8 arrays. But we still have to, on the JavaScript side, even though we can read all of those bytes, it's still unpleasant. We have to figure out how to construct strings and booleans and whatnot from them. But the Rust people are aware of this. And they have built phenomenal developer experience. So what I've done here, this is the game of life written in Rust. I have a cell, which is an enum. A cell in a game of life can either be dead or it can be alive. And I'm saying, hey, Rust, I want you to represent this as a 0, and I want you to represent this as a 1. The rest of the world shouldn't know, but I care about how that's actually implemented in memory, because I need that for performance or whatever. Now, every tick that gets called from JavaScript, I'm going to iterate through the entire board, and I'm going to get a list of all the neighbors around a cell. And now I'm going to match. And you can see this pattern matching again, where I'm matching off of 2 items, which is really cool. And I can say, hey, if this cell is alive and the number of neighbors is less than 2, then the cell should be dead, and so on and so forth. So in this one line right here, or this one chunk, I can concisely encode all of the rules of the game of life. It'll be type checked, and it will be immaculately laid out in memory. Now, what Rust is going to do, as part of this, as an automatic part, whenever it generates the WebAssembly code, it will also generate an npm package, so that you, on the JavaScript side, will be able to pull in all of those functions and call them. But not only that, remember that Rust is statically typed. It has intimate knowledge of all of the types in your application. So it will also generate TypeScript bindings. But not TypeScript bindings like I would write, where it's like, oh, it's any, I'll come back and fix this later. It writes them as though I were a really good programmer. So now we can come in here, and let's take a look at what this actually looks like with a real application. So there's a component library, or there's a library called U, and U is inspired by Elm, except that what it's going to do is you will have a JSX-like syntax. You'll have service workers that will get spun up in the background automatically to handle concurrency. And Rust is going to guarantee that you have data integrity, no race conditions, all throughout the entire experience. So you just write a normal Rust application, you compile it out, and you're going to get all of these benefits. So this is what it looks like to write a component using U. So you can see I have this HTML with a bang. This bang is really cool. Bang means this is a macro. It's like a Babel transform, but it's built into the language. So any library author can ship a JSX type of thing as part of their library. They can bring the language into their domain and make it much more accessible. And so this library has actually implemented their own HTML macro. And all of these props here are actually typed. So if you pass in the wrong type or you have the wrong children, it won't compile. So this is like an amazing experience to actually write HTML inside of this low-level language and have everything typed and compile out nicely. But then we have maybe events. So imagine I have, in my core loop of my application, I have a request. So I'm going to send this off to the service workers, or they can send it to me. And the response to it should come back as an answer. What I'm going to do is, whenever I receive a signal, I'm going to match over that and say, hey, if the signal was a question, then pull out the body, and then send an answer to this saying, hey, that's cool. And what this is going to do is this won't compile, because the message might also be a response. And also, if I add, for example, maybe I have a question right now, but maybe I want to add a demand later. Then if I add that in, everywhere that references that will break. And I'll be able to go through and fix everything once, compile it out, and it will just work. Now, this is what it looks like if you're actually consuming the generated Rust from JavaScript. So right here, this import memory, this is the big bit of memory that we talked about that the Rust compiler generated for us. So we're going to pull that in, and then we're going to initialize it as just a big array of bytes. We don't really care. But But from then on, we're going to say, hey, get the cell at this index. And if that cell is dead, then I want you to draw a dead color, or else use the alive color. And the thing I love here is this dead is actually the enum that we defined in Rust. So we don't care if it was 0 or 1, or true or false, or A or B. It doesn't matter. We get to code as though someone were a really good programmer on the other side, and they gave us this really good API. And that's all generated based off of the deep knowledge that Rust has about your program. I'll give a quick aside about the syntax. I mentioned before that Rust is a bit more verbose, but it is also very heavy with symbols. So just be prepared. But the nice thing is they care so much about developer experience and onboarding that the error messages will oftentimes navigate you out. So for example, here I have foo, it takes a b, which I said is a mutable, unsigned 64-bit value. I'm being very specific about what I want here. And it's like, hey, you are trying to borrow a mutable value. You can't do that. Maybe you should try just removing the and mutable. And what happens is it guides you out of this problem enough times that you start to develop kind of a muscle memory about what is this symbol actually doing. So I want to give one demo of what this actually looks like. So this is an NES emulator written in Rust. And it is super fast, super cool. If we open up the developer tools and we take a profile, you can see that the animation, or sorry, each of these frames is tiny. It's incredibly performant. It's very good on my battery. It's in fact been running in the background for quite a while, and my battery is still doing fine. But the cool thing is, with Rust, you can also compile out that same application to a native application. So this is it running using SDL instead of WebGL. And this is Super Mario Brothers using the same code that's type checked. And you can run this on a desktop or a mobile, or you can compile to the web, as we saw with the other example. And then there are some pretty other crazy things that are happening. So in particular, this idea of WebAssembly, like I said, is crazy well designed. And someone has actually implemented a WebAssembly to Rust compiler, so kind of like a decompiler. And someone actually, there's a subset of TypeScript called AssemblyScript, which is how TypeScript people go to WebAssembly. It's kind of the non-allocating subset of TypeScript. And someone wrote a really cool Game Boy emulator in that. And they compiled it out to WebAssembly, fast and cool. But then someone took the WebAssembly to Rust decompiler, turned that into Rust, and then they took the Rust code and compiled it out to a native application. So it's kind of a crazy pipeline, but like the future seems very exciting. And I'm going to end on this note that I think that we are actually, Rust and WebAssembly represent an unprecedented opportunity in our industry. Because our industry only moves forward via secretion. If there is any abstraction or any implementation that is even a little bit successful, it never dies. To that point, I have a terminal in my computer. A terminal is an endpoint, like a keyboard, that talks to a mainframe, right? And my terminal understands crazy old escape codes, but that can never go away. We are stuck with it forever. And we're also stuck with, like, libc. And libc has caused unprecedented amount of good, but also tons of security issues. It has been very difficult to actually ship anything reliably with it. And WebAssembly and Rust mean that we actually have a platform that it's not in our best interest to ship all of Linux, all of libc to the browser. We need to have a new, smaller implementation of these things. And maybe we can do it in a safe language that's also fast and also correct. And that could be Rust. And I actually think that in the next 5 to 10 years, most of the JavaScript that we run will be written in Rust. I don't think most people will write Rust, but I think that most of the code we run will be. Like, who will actually write it? It's the people who really want fine-grained performance control, and the people who want safety, security, and correctness guarantees. And this is largely library authors. Right? To what extent does the React authors or Vue or Angular have to go through to eke out all of the performance and correctness. And so they're under tremendous pressures to actually do this, and they need tooling that helps them. And I think that's likely Rust. And I actually think that WebAssembly and Rust will also end up going to Node, where you can actually pull in all of these implementations of great Rust libraries that are already compiled out to WebAssembly, and it will just work inside of Node. No more libsass compiling C++ nightmare. So here's my closing pitch. Working with Rust, at least in the beginning, is like banging your head against the wall, but at a very slight angle, so that every time you hit the wall, you actually make a little bit of progress. And at the end, you actually look back at this blood-stained wall, and you're kind of happy, because you built a thing that you didn't think was possible. All right, here are some links, but otherwise, thank you.
Sean Grove, thank you so much. I will just remind you that he will be speaking tomorrow at the chat zone at 5:30 p.m., so you can ask him some direct questions. And we are heading towards our last talk of tonight before we will go have more fun and do a little more networking. Our next speaker is Boris Litvinsky. He serves as the tech lead at Wix, working on products empowering over 190 million websites. He's also an open source developer, and his spirit animal is Rick and Morty. Please welcome Boris Litvinsky.
Oh, hold on. All right. Hi, everybody. My name is Boris, and I'm tech lead at Wix. And today I start by telling you a story. So a few years back, my team started working on a first project that used React after a few years of doing Angular. And just like many of React developers, even to this day, we were faced with this crucial destiny-changing, altering dilemma of which state management library should we be using. And of course, the obvious options were Redux and Mobex. And so we began our journey for the answer by gathering the whole team and having a discussion. But we quickly discovered that basically none of us had any experience with React, let alone one of those libraries. And so what we decided to do is basically spread out, do our individual researches, and then reconvene in order to make the actual decision. But then we remembered that we actually worked at Wix, full of super talented, genius people, and many of whom actually had the experience we were lacking, right? They did work with React. And so what we decided to do is like gather a council that will actually help us make the decision. The problem was that we actually ended up with so many opinions and so much data that we really had a hard time wrapping our heads around that. And so what we ended up doing is actually creating a decision matrix that will help us make the decision. The problem was that this whole debacle took us 2.5 weeks, right? And all the while, we haven't written a single line of code. And why? Well, because in our mind, this decision was so critical that it had to be made right there and then. Like, we've seen no way for us to build a React application without a state management library, right? Because this is what everybody was talking about. And the way we saw it is that if we would have gotten that wrong, we would be stuck and be paying for this mistake forever and ever.
And we were wrong. Because to this day, after more than a dozen of React-based applications of various complexities, that application is the only one that uses any state management library. Because humans, when faced with a decision to be made, usually we see only two outcomes, right? Two categories of outcome. We are either getting it right or getting it wrong. But the problem is that the stress of getting it wrong actually blinds us from the fact that we usually are missing crucial pieces of information to make that decision. Okay? Just guesses. And so today I'm here to tell you that in cases where you don't know whether the decision you're making is right or wrong, there is a third option. And the third option is to postpone the decision as long as you can in order to gain more information. Otherwise, that decision can have crippling implications on your project. So let's start by talking about why we should be postponing our decisions. So usually, when you start working on a project or an application, right, you usually have some sort of architectural review, a design review with your teammates. And the question is why, right? And I think that the reason is rooted in this definition by Martin Fowler of what architecture really is. And he basically defines that architecture are decisions that we wished we were gotten right early on. And why is that important? Well, because decisions made early on are harder to revert, and they serve as a foundation for the rest of the application we're going to build. So the conclusion here is actually that the more decisions we make early on, the bigger the impact they will have on our code. And yet, whenever we start any kind of application, we usually start by stressing ourselves with tons of decisions to be made. Which framework to use? Should we use CSS in JS or Sass? Which database? How many node modules will we have? And so on and so forth. But the question is, are all those questions architectural, right? Should all of them be made at the beginning of the project? Because the truth is, like, the decisions we make at the beginning are usually not based on facts, right? Most of them are guesses. So what are they based on? Well, they can be based on various things, right? They, for example, can be based on hype. So I've seen some talk, I've read some blogs, some tweets about this cool new thing, and now I'm super eager to use it. They can be based on biases. Perhaps in past, I've tried some approach or some tech, and it ended up being a disaster, and now I'm completely against using it ever again. It can also be based on, on ego. How many of you have been part of discussions where somebody actually treated it as a competition, and all they wanted to do is win? It doesn't matter if they were right or wrong. No, the other reason is that I think if there is one thing front-end developers love to do, is NPM installing stuff, right? This is basically warms our heart. Because it gives us the bragging rights, right? We like telling our friends that we got to use this new thing. But most importantly, I think we love the feeling of instantly solving a problem, right? You are faced with some issue in your code, you npm install some package, boom, the problem is solved, and you are a hero for a day. But what about the performance penalty? What about the onboarding that is now way more complex? And most importantly, how can you be sure that this thing you just installed at the beginning of the project is actually the right tool for the job? And one of the reasons that it can be a wrong tool for the job is this thing. This is called the hype cycle, right? You can look it up in Wikipedia. And basically, this graph describes various stages of hype that each technology goes through, right? So first, the technology is being erected, right? It comes into existence. And then it's being discovered by early adopters, right? Some influencers, who basically start blogging and giving talks and doing demos and all that kind of stuff, and basically getting more and more people on the hype wagon, saying like it's the best thing ever. But then, as time goes by, maybe critical issues are discovered, right? Maybe, I don't know, maybe it doesn't deliver on its promise, right? And then people basically abandon the technology. And while it dwells in this pit of disillusion, maybe it's being improved, maybe it's being discovered by new audiences who actually find more suitable use cases for it. And only then, after all that time, does it actually become useful. So the conclusion is the more we postpone an adoption of a technology, the higher the chance that we're actually picking a right solution for our problem. Unfortunately, requirements change, right? This is the unfortunate reality of our existence as developers. The problem here is that the code we write, our architecture or design, should actually be optimized for those requirements. So the more we delay decisions, the more basically we will give time for those requirements to stabilize, and the higher the chance that actually our code will be better suited to support them. So given our inability to predict the future and given the fact that we usually don't know whether the decision we're making is right or wrong in our code, our best option in those cases is basically no decision, right? This is the best decision we can make. Because then we will basically allow ourselves to gain more information before we actually make it. And as long as you don't make those decisions after an optimal date, this will be your safest option. So next, let's talk about some things you can defer. So let's start at the very beginning, right? At the beginning of your feature, somebody approaches you, and they ask you, how long will this thing take, right? And what do you usually do? Same as you just give out a random number, right? I feel like 3, maybe 4, I don't know. That's cool, right? You get people off your back. But the problem is that those estimations are fake, right? And fake estimations lead to fake deadlines. And fake deadlines lead to late delivery, which then leads to suffering. So we should try to base those estimations on some facts, right, and not guesses. And we will talk about some things we could do to improve that. I love this quote by Dan Abramov. He's talking about state management libraries. Now, you don't go buying glasses before you had trouble reading, or I don't know, before you started waving at random people on the street. Same goes for any kind of library, right? Before you npm install something, you should first encounter a need that library potentially solves, right? And even afterwards, you should see if there is a simpler solution within your code. And then you should also ask whether or not it's an actual issue or a design problem, right? Because in our case, whenever we thought that for reaching for a state management library, it was actually a design issue, and using simple techniques like lifting states or using tools provided by React, like context, usually solved the problem for us. And I think today it's even more so because of hooks. I think many of us, for better or for worse, are library developers at heart, right? Are open source developers at heart. And that's awesome. But I think on our day-to-day lives, this basically manifests in our love for creating super generic Swiss knives, one-size-fit-all abstractions, right? If maybe React component or just functions, right? That should solve world hunger and so on. And most importantly, keep our code dry, right? Without repetitions. But if you create those abstractions prematurely, how can you even be sure that you're actually covering all the use cases? How do you know if there are other people on your team that are facing the same problem? Are you solving their problem? Okay? And maybe there are competing solutions in your code already that you can use? Those are the questions that you should be asking before creating any kind of abstraction, right? You should first understand the use cases it needs to handle, right? You should understand how the code is being used before wrapping it in a nice abstraction. One of the rules that I like to follow is something called the rule of 3, which basically states that you should wait for a third copy of the code in order to have a better understanding of the use cases and the API. one of the biggest fears that I have is to see my code deteriorate into something called a big ball of mud, right? Which basically means that my whole app is just a big pile of crap, of tightly coupled code, unpredictable code. And I think that this fear actually leads us into reaching for like heavy guns and heavy tools, namely immediately breaking our application into tons of node modules, breaking it into microservices or micro frontends. And this has a lot of benefits, right? Because what this creates is basically this impenetrable wall between various parts of our application that actually allows us to control how each part interacts with another. But this also comes at a cost, right? Namely, that now integration testing is a nightmare. The deployment of our application is super hard, and the ownership of each part becomes super vague, right? But most importantly is, how can you even know that the boundaries that you have created in your code at the beginning are actually correct? So we should wait to gain more understanding about our organizational and business domain before we create hard abstractions, hard boundaries, because otherwise it will be super hard for us to evolve them and change them when things actually change. So the problem with deferring decisions is that it introduces uncertainty, right? And uncertainty introduces stress. And what will be super helpful is if we could turn the postponing of decisions into like an actual process. A process that will help us, A, understand whether or not we should be deferring a certain decision, then define when will that decision be made, and hopefully allow us to revert it if something went wrong. And I'd like to show you one of the processes that you could be using. It's called real options. It's a concept ported to software from finances. And basically, it's defined as follows. It's the right, but not the obligation, to take some action prior to expiration. Now, this sounds like a huge mouthful. So let's see an example from our day-to-day lives. I've recently visited Japan, which was unfortunately hit by a large typhoon. And what was really useful is that I've booked some of the hotels with free cancellation option. So basically what I've done is I've paid extra in order to create an option for myself to decide at a later date whether I'm going or not. Now, if I were to cancel it prior to the defined date, I'm basically losing nothing. And if I will simply not show up, I will lose the whole booking fee. A more technical example for real options is feature toggles or feature killers, A/B testing systems. Basically, what they allow me is to deploy my code to production and decide later whether or not my code will run in production, who are the population that will be exposed to that code, and it will also allow me to turn that code off in case something goes wrong and do it remotely. Now, Chris Matt, a guy who invented basically real options, goes on to define them using 3 key principles. The first principle is that every option has a value. Okay? And that makes sense, right? The fact that I can decide something later on has a value for me, right? And that value is determined by the amount of uncertainty and, of course, the cost of creating that option. The second principle is that every option expires, right? So if I will basically delay my decision too much, a certain option will become unavailable to me and I cannot utilize it. And the third principle states that you should never commit early unless you know why. So what real options basically give us is reduced stress when delaying decision. Because first of all, instead of just saying I will postpone it indefinitely, we are forced to define a condition when the decision will be made. Now, this condition can be anything, right? It can be a date or perhaps a discovery of a missing part of information. It also forces me to think whether or not I should be delaying the decision, right? Because if the value of an option is low, perhaps because it's easily revertible or the decision is very low impact, there is no point in me deferring the decision, right? I can just make it right there and then. And most importantly, I think it forces us to gain and keep seeking for more information before the decision is actually made. So now let's see some things that we can do in our code in order to create options for ourselves. Gleb had an awesome talk about testing, and I'd like to reiterate how important testing is. So I will talk about TDD, test-driven development, which is basically a software development process that states that you should first write the test and only then write the code that will make that test pass. And when you do that, you should make no assumptions about the code and write the minimal and the simplest code that will make that test pass. Now, what that gives me is basically, it forces me to make no assumptions about the code, about the implementation, and it also prevents me from over-engineering, right, based on guesses. And once the test passes, I now have a safety net that basically allows me to revert my decision and to change my mind if I choose to do so. But I will know for a fact that my unit or the whole system still functions. The next thing is Spike. Now, Spike is basically a potentially throwaway code that we are writing in order to explore a potential solution to a problem we're facing, right? And what that gives us is basically it allows us to gain more knowledge about the technical and the business domain, and that comes really useful when we are forced to give estimations, right? Because now, instead of just guessing stuff, we can sketch some code and gain more knowledge and then give away more accurate estimates, right? This is also super useful when you're thinking of adopting a technology, right? Because now you have a concrete problem, and you can take that technology, right, and try to solve that problem with the technology, right, instead of just playing with it in the code sandbox, for example. Now, this sounds like a little bit of a waste, but it pays off really quickly. So boundaries are important, right? I think we all agree, right? But the problem is that we've discussed that if we'll just split things immediately into node modules, and those boundaries are incorrect, it will be practically impossible or very, very costly for you to basically change those boundaries later, right? So a concept of modular monolith actually comes really handy, okay? And it's basically defined as follows, right? Basically, the idea is that your whole project is basically one big code base, right? It's one code project that is basically divided into folders. Again, not node modules, just folders. Each folder is a business unit, right? One that handles billing, for example, one that handles users, orders, whatever it may be. And each folder has a file that defines its public API, right? Think about, I don't know, an index.js that basically exports all the public functions that we want to allow other parts, other components to be using, right? Now, this is still one code project, so basically other folders can import whatever they like. So this is where tooling comes in handy, because you can use stuff like linters, custom rules to enforce that basically the public API of each component is the only thing being used, okay? So what that gives us is basically it gives us the same boundaries, but it allows us to evolve them easily. So postponing decisions is useful, but like everything in life, it comes at a cost, and we need to be aware of those costs. So as we discussed earlier, if you postpone a decision for too long, you may lose viable options, right? Viable solutions. One of them perhaps may be an optimal answer to your question. So you need to be really careful. If you're part of a team that makes the decisions, right, and you're postponing something, it can not only affect your team, but it can also get other teams that depend on you to get stuck, right? For example, if you're creating something that should be consumed by others. And you need to be really aware of that as well. Now, in order to be able to postpone decisions and create options, that means that our code needs to be flexible and easily changeable. And that, unfortunately, usually means that it becomes way more complex. Okay? And you need to be thinking whether or not it's a cost you're willing to pay. And finally, it's stressful. Okay? And if you are postponing too many decisions, it may cause you to make rash decisions just to get rid of the headache, right? To make real suboptimal decisions. So here are a couple of takeaways that I'd like to leave you with. You should never commit early unless you know why. You should always ask yourself whether you have enough information to make the decision right there and then. And if you will choose to postpone your decision, you need to create options for yourself using stuff, for example, like modular monolith or testing, which is also great. And of course, be aware of the costs and think of them constantly. That's it. Happy procrastinating, people. Thank you.
Boris Litvinsky, thank you so much. And we have some questions for you, Boris. You said that you like them, so that's a good thing. Do you use micro-fronted? What do you think about this hype?
I think, just like everything, it's a tool for specific tasks. They're super costly. We use them on several products, but basically it comes super handy if you want to have one app and have different teams be basically owners of different part of that app and have them move quickly. This is what we use it for. So imagine an app, a team responsible for a certain page, and they want to deploy that page independently without basically deploying the whole app. So this comes super handy. We're using it. Again, it's a solution for a particular problem. Okay, that's all there is to it.
What kind of services do you use for feature toggles?
Yeah, so we have basically our own system called Petri. It's open source, Wix, GitHub, Wix /Petri. I will tweet out the link. Again, you can A/B test stuff. You can just use it for feature toggles. Super awesome. Use it, open source. You're welcome.
And the last question, are you using canary testing for decision making?
Yes, sometimes. Mostly our products do it. It's an effective tool, and yeah, like we do use them occasionally.
And then I have a question, Rick and Morty, which one is your spirit animal?
Both of them, of course.
Both of them.
You cannot discriminate, come on.
See, he doesn't make a decision. He's going to make a deferred decision about this later, I think.
Never.
All right, this was Boris Litvinsky. Thank you so much. If you have more questions for him, make sure you catch him. And before you go off to have fun, please pay attention to me for a little bit longer. Wow. What did we experience today? We had 18 talks, 4 lightning talks, 2 blocks of chat zones with 9 speakers and panel discussion. We started with opera today. Who was here in the morning? Raise your hands. That's a lot of people. I want to let you know the song that we were singing is called Song to the Moon. It was written by a Czech composer, Antonín Dvořák, and it's sung by a little mermaid when she's singing to the moon, hoping that the prince will come. There are so many princes here tonight. Anyway, what did we learn? We learned, besides all the interesting things, we made new friends, and we learned from one another. And also, we learned that 10 minutes of workout and stretching can be better than 10 doctors. Please don't forget to rate our talks. As I said before, it's very important for the speakers, it's very important to us, for the whole Reactive team, because that's how we become better, that's how we improve. That is not all. Tonight we have Reactive by Night, as you know. So, if you haven't won an invitation to a party, don't you worry, and come to the party at Economia next door. I will be there for sure, so you can come see me and meet me too. Maybe you want to go and see Prague, which I recommend you to. We have Pride Tech Scene Tour and beer that is provided by Pipedrive. And then here is a whole schedule of things happening tonight. So the afternoon party, the evening party, it's 6:45 p.m. at the Economia. 7 p.m. the sightseeing is starting. And 8 p.m. are all those parties with our partners that you already hopefully signed up for. Don't forget about our night. That's Omar. If you have any questions, don't hesitate to ask him. He's running around. Text him. Thank you so much for being part of this. And as I said, there is a space around, or here's his cell phone number. So please write messages in there, draw pictures, whatever you like. And more importantly, see you tomorrow, so don't get too crazy tonight. Thank you for listening to me, and have a great night.